Hello. Ooh. eye, right?
That's
Think medium in between vapors, particles, all that stuff, right? That causes things to be obstructed. When we talk about the atmos, dude, like you're contending with the atmos between you and 10 miles or 2 miles or 1 mile, right? So things start to disappear bottom up because of refraction. That's the whole
Yeah,
thing, dude. That's
we're
what he's
talking
talking.
about perspective, not refraction.
Yeah, no,
yeah.
but
Look, can
perspective
I
alone
just want
is
to add
hold on.
something.
Perspective alone isn't sufficient, right, to make things disappear bottom up. I'm granting you that. I agree with that, right? In a vacuum, you would expect things to just blink out, right? They get so small that you can't actually resolve the angular resolution, right? Your eye isn't capable of that. Optics only have a certain limit to be able to resolve that angular resolution, right? It would just continue to move forward and forward and forward. But because of the atmosphere, right, things start to disappear bottom up because refraction is actually the reason why things become obstructed bottom up, because the light rays near the bottom of the object are arrested by the atmosphere itself. They refract towards the denser medium, right, which is towards the earth, and crashes into the surface of the earth. And they can't actually reach the observer's eyeball. That's it. We've demonstrated this in the lab.
Yeah, I think you just, well, it's the opposite of what you said. They
I'd
bend
like
towards the
to.
denser medium, but that
Hey,
doesn't cause
Pinky,
sinking refraction.
I just want to
Light
add
bending
something
up
to what
causes
Lion
sinking
was
refraction.
saying. Yes, that's correct. Light bending up, down. I just want to make one point really quickly, and then I'll go on mute. Okay, so in the live stream text, I just posted this sky-free observation. What they do in here is they introduce cooler air up higher. So you were saying before, obviously it gets cooler as you go up higher. Now, in this is a smaller scale demonstration, so we have apparent downward obstruction of things. So all of a sudden we have a flat floor, and then it looks like things are sinking behind the horizon formed on the flat floor. Okay, and that's because the light is deviating towards the cooler air because it's more dense. Now you're saying how come a mountain can look a little bit lower off in the distance? Because you have the exact same situation that's happening in this observation. You have cooler air up higher, warmer air down lower, and you have something looking like it's sinking a little bit in the distance. It's the same thing, and you just said that happens. So,
Well,
I
that's
don't
a
know what the
specific
confusion
claim. You're
is.
saying the Gaspard observation happens because of sinking refraction. So if that's a
Sorry,
specific
what
claim
happens
you're
because of
making,
sinking?
then you'd have
No,
to
no,
back
this is
that
what
up.
I said. Yeah, I can back it up. I can give the
And you did say it was
citations.
perspective, by the way. You did say that.
No. Perspective. Look, perspective is just something that happens. I never said it appears lower because of perspective. I said it
Yeah, but
appears
neither did I.
reduced and more towards your eye level because of perspective. It's not going to look like it's way up in the sky because it's higher, because we have perspective, and it's reduced so much in angular size, it's going to go towards your convergence point, like Lion said.
Yeah,
All
but
I'm
that
saying,
wasn't my point. The point I made that you responded to, I didn't say that. I didn't say that it should appear way up in the sky. I just said if it's taller than you, you should never have to look down at it ever with perspective.
Yeah, with perspective alone, right? That's just one of many factors.
right?
You
I
have
know,
to,
but I
yeah, you
said
have to
why.
contend with.
Okay,
Okay, so you have
fine.
to
I said
consider.
why are you
Hold
looking
on, dude.
down
You have
at
to
it?
consider.
And he said
You have to.
perspective.
You hold on, dude. You have to consider perspective. You have to consider refraction, Rayleigh's criteria, and the light attenuation. All these things is why we see things obstructed from the bottom up, and why they seem to dip below the horizon, the axis of the center of the axis of the eye.
I know, and you said that for Gaspard, because the air's denser, closer to Earth, light's going to bend downwards, and that's going to make it disappear bottom first, right?
Well, yeah. So if you look at Andrew Thomas Young's paper, right, you have 4 different types of refraction. Besides, I mean, exclude cosmic refraction, all that. So we have above the horizon, you have towering and looming refraction, superior
We went through
mirages.
this earlier already.
Okay, okay, I understand. And then below the horizon, you have what? You have stooping refraction and sinking refraction, right? Stooping is where it looks like it's compressed, right? Things seem to start getting compressed as they go towards a convergence point.
Yep, like
All
the sun.
these different types of refraction can be caused by light bending towards the same exact direction. Now, I know in the globe, you guys say, oh, no, it's depending on whether it bends up or bends down, you're going to have different effects. What Andrew Thomas
that's what
Young
DJ
actually
said.
showed, yeah, I know this is the common consensus. But what Andrew Thomas Young showed is that actually, depending on the rate of refraction, right, where light can be bending the same exact direction and can cause all 4 different types of observations. Towering, looming,
I don't think so.
sinking, and stooping.
Look at this. Look at this picture. This was a thing that was going on, I think, in the earlier days of the fluttered stuff with Jenna Fredo and the CN Tower from across Lake Ontario and Alcott, New York. And the CN Tower, right? It's a huge object, right? Like 1/3 of it is completely missing, as well as the Toronto skyline. The majority of the Toronto skyline is missing. And you know, that particular region, you can go out on days where the air is a lot hotter than the water. You can go out on days where it's a lot colder than the water. And yet there's never a time that you could go out there where the refraction works in any way that you could ever see, you know, really more than 2/3 of the CN Tower or the Toronto skyline. There's never a day you can go out there and then see, you know, and see the normal Toronto skyline. So what is happening there? Even though you can go out in a day when it's 100 degrees out and the water is, you know, 55 degrees, or you can go out in the wintertime when it's like negative 20 degrees in the air and the water is, you know, a few degrees above freezing. There's never a situation where you can ever see that skyline.
Yeah, refraction is not your friend, dude.
The kryptonite for the globe.
Refraction is not your friend. You understand why? You understand why? I know you guys love using refraction.
Understand. I mean, you're saying that no matter what the temperature gradient looks like, there's always going to be like 1/3 of the CN Tower missing from 40 miles away, right? Like, I don't understand.
Dog, do you understand that refraction is why we can't see as far as we normally can see? So visibility increases when refraction goes down. You guys are saying visibility increases when refraction goes up. You have to say that, because when we can see way more, right, than what's geometrically possible, you guys say, oh, it's because of refraction. But actually, no. Visibility increases when refraction goes down.
Yeah, true. And infrared debunks them. Infrared observations, they debunk their claim that that refraction will make you see farther. No, because infrared, it reduces the refraction effect. So less refraction with the infrared filters, we see farther. It's against your claim, meaning that you're wrong.
Yep. So he gets it.
So is there a day where you can go out with an infrared, camera and be able to see the entirety of the Toronto skyline from Alcott, New York?
Well, you're limited, dude, because it's not like we're looking through a vacuum. Even on ideal conditions, right? Wait
a minute, we're seeing the top of the tower and the buildings, which are further away than the bottom.
No,
yeah, I know this, bro. I'm trying to explain to you. The reason why you can see the top and not the bottom is because the bottom, right, is closer to the surface of the earth. The closer that you are to the surface of the earth, it's no difference than when you're out in the ocean. You got the marine layer to contend with, right? You have dust particles, you got evaporation, you got heat rising from the surface of the earth. That's going to cause light to be arrested, right? Arrested in what? Diffused or hit the surface of the earth, never making it to the observer's eye. So that's why
that's not what we're seeing. We're not seeing
when you have a skyscraper, when you have a skyscraper, you would expect, right, that the bottom of the skyscraper would be obstructed first.
Okay, so if what you're saying is true, then what we should expect to see is that the top of the building would be clear, and then there would be like a hazy area, like when a building is rising up out of the fog, and then you would see the water below. But what we see is a hard water line that cuts off everything above that, right? That we can clearly see the objects above the water line. We don't see some hazy region of dust and whatever bullshit marine layer that you want to bring in.
That's
that
not
would cause
bullshit,
a haziness.
Bro.
That wouldn't cause that wouldn't cause a hard delineation, right? That wouldn't be. It would just be fuzziness.
That's just you saying, nuh-uh. When you know for a fact that at the surface of the earth, it's the most chaotic, right? That's where all the evaporation's happening. That's where all the heat's rising from the surface. That's where all the dust is at and all the pollen and all the fucking particles, right? So obviously, light that's reflecting off that fucking building, the closer it is to the surface of the earth, the earlier it's going to get obstructed. Dumbass.
So from Carlsbad, California, when the sun is setting directly behind Catalina Island, which is almost 2,000 feet high at the highest point, and we still see the sun directly set into the water, we never see the silhouette of Catalina Island from Carlsbad. What's causing that? How is it that we're seeing the sun get cut off by the water as it goes away, and we never see the silhouette of the island that's in between? That's like 2,000 feet high. What's causing that island to just disappear?
We've been
Yo,
over this
somebody else can
before.
take this. I'm not trying to lose my
Yeah,
temper.
I've looked it up. We've had this same conversation, and we looked up the average visibility for that location, and it's way below the distance that you're talking about.
But we
And
can
you
see
can
the sun. So if something is blocking, if something is
yeah,
between the sun, why wouldn't you see the silhouette of it? Because if we can see the sun, obviously we can see far enough to see the sun, right?
all right. So because the sun is up in the sky, it's extremely bright, and the light coming to you from the sun is much more powerful than the dim light that's just reflecting off the things that you're talking about and trying to push all the way through all of that atmosphere to make it back to your eyes. It's not possible. But the bright light from the sun, right? It's like the Canigou one. Okay, when you look out, you can't see Canigou on that particular day at all. And it's not until the sun goes behind it and that bright light from the sun is powerful and push through all of that air and make it back to your eye. So then all of a
So
sudden
we're seeing the
you're like, oh, there's
silhouette
shit. There's a
there.
mountain there that the light wasn't making it back to my eye from, but now we have a brighter light source. We can see the sun.
So we should be able to see the island then, right? Just like Canigou.
Like
Well,
Canigou,
is
like
the sun,
refraction
if
is
the sun,
conspiring.
is the sun setting right where the island is? Do you have footage of it? I don't think you have any footage of this.
Certain times of year, the azimuth of the sun directly in line with where the island is supposed to
Okay,
be.
we'll grab that footage and that'll be cool to go over that.
It's just
You know,
one of those
when you
things,
have-
man.
It's just
one of those
for
where you don't
Canigou,
have
it's
footage
just
to back your claim.
it's just a coincidence. Refraction is just conspiring with the time of the year, so you can see Mount Canigou every time. Refraction is the same, so meaning that the temperature is the same, everything is the same, so you can see Mount Canigou like that every time, every year.
Refraction's conspiring.
Yeah,
Conspiring
refraction
with the flat
conspiring.
earthers to hide the globe from the globers.
Yeah, it makes a rendezvous with the mountain and the sun. Oh, look, I will be there during that time of the year, so just try to not be late. So it conspires with them, so you can see that effect, that phenomenon happening every time, the same time. Yeah, it's just a method of coping. Typical globers. What do you expect? You just explain to them that when you reduce refraction, expecting to see what you globers are claiming, that with the refraction you see less. When we reduce that refraction effect, we see farther. Why do you want to jump to some mountain? Why I don't see the mountain when the sun? Oh, okay, so it already opposite of what you just claim about refraction. We don't care about the mountain. Refraction won't do that because we see it. We tested it. More refraction, you
I
see
mean, it's
less.
pretty. This is pretty
Less
common
refraction, you
sense,
see
bro. Like,
farther.
yeah, the more refraction, the less visibility, dude.
Yeah,
This is predominantly the case. You know, light tends to bend towards what? The denser medium, predominantly, right? Now, granted, there's some anomalies. There can be like a super mirage due to internal a boundary layer, inverted boundary layers, and internal reflections and all that. But predominantly, light bends towards the denser medium. Where is the denser medium at?
And why are people
Wait, hold on. Where's the
comparing-
denser medium at? Usually, normally,
Normally, it's always
towards the surface of the Earth, right?
towards
At
the
sea
Earth.
level. That's where the denser medium is at.
This is but Lion. This is where the globers actually screw it up because they're sure the PSI is higher, lower, but if light bends towards the denser medium, that means it's downward bending light, which makes things loom up. It makes things look like they're higher, and that's what their claim is to explain these observations. But what's actually happening and what mainstream optics says is that it's about the optical density. The optical density is controlled by the temperature of the air. So if you have warmer air down lower, and then you have a layer of cooler air above it, the light's going to bend upward, and it's going to cause things to look like they're sinking, look like they're going down, because optical density is king when it comes to the refractive index, not this vast gradual change of this atmospheric density that reduces with height. Because the amount that just say it's 14.7 psi at sea level. Let's say we're standing at the ocean. It's 14.7 psi at sea level, and we've got a P900. We're looking at an oil platform that's 9.4 miles away. The density over that 3 or 4 meters from the ground up, it barely changes. So that natural change in the density gradient, it's F all of an effect. What completely dominates is the temperature gradient. So if you've got much cooler water, it's going to make a layer of cooler air down lower, and then it's going to get gradually warmer as you go up. Then you're going to get some looming, right? But if you've got the warmer water, then you're going to get the opposite of looming. You're going to get sinking, and the globers conflate the natural progression or decrease of the refractive index to the psi of the air, but it's dominated by temperature, according to all the experts.
Yeah, that's what I was talking about. Yeah, inverted boundary layers, where those are anomalous situations, though. Predominantly though, what we have is the denser air at the bottom and the lighter air at the top. That's universally the case. But you'll have like specific locations like near the Straits of Gibraltar where you can have more calming superior miraging, where you won't see that anywhere else in the world except at the Straits of Gibraltar, because for whatever reason over there they have the conditions needed to actually have that effect. But that's not normal. Normally you just have refraction making visibility impossible to beyond a certain point. Light does tend to bend towards a denser medium. If you have this inverted boundary layer, light can bend up in those specific scenarios or locations. But the point is that when you have light bending down towards a denser medium, that's towards this crust, that's towards the earth. So when light bends down towards the earth and hits the earth, it can no longer reach the observer, and the light closest to the surface of the earth is going to naturally bend down towards the denser medium, becoming arrested and completely diffused when it hits the earth. No, that's why things disappear bottom up, because the bottom of the objects are obviously closer to the surface of the earth, causing them to be obstructed first. Plus perspective, right? It's called the viewing angle. Things become obstructed bottom up. That's just so a combination of refraction, perspective, light attenuation, Riley's criterion, Fermat's principle. When you factor all these things in, that's how you end up with bottom up obstruction. That's how you end up with the sun disappearing. When due to perspective alone, right, the sun shouldn't just disappear the way it does. But we're not dealing with just perspective alone, guys. Go ahead.
Jeremy, you still here?
Oh, I'm here. I'm always here. What's up?
Oh yeah, you were saying something before about how it would be good to have some kind of like some side views of these laser tests.
Yeah, I mean, there's issues with that though, because every camera is different, right? And it has a distance per pixel that'll be inside the thing. Like, say you were to go take a picture of the Empire State Building, right? With your camera, we could measure, how high the Empire State Building actually is. Then we could get your photo, see how many pixels are in it. And then we can see how many feet or inches are in each pixel. You know what I'm saying? So when you're trying to go see if the light's bending with the laser beam on the side, you have to have a camera that has really good, like a high amount of pixels, because you want to have that number be as low as possible. Like, you want the least amount of distance in each pixel, so that way you can differentiate, because you could have something bending and not even see it in the thing because there's not enough definition. You know what I'm saying?
Yeah, absolutely, man. I've got a really good side view of a laser test that I don't know if you guys know Lanolin, but he did the Abomination of Desolation documentary where he did a bunch of laser tests over Frozen Lake in Alaska, and he set up a bunch of weather stations. But he actually invested in one of the best rectilinear lenses. It's a wide angle rectilinear lens. I think it's 9mm focal length, but it has next to no distortion. It's extremely expensive lens. And what he did was he did a 6 mile laser test, and he took a long exposure. So he leveled everything correctly. He took an 8K image. It's actually a bit over 8K quality, and he got a side view using the rectilinear lens.
Yo,
And
that's
he
another
actually
thing.
yeah. So this is he's trying his best to mitigate lens distortion. So he has the entire 6 mile transit from left to right of the laser.
That's
And
awesome. That's awesome. But
yeah,
that's another thing though. You want to make sure your camera, you want to try to make sure the center of your camera is at the center of the laser. You know what I'm saying? And as you're backing up from that, do you do it off of
well,
do
this
you
is
do
the
it
good
off
thing.
go ahead.
This is the good thing, because what he did, because flat earthers, right, we can always give the globus some grace. Our observations are so far off matching the globe, we can give them a little grace. So what he did was he actually had the horizon was quite a bit above the center frame. Okay, giving the globus some grace there with the lens distortion. And so what you can do with this 8K image, because it's 8K, and you can vertically squish it. And when you do that, you can see that the laser is actually ever so slightly bending upward over the distance when you compress it. So even though the laser is above center of frame, which would cause it to be convex, and it's an 8K image with a rectilinear lens, even then, it still doesn't curve at all downward. It doesn't curve. There's no curvature of the Earth. It actually, and the laser's hitting the target 3 foot to 3 foot of. So it's
That's
a
what I'm
real
saying,
globe
bro. You
killer.
whip this,
Oh, oh,
when
fantastic.
you whip this out, you know what I'm saying? You're like, oh, it's hitting here and it's hitting there on either ends. And the Glober comes and says, well, yeah, of course, the laser's bending down. And then you show them the side on view. I mean, I don't know. I don't know where the argument goes from there.
It goes downhill for the Globers, but not literally. Here's if anyone wants the image, that's the raw image straight out of Lanolin's camera. It's about 50 megabytes.
Have you ever debated a Glober and used this side on view thing? We
Yeah,
could do it
plenty
right
of
now.
times.
We could do it right now. Jake, Pinky, there.
Where you put the raw
They don't want that
footage, right?
smoke pickle.
It's the NEF file in the Livestream Livestream one.
Carlito ain't the one for this. We need like Jake or
I don't think a side view would help to see the laser arcing or something like that. You don't see the horizon arcing on a side view. The horizon is just that x-axis that you have
yeah, but
from
there's
you to
claims
the.
on there's claims on what the laser's doing. People are saying it's curving downwards. You know what I'm saying? So if you have a side on view with a camera with enough pixels and so on and so forth, you can see if it optically is doing the thing they're claiming it's optically doing or not. That's all.
That's right. The laser would have to be, for this to work on the globe, the laser would have to be bending down for about 14 foot to be able to hit the target at 3 foot. And you can see he's using a really good laser as well that has hardly any what's it called?
With DJ,
the diversion of the beams isn't much over the distance at all. Can hardly see it.
Don't go anywhere, and we'll press them on this as soon as we get a Glober in here that knows what they're doing.
Yeah, I do have to get to work in a second, so hopefully a Glober turns up. But yeah,
bro, get your priorities straight. What's more important?
Yeah, flat smacking some Globers.
DJ, you have a website link for me?
Website link for which?
Yeah.
For this laser, for this test?
Yes.
Oh,
yes.
okay. Yeah, I have Lanolin's YouTube channel. So I'll grab that and I'll put it in the side chat. So he spent about $40,000 in a long period of time setting up his test. He set up he went out with snowmobiles and weather stations, and the guy's been, okay, so he's a flat earther, but he decided at the start, he's like, I want to become an expert at at debating this topic, but it's too much to be able to learn every single argument of every single point in the topic. So he's like, I'm going to concentrate on camera trickery, right? So he could debunk NASA footage, that kind of thing, and refraction. So he's took a deep dive into refraction. So that's why he's gone out with different spectrum lasers. He's gone out with weather stations, and he's measuring the humidity, the temperature, the pressure. And he's got a documentary that he made called The Abomination of Desolation, which I'll post his link in the chat in a minute. It's pretty cool.
Thank you so much. Exactly what I'm searching for. Yeah, really expensive. Yeah, really cool.
Yeah, there's a really good stream. If you look up worldwide debates and just type in worldwide debates Lanolin, it's about a 6-hour stream where he goes over everything with rigs. He goes over all of the NASA stuff, and then he spends hours going over refraction, lasers. He shows all his footage. He explains everything. Very smart guy. I'll find that link. I'll put that in the side chat as well as the document link. I mean, in the main text chat.
Hey, y'all got a topic. So if y'all don't, Jeremiah needs to ask you something.
Oh, wait a minute. I want to ask the guy, what's his name? Pickled Mind. What do you think of the TFE thing? What's your perspective on it? Some people think it's fake, like, so I just wonder what you thought.
Look, I haven't been there. I don't know 100% for myself, but I don't think the arguments that it was fake are very good. I think they're pretty trashy and embarrassing, to be honest.
I agree with that.
Yeah. Well, that's just my opinion, but I haven't seen any convincing evidence when it comes to they didn't have breath. Where's the footprint, the noises of the crushing snow in the footprints. It's done in a studio, that kind of thing. I haven't seen anything that's convincing when it to that personally. I haven't been there, so I don't know for sure, but I can't see any proof that it was like studio or anything.
Yeah, nice. I agree with that.
And I saw footage that I couldn't debunk even before they went. If you just look up the 8K time lapse that was out for TFE, and you can't really find any flaws in it. Not that it couldn't be faked, though. Right? I mean, if they were able to fake the moon landings, I'm sure they could fake some Antarctica footage, but I haven't seen it. I'm not claiming that it was because I don't have evidence to back up my claim.
What's up? What's up, Carlos? You all set, Andy?
Yeah, that's good. I agree with him.
Yeah, there's not many people are saying it's fake. A couple nutcases here and there.
Yo, shout out to that guy for what he just said. So I appreciate it. But look, check this out, Jeremy. I was asking this earlier, I got my head bit off. You're in Australia,
Rightfully
right?
so. Rightfully so, bro. Go ahead.
You're in Australia, right? You got a compass. You aim south, and you walk in that direction. Or you walking in a straight line.
Hold on. You're in Australia. You got a compass. You look at which way is south. You start walking that direction. You toss the compass, or do you always check the compass?
You always check the compass. You keep it south.
Always, like you do a step check the compass. Do a step check the compass.
You ain't even looking up. You just looking down at the compass. You aim it south, and you walk towards the edge.
All right. Then what?
Are you walking in a straight line?
Not on a globe. No.
No, I'm talking about on a flat Earth.
I might say no also because of magnetic declination.
So what are you walking in?
Like a curvy line, dude. I don't know what the magnetic declination is. I know it gets really bad in the south, and there's bad anomalies somewhere. I would say no. You're not walking in a straight line. I don't have any proof of that. If magnetic declination in the mainstream model is true, you're definitely not. So.
Okay, what if you take a compass, right, point it south, and then you point in that direction, you hold your finger up and you point that direction, and then you just walk in that direction. Now are you walking in a straight line?
So you're gonna check the compass once and then not deviate
Yeah,
from
you're not
that
deviating.
first, right? Then I would say you're walking it. Well, I mean, bro, you know how hard it is to walk in a straight line. You'd have to like snap a line or something. So it's pretty tough to walk in a straight line. You always hear people get lost in the woods. They end up double backing on their one of their previous positions and shit. So
I'm trying to figure out how south works, because I guarantee if I told you that we walked north, we'll hit the North Pole, and that's
you
a
don't know
straight
how
line.
east works. You don't know how east works, bro. You can't. Don't worry about south yet.
I do know how east works and west.
Okay, we're standing in a location in North America somewhere. We look at the compass and then head in that direction. Am I going to go around a latitude line or am I going to hit the equator?
Wait, hold on. I said it one more time. We're standing in North America. All right. So the compass is going to be pointing north towards the North Pole.
No.
Okay. Depending on where we're standing, left is going to be east, and right is going to be west, and then south would be opposite of north.
Yeah, I look at the compass. Hold on, man. I look at the compass and then I toss that shit and just head in a straight line in the direction the compass was. Do I hit the equator or do I go around a latitude line?
Oh, you'll hit the equator.
All right.
Yeah, because your east and west is relative to north. So it's going to keep pointing north, and then you'll just be walking in a circle. You'll pretty much be walking in a circle.
What's with the south thing, though, bro? What's with the south thing?
Because I'm trying to figure out. So here was the premise, right? I'm trying to figure out which direction is south. Because my understanding was south is opposite of north, right? So if we at the North Pole and we pick a direction and we walk in that direction in a straight line, we're walking south. But I asked earlier, I was like, okay, is that a straight line? And people was like, well, it's not necessarily a straight line and it's not a curved line. I'm like, well, then what the fuck is it? Is it a zigzag? Is it diagonally? Like help me out. And then I got fucking cursed out about it. Well, not cursed out, but people was like, "Oh, Carl, you're stupid. Go to hell." So I'm trying to
No,
figure out Southward.
yeah, I think the whole premise was you were saying it wouldn't work on a flat Earth if a person in Africa tried to go to or went south, and then a person in Australia went south, and they both ended up in Union Glacier. But that's a false premise because if you look, just chat GPT that, they will say no, they will not both end up in Union Glacier because of magnetic declination.
No, I didn't say Union Glacier. I said Antarctica. I said you would hit Antarctica. And you can get the Union Glacier from there.
No, but
But
your
this
whole
is
point was
my
that
whole
your whole point was that they're going to end up in the same location.
right, which is Antarctica. And you can go to Union Glacier there to make sure you're in Antarctica. But my whole thing was my premise, like I abandoned that very, very quickly.
So if Antarctica is huge, you're not in the same location just because you're on the continent. Do you understand that?
I understand that. But my thing was, okay, on a flat map, you go south. Somebody goes south in Australia, somebody goes south in South America. They're going to be on opposite ends of the earth. They're not going to be nowhere near each other. You're going to be the farthest, that's the farthest distance you can be from each other, period, on earth. So I was trying to figure out what they was telling me now. So I'm trying to figure out, okay, then how does south work? And that's where I got to that. And I
Well,
still don't know how.
no one really said no. They just said you would. Your premise is false. You wouldn't go to the same location.
All right. And then I was saying we could test that. Right. So we can test that, right?
Did you look at the magnetic declination map that DJ
No,
posted at like
no,
10:55 on the hour?
no magnetic declination. We don't need magnetic declination for this.
You
We can
absolutely
test.
do, because if you're using
All
a
right.
compass, right? How else are you going to
Yeah,
go south?
Carl, if you go stand in one spot, if you go stand in one spot, you're just if magnetic declination is like bad there or something, you point the compass. Dude, I've seen magnetic declination maps where it literally looks like if you're somewhere in the south and your compass is pointing south, you're almost going directly north. Like it's almost a full buck 80. It's crazy.
Right. But here's my point. This is why I don't care about magnetic declination. Hear me out. You know how long it takes to fly from California to New York?
But you could be
Think about that for a
pointing
second.
north though. If you pull your compass out and go in that straight line, that line could be like east or something.
I understand that, but do you know how long it takes to fly from California to New York?
Are you on the Concorde? Are you in a Cessna? Are you in a
In,
737?
an airplane, just a regular airplane.
Are you in a jet
Flying in a
fighter?
regular airplane.
Are you in the
You're,
stealth bomber?
you're flying. Now, you're in a commercial aircraft, a
Are you on
Boeing
the ISS?
757.
My bad.
No, man. You go to the airport when you go to LAX, and you fly from LAX to whatever the fucking airport is in New Orleans, not New Orleans, New York.
I think you're breaking up, Carl. Is it me or him, guys? Like, check.
It's him. It's him.
Yeah, it's him. Sorry, it took me a while.
Yeah, I'm driving through the country right now. That's why I'm breaking up. I'm in the middle of nowhere. But can you hear me?
I hear you now.
All right. So LAX,
Oh, you're breaking up again, bro. You're breaking up again
commercial
immediately.
aircraft.
Get
All right.
somewhere better,
I'll be
Carl.
back
Get
then
somewhere
later.
better. All right, don't try to Terminator me.
I'll come
Just
back.
come back later. All right.
Yeah, yeah, don't forget. All right. Later.
Talking about I'll be back.
else would you expect, regardless of shape? Like, duh, if you understand perspective, there's nothing there that would allude to you, like one way or the other, what the shape is. That's just your preconceived notion being imposed upon what you're seeing in reality and not understanding an alternative.
I don't even know what is his conclusion when he said that. So he saw the building appearing from
He's
top
throwing
to bottom.
shots. He was throwing shots at us.
I was just throwing a little shot. It was a little left out.
Okay.
That's all.
It was like a little jab. It was like taking a little jab.
Okay.
I just wanted to say some shit and then hurry up and change the subject. But anyway,
just want to throw a little jab and then run.
Well, I was thinking initially
case.
maybe you started to understand perspective, but I guess that's not the reality of it. You still think that has something to do with shape, I guess.
Jeremy, you were right. All right, so direct flight from LAX to New York, 5 hours. 6 hours. Some of them 5, some of them 6. All right, so we established that. So now I want you to think about this, dog. So you're in Australia and you fly to Union Glacier. And then you go to South America and you fly to Union Glacier. And then you go to South Africa and you fly to Union Glacier. Right? On one of those flights you should be flying across the earth. There's no way all of those flights should be around the same time on a flat map. Right?
Bro, what was the question? Were you talking to me that whole time?
Yeah, dude.
We're flying from LA. How long does it take to fly from LAX to New York?
About 6 hours, 5 to 6 hours.
All right. On
Okay,
certain
so
planes with
that's
certain jet
flying.
streams. Can you change that time though? Can we change that?
What you mean change it?
You said 6 hours.
It was like 5 to 6, depending on the plane.
Could we do it in 4? You think?
Maybe pushing it.
We catch a good jet stream.
Maybe.
What about 3? Could we push it down to 3?
No, I don't think we can get to 3. Maybe if you was flying in a fucking military fucking supersonic jet.
All right, so from New York to LAX, it's 5 to 6. You said
5 to 6.
What about from LAX to New York?
God damn it! Hold on, let me look that up. Let's flip it back. LAX to New York. Hold on. I mean New York to LAX.
No, you already said New York to LAX is 5 to 6. What about LAX to New York?
Hold on. I'm swapping them now.
Where are we going? LaGuardia, JFK?
JFK.
It's probably not important.
All right. So JFK to LAX, flying Delta, 6 hours and 16 minutes nonstop.
So that's a very specific time. The other one you had it. So LAX to New York is 6 hours, 16 minutes. What's New York to LAX?
No, that was New York to LAX. I'm sorry. Now this is LAX to New York.
All right.
I mean, no, that one up. All right. 5 hours and 23 minutes.
Oh my god. Oh my god.
5 hours and 23. Okay, so we established to fly across the United States, it takes about 5 to 6 hours.
Well, I would just like to note for the record that it's a different time in different directions, but okay.
All right, I'm just saying. Just to fly across?
I'm just saying too. Just it might come in handy later for me. So I just want to take note right now that it's different times in different directions.
Right. They
for the same
varied,
distance.
They varied for about 30 minutes.
That was more than 30 minutes. What were your times again?
God damn it, Jeremy. All right, LAX to JFK.
You're trying to downplay this because you know this might come in handy for me later.
It's not. I guarantee you it's not, but
okay.
We're going to do it. All right, so JFK, LAX. I'm sorry. LAX to JFK, 5 hours and 23 minutes. All right. Let's see, JFK to LAX.
It was 6:16.
Okay. It's 6:23, so about an hour.
Okay, an hour. An hour difference just from across the country.
Right, so it take about 5 to 6 hours to fly across the U.S., depending on.
You think we could get that number down to 4 and some change?
No.
The 5 hour, the 5 hour and 23.
If you switch the plane or you increase the speed, then probably.
No, same plane. Same plane.
Same plane? Nah, not that far down.
You don't think you could shave 23 minutes off?
Maybe.
No, maybe, yes, maybe, I don't know.
Maybe.
Maybe.
I don't know. I'm not an expert, bro. I'm just going
All
off
right,
the
these
flight.
times are really, this is some precise shit though. Go ahead, carry on with your thing. Let's
All
let's
right,
move
so
forward.
5 to 6 hours to fly across the United States. Are we agreeing there?
Depending on which direction you go in, it'll vary up.
Yeah, that's what I'm talking about. Okay, cool.
And you
Cool.
might be able to shave some times off of that too. So I mean, who knows? It's in air.
Okay, and that's the time it'll take to fly across a country. One country, the United States.
What's the time?
5 to 6 hours, dude.
You might be able to do it in 4 and some change though.
All right, I'll give you 4. Let's say between 4 and 6. Is that cool?
You're just gonna give me straight up 4? You're a
Yeah, I'm
terrible
giving you 4.
negotiator. Just 4
I'm just
flat. You're a terrible negotiator.
I'm gonna just give it to you, bro. You know why? Because
This is why you're not
I
top
fuck
5,
with you.
bro. Go ahead though. Let's carry on.
This is why I fuck with you. All right. So 4 to 6 hours, and that's flying across the country. All right, cool. Now think about this for a second. You got Australia and you got South America, which is according to a flat map. Any flat map you look at, they're going to be on opposite sides of the Earth, right?
Sorry, Australia and South America are on opposite sides of Earth.
Yeah, they're on opposite sides.
Like anti
One is
like
on one side, the other
exactly.
is on the other one. One's on the top,
I've
one's
seen
on the
them.
bottom.
I've seen one where they're kind of like not really like that. I've seen maps
What
when
map?
they're like kind of like just a quick little shot.
I'm talking about your AE map. On your AE map,
I've
dude.
You haven't seen AE maps where they got it like cocked slightly and it's not that bad from Australia to South America.
No, but all of them you got to fly across the world. On every AE map I've seen, you got to fly across the world. One's at the, you know,
Okay.
on every.
Maybe I don't know. I could swear I've seen some that where it's an AE map, but it's like they'll have them like kind of like smushed up against each other. So like South America and Australia really aren't that far apart. But I mean, I guess carry on.
I haven't seen that one. You would have to show me that one.
Yeah, I don't know. Just
You have
from
to
what
show me
I've
that one.
seen over the years,
All right, so this is why I
I
say I
don't have
need.
it on hand.
So this is why I would need South explained, because under those circumstances, if I showed you flights going south from South America and flights going south from Australia, and they landed in the same general area and they got there in close times, then you have to admit that's impossible.
Whoa. What the fuck? Hold on. What happened? You
If I
go
showed you
south
a
from
flight
South
going
America and
south
south
from
from
South America
Australia.
and they landed near each other in the same place,
Okay.
and they had
Okay.
similar times of flight, then you would have to admit that's impossible.
That is absolutely not okay. You have 2 points on flat Earth. Uh, you make a you make an equal distant line between those 2 points. Now we got a triangle. Why is that impossible?
Because they have to go south.
But the same times and the distances and shit, they could do that, right?
No, because if you go south from South America and south from Australia, you're going to end up on two opposite ends of the earth.
South according to what?
According to a freaking compass or a map or
We just
south. That's
went
how I'm
through
trying
Yeah,
to
the
figure
but
out how
declination.
none of
this
them
is.
flights go south though, man. They go east and west, bro.
There's that too. I mean, but we went over the declination thing, dude. You could be standing
Except for the
somewhere.
ones that go to Antarctica.
You could be standing somewhere south. Your compass will say south, but it's actually fucking east or something. Like magnetic. Look at a magnetic declination map, dude. It gets wonky in the south. Bad. Real
Like almost
bad.
180 degrees wonky. Like it says
That's what I'm
south, but you're
saying,
actually
bro.
facing
Yeah.
north, kind of stuff.
It's
I'm getting ready
nuts.
to take a
It's nuts.
I'm getting ready to take a 15-hour flight. I don't know what that's going to prove,
No, so
but I'm
okay.
taking one.
So
Oh, you're
basically,
about
what
to
y'all
debunk
saying
flat Earth.
Yeah, right.
what y'all saying is that we can't verify if we're going south because of magnetic declination.
Have you looked at the magnetic declination maps? Have you seen the variances? Do you think that
Yeah,
the
and name
AE
all
map or
various
the globe
variables.
map is? Do you think there's an adjustment for magnetic declination on those maps?
Yeah, the closer you get to the magnetic South Pole, yeah, but they don't vary the way y'all varying. Only when you're like very close to the magnetic South Pole, but not when you're just in Australia. You're fine. You can use a compass, totally fine. Same thing with South America.
Sure, but you're talking about leaving the place, right? And that's when you start to get into magnetic declination anomalies.
Right, when you get
And it's
very
not
close to
just
the.
around the magnetic South Pole, by the way. Maybe look one up, take a gander at it before you start
I
to
already
talk
did.
as though you know what you're talking about.
I already did. You have slight variances for sure. The extreme ones y'all talking
Flight?
about 180 degrees and all of that is very close to the magnetic South Pole. That's a fact.
Yeah. So these flights that you're talking about, where are those close to?
They're not. No, I'm talking about extremely close. Not that. Not the distance between fucking Australia and Antarctica, dude. And then even if I was to grant you that, then
And the
you would need to
variants
have
aren't just
multiple.
right next to the magnetic South Pole.
Napalm. Even if I granted you that, you would need multiple magnetic South Poles in order for that to work.
Yeah, that's a possibility. Have you proven that it's not?
Oh, so now we have. So we got magnetic South Poles all around the ring.
I don't know. You've
Besides
been out there
one.
testing them? You've been out there testing them, bro?
I'm answering the question.
No, you're the one who posed it.
Then you're making the claim, bro. You're saying it's magnetic
I
declination.
never made a repeat my claim back to me.
Excuse me. I'm sorry. Your claim is that we can't tell if we're going south from Australia and South America because of magnetic declination. We could be going east.
Well, I'll accept that if you can go back and clip that and play it back. That was my claim.
That's
But
what you
that's not.
insinuated.
Oh, so you're saying
You're
your
an insinuator.
interpretation? Yeah, your interpretation of my words is somehow reality.
I mean, that's what you're saying. Should I not take what you're saying into account? That's what you're saying. I'm saying we could fly south
That
from
is not what I
Australia.
said.
Okay, so can we fly
I
south?
said there are times with magnetic declination that it could be up to 180 degrees variance.
Right,
Now
and
everything else you put after that's on you.
right, and that's very close to the magnetic South Pole. That's when you have all
That's your
this
claim.
extreme
So
declination that you're
there's no
talking about. No, that's
there's
not
no
my
distance
claim,
away
bro.
from.
That's the observed reality of it. The observed reality is that when you get close to the magnetic South Pole, that's when you start having these extreme instances of magnetic declination that can spin around 180 degrees and all the other extra shit.
In the south, and you said your flight paths that you were talking about were going south from Australia and south from South America, right? That's your claim. So do those
Right.
flight paths come close at all to the magnetic South Pole?
They do.
Oh, well, there you go.
Right, but that makes sense on a globe. It doesn't make sense on a flat Earth unless you have multiple magnetic South Poles. So I'm asking you, are there
No.
multiple magnetic South Poles?
That's what they claim on the globe.
Napalm, you
there's
need to
two.
have that answer right now. Are there multiple
No, they
magnetic
claim
South
two.
Poles,
They claim
Napalm?
two.
I want you to know.
magnetic
Have you
South
checked?
Poles.
Yeah, I haven't been down there.
You would need magnetic South Poles all the way around the ring. That's what I'm saying. Because you can fly south from Australia, you can fly south from South America, you can fly south from South Africa.
Where do you think that the magnetic South Poles are on the globe? You didn't know that there was two, right? They claim that there's two.
It's somewhere over water. The one in the south. It's like off the coast of Antarctica.
But you said that there's only one. Is that the one that you're talking about?
No, I'm saying that on a flat Earth you would need multiple. You would need more than two. You're telling me there are two. I'm telling you, on a flat Earth, in order for this to make sense, you would need an infinite amount going around the ring.
Well, I think you're making a few assumptions.
All right. I'm not making a few assumptions.
You should. What I would recommend you do, to make the argument a little more sound, is to actually get the flight paths of the flights that you're specifically talking about, Right, and then form it together in a little presentation where you can say, okay, this is the exact flight path I'm talking about. This is what it's claimed to do, and and then we could actually go over it, and we could look at the magnetic field line map and all of that sort of thing, and actually have some data to work with instead of
Yeah, but
just kind of hypothetical.
before I go into all of that, I want to make sure we get the premise right first. Then once I can prove that, then I don't want you to be able to walk back your premise. So that's why I'm asking you how South works before I do this. So I'm just asking
He's trying to
if
set
you
a
fly
4 hour
south.
long. This is a 4 hour long trap he's trying to set here. Go ahead, Carl.
It's not a trap. I'm just asking you a simple question. The way that the South works on a flat map is they all spread out from each other. Am I lying?
On an AE map?
On any map, any flat map, South is opposite of North, and if North is in the center, then all points away from North would be South, right?
Are you just talking about lat long
Where
maps,
where
which are spherical coordinate system projections?
I'm talking
I mean,
about in
what map do
reality.
you
I'm
have
talking about
north
on
in the
Earth.
center? What map do you have north on the center of? It sounds like you're talking. You said you weren't talking about the AE map, but it sounded like you were talking
I'm
about the
talking
AE
about
map
in
when you said it.
reality. In reality, if you stand, is there a North Pole in your world?
A North Pole,
Yeah, North Pole. Is there a North Pole in your
like in
world
the sky or on the ground?
on the ground?
I mean, you got to be more specific. Like, what does that actually entail? The pole part. Like, is there one spot we could all walk to, and we're
So,
all up at this? If we all went north, would we all be holding hands at the same spot? You're saying?
yeah, if everybody went north, will we meet up at a point, and will we call that point the North Pole?
I mean, I think so, maybe, but I mean, you'd have to check. I'm gonna have Napalm check it after he does the south thing for you.
Okay, so
Are you
if we
talking
all meet
about
up
the
at a point,
magnetic north, though? Just quickly, are you talking about the magnetic north, which is not this where the GP is for the Polaris for the celestial North Pole ground position? That's a different location than the
He's talking
magnetic
about the
North Pole. Which one?
presumed polar axis. I mean, why you guys are...
Well, that's not what your compass is going to take you to.
I think y'all know what I'm talking about. I think y'all just don't want to say it because you know what it means. I think you know what it means.
No, I'm asking you questions about it. Simple questions,
All right, let
because
me ask you a question.
there's different right.
What's
There's
on the
magnetic
Polaris?
north, there's true north, etc. So I'm asking you which North Pole you're
I'm not
talking
talking about
about.
compass. I'm talking about we all
Because
walk
you didn't
towards
know that there were
Polaris.
two magnetic south poles a minute ago, so I'm guessing you don't know that much about magnetic declination.
Only one. There's only one main magnetic South Pole. I don't know about the second, but I don't care about that one because I'm talking about walking towards Polaris.
That's my
So
point,
we
though.
all
Like, you
walk.
don't know
If we
you can't
all.
stillman the basics of the globe. That's why I'm asking you questions so you can
Oh my
clarify,
God.
because I don't think that you've looked into it enough to be using it as a debate
No, I've
argument.
looked into it. I've looked into it, and it's a very simple premise. If we all walk towards Polaris, will we all run into the same spot? Very simple. This is
Who
not complicated.
validated that? Who validated that? Who even validated that the GP of Polaris is at a particular location? At that
Okay,
Polaris,
so
right?
we
At
all walk towards.
that the North Pole on the Earth, right, is at the zenith. That Polaris is at the zenith of that point.
You
Who
don't want.
validated that?
So you don't
Maybe
want to
it's
answer the question.
true, but who actually tested that?
Yeah, you're not
So
even
you
allowed
don't
to
want.
go there. That's the problem.
So you're not going to answer the question.
Well, I'm asking you like questions about what you're claiming, right? So if you claim things, then I'm going to ask you questions about the things that you're claiming.
I'm not claiming anything. I'm asking you.
You did. Well, okay. I said I gave you an answer. I said nobody's done that to confirm what you're suggesting.
So you don't know is your answer.
My question is, I don't know, and you don't know. Yeah.
Okay, so we don't know if there's a North Pole, is what you're saying.
It's presumed,
Depends what you
but
mean
I've
by
never
North Pole.
confirmed it.
I'm just asking, bro, is there a North Pole?
There's a
Is
celestial
there
point in the sky.
North
There's
Pole?
a celestial pole in the north. That I can agree
Is
on.
there a landmass?
You know,
Is there a landmass there with a lot of ice?
I don't know. Have you tested that? Who checked?
I mean, people go there. People live there.
Well, isn't there no land there on the globe model? It's just a
In the
spot
North
in the
Pole?
ocean. Yeah, at the
No.
North Pole.
You're talking
What
about
do you
the
think?
magnetic
Santa's
North
at the
Pole.
North Pole or something?
I'm not talking about the magnetic North Pole. I mean, I'm not talking about the magnetic North Pole.
Okay, so grab me the map, the globe map, and point to where you're talking about.
Okay, look at a globe. Touch the top of it. That's the North Pole. Look at a AE map. Point to the middle of it. There's an ice there.
What's the point, though,
That's the North Pole.
Carlito? What's your point?
Okay, so I'm trying to see if we all travel north, will we get to that point? And everybody's like, not answering the question.
Okay, I'll answer yes. Now what?
Okay, now is opposite of that point south?
No.
Okay. And then what is the opposite of that point?
I think you said it
What is-
earlier.
What is south?
South is every other direction other than north.
Okay, so if we're standing, if we all walk north and we get to one point, and then we turn around and we walk the opposite direction, are we walking south?
Yes.
And does south go in all directions from that point?
Well, this is how I presume it to be on a flat Earth, and I would say yes.
Okay, so that means that Australia and South America would be on the opposite side of the world.
From what?
Right? From north.
You said Australia and what?
If me and Jeremy were standing back to back at the North Pole and we started walking away from each other, we both would be walking south. One of us, if we could walk on water, one of us would hit Australia, the other one would hit South America.
Depending on the direction. Depending on the direction you went.
What do you mean depending on the direction I went?
So
What do you mean? I just told you
so
direction I went.
you're going two different directions apart from one another. You're standing back to back at the North Pole.
Uh-huh.
And you're going two different directions.
Uh-huh.
Great. So the South Pole is an outer ring. The North Pole is a center point.
Right, exactly. Okay, right. So we can test that. Because Jeremy, when he walks south, he'll hit the ring. And then when I walk south, I'll hit the ring. And we would be on opposite ends of the earth because it's a ring.
Okay.
Okay, so we can test that, right?
I don't know. Can we? I mean, I don't think we can go past the 60-second parallel south, and I don't think you can go completely to the center of north.
Well, we can go to Union Glacier, can we? Can we go to Union Glacier? We can go to Union Glacier, right?
Well, aside from like legal boundaries, like sure, theoretically, yes.
Do you think the TFE was fake?
No, not necessarily.
Okay, so they went to Union Glacier. Do you think people that run the marathons, do they go to Union Glacier?
Okay.
Okay, so if one person flew to Union Glacier from Chile and the other person flew from Union Glacier from Melbourne, don't you think that the flights should be vastly different? One should be like 5-6 hours long, and the other one should be like 19 hours long. Don't you think? Or no?
I mean, I'm not looking at the map, but I would just assuming that they're different distances apart. Sure. I mean, I don't see what the point is, what the problem is.
Right. So we would have to check that, right? So if they're similar times, then that means that they can't be on opposite ends of the Earth, which would mean that it's not flat.
If there's similar time.
Yeah. If you
it's flat. It's flat, and it will remain flat till the moment that those people who were back to back in the North Pole will meet each other in the South Pole at the center of that ball that you are claiming. If those people never meet each other, yeah, it's not a ball.
No, I'm saying. Y'all really established that. Oh my God. I don't know why y'all making this so complicated. We already established that Melbourne, Australia, and fucking Punta Arenas, South America, should be on opposite ends of the Earth. So if you just take two people from those two places and you told them to fly south and see where they ended up, if both of them end up at Union Glacier, then there is no way that the Earth could be flat.
No, you're pointing to a direction. That's just stupid, bro. What you mean? You're telling, go to Union Glacier. No, what you have to go is go to opposite directions. You go south, you go south the other way. But right now, where you're telling me, hey, go to this location.
Yeah, they would have to fly south.
Yeah, that's not go. That's you just dude. How can I? You know what?
Yeah, I told him that. I told him that you don't need to bring any specific location. You just unleash those two people back to back from each other on the North Pole, and they will meet each other. If the Earth is a ball, they will meet each other at a certain point in the South Pole.
That's what I'm saying.
Nice.
You're not saying that. You're saying go to a location. It's like saying go to California from China and go to California from Ecuador. And if y'all made up in the same place, then the Earth is a ball. Get the fuck out of here, bro.
Oh, listen, bro. If one
that's just
person is
stupid.
flying, if one person is flying south from Melbourne, Australia, and the other person is flying south from freaking Punta Arenas, and both of them end up close to Union Glacier, bro, they should be getting further
Well,
apart.
that's not. That's dude. Now you're saying close to Union Glacier. Well, first you were saying if they both go to Union Glacier, they fly to. That means the Earth is a ball. That's not the way it works because you're trying to say go to this location. Now, what you got to do is go south. You go south. You go south. If we meet up in the middle of wherever we land at, there you
You
go.
don't have to.
There's
You don't have to meet up in the middle, dude. Listen, bro. There's two exclusive claims here. The Globe claims that Antarctica is a continent. The Flat Earth claims that Antarctica is a ring that goes all the way around the Earth.
Yeah, but
So all
when
you
you
have to
fly,
do is see what Antarctica is.
when you fly
Oh,
from Melbourne to Union Glacier, you're not going straight south. You're going southwest.
Yeah, you got to understand that the thing is, Carlito, is nobody travels straight as a crow flies. Everybody takes a curved path when they
but even if
travel
you
long
curve,
distance.
it's the distance that we're
Bro, can you
taking.
hear me?
It's not.
Can you hear me? Mic check.
I can hear you. I'm sorry.
Okay. So if you're to understand that nobody travels straight as a crow flies, everybody's taking a curved path, then and you understand this, then what are you saying?
Look at the time, the distance. That's why I asked how long it takes to fly across America. 6 hours.
How are
Okay,
you
that's
going to get an accurate distance if you're not going straight? When you
how
measure
you gonna
things,
get
the
an accurate
distance to
distance.
things, do you measure it curved or do you measure it straight?
Measure it any direction you want to. What are you talking
No,
about?
we don't measure things, right, with a curve. Like that's not how we measure distance. We measure distance from A to B.
Yeah,
Wait,
bro.
so if
Like
you
But you're
what
not traveling
Dyslo's
from A to B.
saying, right now is like, if you were to go to your friend's house, right? But there was like a little lake in between you, so you had to go all the way around the lake in a huge arc or something. You wouldn't say that's the distance to your friend's house, and is that arc they took.
But you would say that's the distance that you traveled.
Okay, but that's irrelevant.
Yeah, no, it's very relevant because on one you would have to travel across the whole world, and on the other one you have to travel just a little bit. So if they get there around the same time, then how in the hell can you say? Like, I'm not understanding why this is so difficult.
Bro, you're not
One
even
flight
getting
should be way
to the
longer than the
same
other one.
time. Carl, it's not even taking you the same time to get to the same location. You go from New York to LA, what's the time? And then what's the time from LA to New York? Those aren't even the same time. So I don't know like what you're
Yeah, but
trying to
there's
use
only,
this for.
but Jeremy,
Remember
there's
when you
only
said
like there's
I
only an
wasn't
hour
going to be able
difference.
to use this? Remember when you said I
You
wasn't going to be able to
can't.
use it? I'm using it right
You
now.
can't. You can't because it's
I'm
an hour
doing it
difference.
right now.
It's an hour difference. It's an
Or
hour
2
difference,
hours.
bro.
You gave me 4 hours.
I'll give you 4
Remember?
hours. I'll give
Yeah,
you a
and one was
4 hour
6,
difference.
one was 6, one was 4. That's a 2-hour difference. Admittedly, your guys aren't the point Dyslow made about not traveling in a straight line. You guys admit that the pilots are making Coriolis corrections, albeit ever so slightly, but that means they're not going in a straight left or right path. You got major issues with this, my man. Major issues.
I think you're trying to make it a major issue. I don't
No, I'm
mind
just
giving
saying your
you a
shit's
2
all
hour
fucking
difference.
wonky, bro. Your shit's all
How?
crazy.
Bro? How? One flight would have to fly across the whole globe. Well, not globe. Well, one flight would have
Here's
to
how
fly
your
across
shit's
the whole
wonky.
map.
Here's how your
Okay.
shit's wonky. You're trying to use this time thing. You're not even going back and forth from the same 2 points in the same time. So there's that.
Right.
Right? And for
Okay.
B, they're admittedly not going in a straight line. So there's that. Like this is all over the place. This is nuttier than squirrel poop.
Or
No,
I'm
no,
looking at it
I'm
right
not
now.
doubting you, but that's ridiculous.
Bro, I'm looking at it right now. There's one magnetic South Pole. Then you have a geographical South Pole, which is a place, right? Then you have the geomagnetic South Pole, which is a theoretical point, not a real point, and it's calculated based on the magnetic field. And then you have the South Pole of inaccessibility, like I said, which is just a point on the Antarctic continent farthest from all the coastlines.
Dicelo, post what you're talking about, because that's ridiculous. A magnet has a north and a south. Single, one of each.
Yeah, but you don't know how many magnets we're dealing with on Earth. It could be more than one magnet.
Well, that's a different story, yeah.
That's what I mean. We're talking about on Earth, so.
You know, Jeremy, I'm disappointed in you dropping down. It used to be you,
Why?
Geo, and then SC, but now SC is number 2.
You don't
Geo's
even
number
have
1.
Winston on there?
You're like
You don't
5.
have Winston in your top 3?
Nah, Winston not in my top 3.
Wow.
He is in my top 5 though.
Your list is crazy. You think you're in the top 5 Globers though, so that's your list is all fucking crazy.
No, I was just asking if I was in yours.
You put
And
yourself
while
right
we're on
next to
this,
Kosho. Go ahead, Essie.
Me and Kosho.
while we're on this magnetic
hell
thing,
no. Go ahead,
I brought
Essie.
this up. Yeah, while we're on this magnetic thing, right? I brought this up before. Has anybody ever wondered why the compass never flips? Anywhere on Earth, it always points north. Has anybody ever like contemplated that?
Well, they say it flips, right?
Yeah, they say it flips.
Where? No, they don't say it flips anywhere. No, where do they say it flips?
When you go through the magnetic, you gotta go through the magnetic pole, South Pole.
No, it
Why would
never
it- why would
flips.
it
You have
flip?
people in the South Pole showing it always pointing north.
No, it's only going
No,
to
they
point in
say
one
there's a
direction.
region you got to go through. There's a region. It's like off the South Pole. That is the magnetic South Pole. That when you go through that, it should be pointing. Like if you were to go in a straight line, they say it would be pointing behind you afterwards, right?
Well, they say that, but I've never seen any. First of all, I haven't heard that they say it, and I've never seen a compass pointing anywhere but north.
Yeah, because it aligns with the magnetic field lines. So it's not going to flip. It's just going to always point north. And then when you get close to the pole, it's going to start doing crazy shit like spin and all this other type of shit. But it's always going to point north.
Well, except that magnets don't work that way, and compasses, they don't work that way. They don't start going crazy, and there's a certain point where the compass flips.
No, if you stand close to the source, then it's going to start acting wonky.
Look, Carlito, get a magnet and get a compass and move it around the magnet, and you'll see it flips. There's no way around that.
Yeah, because you're thinking about a magnet. You're talking about like a bar magnet, right?
Well, that's what they say that your pseudo Earth is. It's like a bar magnet.
Right. So if you have a bar magnet on the table and then you take a compass and you move it around, then yeah, it's going to flip. But that's not how that's not how the Earth. You got to think about it. In order to make it like how you saying it, you'll have to take a big styrofoam ball and then you'll have to stick the magnet through it.
No, not really. Why? In your
Because that's
model,
how
pseudo model, it claims it's like a bar magnet that runs north to south, right? That's why the compass works, right?
Yeah.
Okay. So there's no magic to a magnet. Well, there is magic. I mean, I'm not talking about how the magnet works itself. I'm talking about how the magnet works with a compass. There's no getting around it. When you move closer to each pole, the compass will flip. Try it. There's no getting around that. Now, unless you think the Earth is special and doesn't behave like a magnet, that's a whole different story. But do you understand what I'm saying?
Yeah, I understand. No special. So if you take a magnet and you lay it down on your kitchen table and you get a magnet and you go around it, it'll flip, right? But you got the magnet laying flat on the table. That's not how Earth's magnet is. You have to take the bar magnet, and impel it through a ball to where the north is at the top and the south is at the bottom. And then take your compass and move it around the ball.
Okay, so according to the way you're thinking, is the magnet a line horizontal or vertical on Earth?
It'll be vertical and it goes out.
It'll be vertical?
Yeah, like top to bottom. The top will be the north, the bottom will be the south. You put the north at the top, put the south at the bottom, and it'll radiate outward.
Okay, so it still has to behave in the fashion that I'm saying. There's no way around that. There has to be a point on Earth that the compass will flip. There's no
What
way
point?
around that. And so far, there is no such point on Earth. Now,
Why would it flip?
unless we're dealing with a monopole magnet, which we know it doesn't exist, you have some splaining to do. And this is not a flat Earth versus globe thing. This is everybody. This concerns everybody.
Why would it flip, Essie?
I just explained to you how a magnet works and how a compass works. If you're closer to one pole or the other, the compass flips. I told you. Take a bar magnet and see for yourself.
Right. Wouldn't it point towards the north pole of it? Well, actually, it's like reversed. So
Bro, do
actually,
you
the
have a
south pole
magnet
is at the top.
and a compass?
Yeah, but I'm
Do you have
saying
a magnet?
actually, it's reversed. So the southern one would be at the top, and then that would point north. But anyway, what I'm saying is, if you took the bar magnet, you're thinking of a bar magnet lying on a table, dude. That's why you think it should flip. I'm assuming you think it should flip at the equator because you're thinking about it being on a table instead of thinking about it being through the sphere. And you on the
Wherever it
surface
is,
of
right?
the sphere.
Your compass is picking up the reading, right? Regardless of how you imagine this in your mind, right? There has to be a point where it flips. I don't know if you understand that, right? There's no way around that. If you think the Earth is a bar magnet, then there has to be a point where the compass has to flip. Be it some say at the equator, some say at the North Pole, but it doesn't happen. The only thing we have is they say there's a military video flying over the North Pole, and it says it goes crazy and wonky. That's not how things behave. That's not how it works.
I think, you know what? We should try it. We should get us a bar magnet and a big styrofoam ball, and we should stick the magnet through the ball and get a compass and move it around and see what happens.
Try it. Try it. You're going to be shocked. Whether you stick it through a ball, wherever you stick it through, you're going to see that compass flip. There's no way around it. It's physically impossible for something else to happen. It has to flip. That's how magnets work. That's how magnetic attraction works. There's no way around that.
All right. Well, I'm willing to try that, and I'll
Please
report back
try
to
it.
you.
Try it and film it and see for yourself.
I'll report back to you. Fine, sir. My findings. Now, let me ask you a question. Let's see if you're a top thing, and we're gonna keep it very simple. I'm gonna ask it quick because I've been going over this for 2 hours. Right? North, right, is towards the center. Correct?
What do you mean
That's it.
north is towards the center?
If everybody on Earth, the Earth is flat now. We're on a flat Earth. If everybody walks north, we're all going to meet up in the center of flat Earth, right?
You mean geographic or magnetic? Which north are you talking about?
If we all walk towards Polaris,
Well,
We'll all be
yeah,
stopped.
sure.
We'll all be stopped by
okay.
Russia.
Okay. Assuming we don't get stopped by Russia or shot, we would all end up in the North Pole. Okay. So now we're all under Polaris. We turn around and everybody walks in opposite directions, right? We're walking south, right? Essie?
Okay.
All right. Are we walking in a straight line?
I don't know. Are you?
I'm asking.
You're asking me of a shape that I don't claim. You're asking me to make a prediction on that, right?
No,
I
I'm
don't get
saying
it.
if it was flat. I'm not asking you to claim something. We're just doing a thought experiment. If it was flat and north is one direction, if we turn around and we walk the opposite direction, we'll be walking in a straight line, right?
I guess, yeah.
All away from each other, right?
Well, yeah, if you picture a pizza disc, if that's what you're talking about a disc, a flat disc.
I'm just saying any type of flat, I don't care what shape it is. It could be a star, a disc, a triangle, whatever shape you want it to be. If north is in the center, in the middle, and south is opposite of that, if everybody was in the middle and walked away in different directions, we would all be walking south, but we would all be walking in different directions away from each other.
Right, in that scenario, but I don't claim that. Let's be straight out, right? That's not anything that I claim. But yeah, obviously, if you're on a pizza dish and north is in the center and south is all around, you'd be walking in different directions. Duh.
All right, thank you. And I'm happy that you put the duh on there. I hope all the other people who've been arguing with me for 3 hours telling me you could be walking in any fucking direction just heard that duh.
Yeah, but understand one thing. I don't claim that. That's not my idea, right? It's just
I know, I appreciate it. I'm not saying it is. I was just saying. I was asking people that they were saying, "Oh, you could be walking straight, or you could be walking into the left, or you could be walking to the." You know what I'm saying? It's like, damn, dog. It's not that complicated.
Well, let me ask you something then. On your ball, right? When does north become south?
When does north become south? When you cross over the North Pole?
You're walking north, right?
Yeah.
You're walking north. So at a point, north becomes south in your pseudo model.
Yeah. when you walk over the North Pole, when you cross the North Pole.
So you could be walking in one direction, and then from that it just turns to another cardinal direction. But you're still going in one straight line, right?
Yep.
Okay.
You're going in a circle, a great circle.
Let me ask you another thing. What time is it at the North Pole?
What time is it at the North Pole? Like right now?
Yeah.
I'm at North Pole.
You think you can recreate that in reality? Since we're playing the model game, right?
Why would it melt though?
Well, think about it. You think it's physically possible to have a frozen ball with one heat source and only heat the center of it? Do you think you can recreate that?
Yeah, because it's tilted. So all points on it's a sphere, so the whole thing isn't being heated evenly. You got the middle, which is again the most direct sunlight, which is why it's the hottest on the equator. And then you got the tops and the bottom, where the sunlight is just skimming it. And then you got ice there, which is reflecting a lot of that heat. So it's going to be cold there.
So you think just by tilting it, so you think like you have a campfire and you have a frozen ball, just by tilting it, you think you can just melt the center of it?
Well, I mean, that's going to be a little different because you got to understand that if we're sitting by a campfire.
How do you have a molten core right next to a sun that's supposed to be 0.3 million times bigger than the Earth? How do you have that and still have ice caps?
So what are you saying, that the molten core should just come up and just heat the whole thing and melt everything and burn everybody?
Over millions of years, you should have conduction, or heat gets transferred through the mass of the Earth. Plus, not only do you have the sun, you have the molten core, bro.
Try to do it.
That's what I'm saying. You can't. I can't create. I don't have an anti.
That's a new one. You can see gravity.
Before you get past his original claim there that you can see it, right? That's in question to begin. You said we see it. We see the entirety. We see that it exists with an atmosphere inside a vacuum. And I'm asking you, when you experience that.
Yes, when you fly an airplane.
No, you can't. You're telling me you can see the entirety.
Well, the Earth, no. That's not the claim I'm making right now. I'm talking about vacuum.
Oh, so the claim is which, okay, and your claim is that the Earth is exactly that, right?
Right. So when you're at sea level.
So you are talking about it. So you're talking about it, but you're not talking about it?
We're talking about, so what are you talking about? You're talking about the curvature of the Earth, or are we talking about pressurized system? Which one we're talking about?
We're talking about that pressurized system in a vacuum, and you say that we see it.
Okay.
And your claim is that we see it with Earth. And I said, okay, that's cool, Carl. Give me the time and date in which you saw that. You say you went up in an airplane, but you're not. You're just experiencing a small portion of something. So you don't experience that. You've never experienced that.
How don't you experience low pressure next to high pressure? How are you not experiencing that? When you're on the ground, you're in a high pressure system. And you go up in an airplane, now you're
100%. Yep. I never made that. I never made a claim that we didn't.
Okay.
So your claim, I'm blowing up your spot. When you're making the claim that we see this entirety, we see this ball that has an atmosphere in a near perfect vacuum. You say that we see that. We don't.
I didn't say that.
Okay, so then that's not your claim? So you're not claiming that then?
No, not then. I wasn't claiming it. You can see that, but that's not what I was talking about just then. Just then, I was
That's
talking
it. That's
about
SE's point, is about making that on a smaller scale. And you say that we see it, we experience it, but we don't.
you
It's
experience
speculation.
being inside of an atmosphere adjacent to a vacuum. You can see that.
No, I can't.
How can't you?
I experience everything within the atmosphere. Everything.
Okay,
The
so
atmosphere
if you
extends to the moon. I've never been past the moon. The atmosphere extends to the moon. So no, I don't experience that.
it does, but the vacuum starts way closer than that, doesn't it? In my model, does the vacuum start at the moon or before?
No. Well, give me, first of all, vacuum would have to deal with where you claim in a pressure system that vacuum starts. So give me pressure in which that
No,
starts, and then we can talk.
Vacuum in this situation is in relation to something else. So that's why when you see like those movies and shit where they poke a hole in and everybody gets sucked out, that's because they're playing.
Oh, so that's the vacuum. So within the Earth's atmosphere, so even below the Kármán line, you're in the vacuum. Is that your
that can be considered a vacuum? Yeah.
Okay. All right. Cool.
Are you guys denying the pressure gradient? Are we denying the pressure gradient
No,
today?
nobody is. Nobody is. Nobody made that claim.
So where does the pressure gradient stop then?
That's a good question.
Exactly. That's my point. So you got a high pressure system sitting on top. You got a high pressure system with a low pressure system right there, and that's the thing I'm saying you can see. And that's the thing you're telling me it's not.
You go from high pressure to gradually to low pressure. So
right,
where do you think the pressure would stop then?
Well, yeah, no, I'm not making that claim, right? So it's just a gradient. He's claiming that all of that could be considered a vacuum, right? What I'm experiencing right now, one atmosphere could be considered a vacuum compared to something that is of higher pressure.
That's dumb, but okay.
That's his claim, right? So if we're talking about that and we're talking about a gradient, that's fine. We experience high and low pressure differentials here on the surface at one atmosphere. We experience fluctuations in that of high and low pressure systems. That's what causes our weather.
So if you go, are you saying that when you go up in altitude, there is no pressure gradient?
No, nobody's making that claim. Carl made the claim that he has gone up and he's experienced from a vacuum something that has an atmosphere. So I'm asking him where he experienced that, what the height was. He said it's just in an airplane. So is that your claim?
So the
as
pressure
well?
is lower. The pressure is lower up there, isn't it?
That wasn't his claim.
Oh,
Yes, it was. That was my claim. That's why when you see an airplane
so
with a hole
if
in
I go up on my roof, the pressure's lower. If I go up on a 2-story building, the pressure's lower. So his claim means absolutely nothing. So what he's trying to claim here means absolutely nothing, because we're talking about creating on a smaller scale what we experience with Earth, right? So it's going back to SE. His claim is put it in a vacuum chamber and then experience these heat differentials that you're talking about, where you can have frost and frozen portions on the outside. You can have a molten iron, you can have a molten inside, and you have no heat transfer between the two of them, right? And Carl said, we see it, we experience it.
In a bucket in a lab, right? Got it.
Yeah, because otherwise it's just speculation. Like, I don't have to believe the bullshit story of it being a ball, that we can experience it from space because Robert Simmons made pictures in Photoshop, and you believe that it's true. Like, I don't have to believe in your delusion.
Robert Simmons. Wait a minute, hold on. So making a composite.
I don't have to believe your delusion.
Making a composite picture means all the pictures are fake when you put them together.
Hey, I can take a whole bunch of different pictures and put them into whatever shape I want, bro.
Is a composite image fake then?
It's not a accurate depiction.
Not an actual picture.
So a composite image is not good enough, right? That means anything you take with your cell phone is basically.
Because you know what, I can go high enough up and take pictures of my whole entire county that I live in, and I can wrap it around a ball. Does that make the county that I live in a ball?
Could also
They're real
put
pictures.
In a funhouse mirror game, you know? I mean, is that accurate?
Would it match reality? No.
Yeah.
If you took a picture,
it would be actual pictures of reality, right?
No, it wouldn't match reality though. Because if you took a picture of your neighborhood and you wrapped it around a ball, then it wouldn't match reality at all, would it?
Yeah, it would.
No, it wouldn't.
So you're telling me that images of my county that I live in are inaccurate?
If you wrapped it around a ball,
How big a
just your
ball?
county.
Okay,
How big
cool.
a
So
ball?
then we can say
How big a
Robert
ball?
Simmons
How big a
making
ball?
composite
How
image
big a
of
ball? How big a
high
ball?
altitude
How big a ball?
altitude
How
images
big a
and
ball?
wrapping around and
NASA,
wrapping
stop
them around
interrupting
a
me, bro.
ball.
Stop
I was
interrupt. We're having a good
in,
convo before you came in. Stop.
that's because I don't stand to be interrupted, just like you don't expect to be interrupted. But
You're interrupting me.
Napalm's responding
apparently
to
I can be
Carl. Just let
interrupted.
him go, dude. Stop him.
Apparently I can be
Let
interrupted.
Napalm respond to Carl, and
Yeah,
then you can go next.
That's double standard, right?
So Carl, when Robert Simmons made the claim that he took high altitude images and wrapped them around the ball, you would say that that would be an inaccurate depiction of reality, right?
You talking about the whole Earth?
I'm talking about. Can you just answer a fucking question, bro? Robert
You're
Simmons,
talking
you know
about
who that
you're
is?
talking about two different things.
How
You
big a
said your
ball?
neighborhood.
How
You're
big a
talking
ball?
about your neighborhood. Hold on, wait. You're
Was
talking
that my
about your
question about the
neighborhood.
neighborhood, or was it about Robert Simmons, or do you want to deflect from my actual question because it destroys what your claim is?
No, it doesn't. It shows your ignorance. And how big a
It
ball are you
is
wrap your
not.
neighborhood
No
around?
one's gonna get anywhere like this, by the way.
How big a ball are you gonna wrap your neighborhood on?
Let's say it's 3,959 miles in circumference.
Fine, then you would have an accurate depiction of your neighborhood.
Okay, sure.
Because you can measure that radius.
Cool.
No, you have
So
to
Carl, do you agree with SE, or I'm sorry, with NASA Shill, that you can take images and distort them, and that still is reality?
You don't distort them when you wrap them around the ball.
No.
Okay, so a flat image wrapped,
pictures.
so a flat thing wrapped around a round thing creates no distortion?
If you have a lot of, it's like depends how small the pictures are.
How big were the pictures that Robert Simmons was using?
I don't know. This is your claim, not mine. See, the thing about it is
Robert Simmons is just my claim that he exists and that he did this?
The very first blue marble was not computer animated at all. It was a real picture taken real film by real people.
Yeah, it was a real picture of a painting. I would agree with that.
It was a real picture of the Earth taken halfway to the moon.
Incorrect. It's a real picture of a painting. Prove me wrong. That's my claim.
Yeah, well, I know it's your claim, but we have the negatives. Yeah,
when you take a picture with a camera of a painting, do you get negatives?
Painting.
Do you get negatives?
It's a painting now. Got it. I love it.
Do you get negatives?
Wow.
When I take a 35 millimeter camera and I take a picture of a painting, do I get negatives?
What are you smoking to get this much denial? I mean,
you can't even answer a simple question. I mean, I've developed film. I've made pictures. I've done it for a very long time, and I know what negatives are, and I'm very experienced with that. And if I take a picture of a painting, would I get a negative?
Oh, it's a painting now. How do you know it's a painting?
How do you know it's not?
You just postulate. Right. How do you know it's not? Exactly. Typical flat earther.
So your claim has no more valid than mine because there's
What
negatives.
about this? It could be this. It could be this. It could be something fake.
It could be that some man flew all the way there, but nobody's done it since.
Oh yeah, we're gonna do it again. We're gonna do it again here in about 2 weeks, it appears.
Yeah, I was told we were going to do it again like 3 years ago, and I was told we were going to do it again 15 years ago. And I told we were going to do it again 25 years ago.
Yeah, it was a matter of money. It was a matter of money.
Oh yeah.
It was a matter of money and will. And it actually looks like it might happen here in 2 weeks.
Oh, in 2 weeks? Yeah.
2
you
weeks.
going? You flying up there, NASA Shill?
I wish I would.
You taking your 35 millimeter camera? You're going to get some negatives of that image?
I would do it in a heartbeat. Actually, they're not going to take negatives this time. They'll probably take,
Yeah, exactly. Well, you and Carl's spot just got blown up because you have to admit that you can't actually replicate what you claim Earth is in science. So you just take it as speculation.
I was talking. He interrupted me.
Yeah, I'm just going to walk away from this conversation because you're acting like a 5-year-old, dude.
Run away. Bye.
Yeah, don't argue with idiots because they'll bring you down to their level.
Exactly.
They'll beat you with experience.
I know, exactly. You're doing a good job of it. You're doing a really good job of showing your ignorance.
It's not my fault you lack the comprehension to understand the argument.
I lack the comprehension.
But you can just call names. You probably don't even know what that statement means. You probably lack the intelligence to understand that statement.
Right,
that's cool, bro. Go ahead and act like a 5-year-old with somebody else.
What's your background in science? What's your
fun.
background in science? Where are you working? A janitor or something? Like, that appears to be the. You're working on Sunday,
You
huh?
think I'm a janitor? I'm
I don't
more
know.
highly credentialed than you are, dude.
I
By the
doubt
way.
so.
I'm more highly
Oh,
credentialed
you
than
doubt so?
everyone in this room. I'm the smartest dude in the room, and I am a
Right.
janitor. So
I know. I got it. I saw. I know. I saw that documentary. What's
you
it?
didn't
Good Will
watch
Hunting.
Goodwill? That was a
Yeah,
documentary.
I
Yes.
have credentialing that's almost as high as medical doctors, but I'm sure you out
I don't
you're
believe
more
you.
intelligent than me, I'm sure.
NASA
Right?
surely knows everything because he's the smartest. Yeah, he's a scientist. Yeah, that's
I
what
don't
he's
believe.
saying.
I
Yeah,
don't believe you're
you're not a
credentialed in a heartbeat.
scientist. You're
A
a
medic.
Where
pseudoscience.
did you get your
You're a
science
clown.
degree from? NASA Shill?
Yeah.
Where'd you get your science degree from? And what level of science?
It's a master's degree. I'm not going to tell you where.
Master's in what?
Chemistry.
You have a master's in chemistry?
Yep.
Does that make you qualified to talk about astrophysics?
In a manner of speaking, yeah. I mean, it
Cool.
shows me that I have it.
No, it
shows
doesn't.
me I know way more about science than your average.
We've quizzed you on
sanitation.
science.
Here we
You don't know
go.
anything.
Look who's talking.
My wife,
the sanitation engineer.
My wife has her bachelor's in chemistry, and she doesn't even know what a covalent bond is. So that really doesn't mean
What?
anything to me.
She has a
I'm
bachelor's in
gonna start using
chemistry.
that.
Doesn't know what a
Hold on.
covalent
What'd you
bond is.
say, Paid? Paid. What'd you call me?
A sanitation engineer.
Yeah, I need to start Yeah, I'm gonna start using that one. All right.
Yeah. I saw Good Will Hunting. That was a very good documentary. I guess all janitors.
I got some questions on SR-71 if you want to. Napalm, did you want to keep this going for about 4 more hours with Paid? I got some SR-71 questions.
It's got a book on it. Yeah.
When you're linking up to refuel them in the air,
Yeah.
what call signs did you use? Like, what did you say to those guys on the?
They usually use the
radio?
Aspen call sign, and the believe it or not, when we did the refueling with the SR, we were pretty much radio silent, as much as we could be.
So no call signs.
They in the peacetime they were called Aspen, and we had differing call signs usually because that's the way they did.
So when you're reconnecting with them, you're that's the call sign you're using, or were you radio silent?
Oh, we were radio silent with them. There actually was we had a communication with them through encrypted channels. It was at the time was classified. I guess it's not anymore. They had some pretty
So
cool
you
equipment.
did have communication with them, or you didn't?
We did, but we weren't talking on the radios, if you will, using call signs.
But there were radio communications between the two of you?
Yes.
The refueling process is like a well choreographed thing. They do just hand signals and stuff. They don't talk to each other.
Right. We were well in a normal.
I was trying to trap Paid there. I already knew they were radio silent. I was trying to get him.
Yeah, most or less radio silent. We did have like I said, there was this basically it was a radio signal back and forth that was encrypted. We could tell distance and direction. It was pretty cool. We were the only ones who had it. But that's one of the things that made us unique. There were only certain certain tankers that were modified to refuel the SR. They were the Q models.
And they got rid of the SR-99, right? So that means something like that. Yeah, 99 was the last flight. Other places got rid of it a lot sooner, but the last possible.
Yeah, NASA. I don't know if they refueled the NASA guys or not. I'm not familiar with that. They probably did because they were so dependent on refueling.
So when was the last time you refueled the SR-71? If it wasn't in 99.
It was earlier than that.
Well, when?
Yeah, I'm not gonna tell you. I've already doxed myself enough.
Bro, how old are you? You got to be old. You got to be old, dude, because they're not letting the young gun. They're not letting the new guy fucking refuel the SR-71, right?
Actually, the new guys did. The refueling part. The younger guys. There were some pretty young guys there flying it. But they took the Q models and re-engined them and named them Ts. Although I guess they don't use the ability anymore to keep the body tanks separate from the wing tanks, which was basically what so you had the cool part about this is you had a connection they called a single point refueling system, right? That's the connection. That's the name of the connection. So the Q model tankers had two single point refueling connectors.
Did
Now
they
figure
use
that. That's
the point of contact? Was it magnets?
Magnets? No, it's a boom.
It wasn't like it didn't like you had to like stick it inside the thing
Yeah. I
like a
don't think it was
like you're
magnets.
at the gas pump with your car. You had to like actually get it in there.
Right, and then it would expand a little bit to hold in there. I don't think there were magnets involved. The boom system is the boomer. That was his system. You know, I don't think there was magnets involved.
I'd like to think there'd be magnets involved in that, just to
I don't think so.
just to
I don't
give it a
remember.
little clickiness, you know.
It went in, and then there was it would swell up a little bit. Okay, although see, you didn't want it to be fully connected because you wanted to be able to disconnect it if you had to.
Yeah, that's why the magnets would have been perfect.
Yeah.
Which
So
they didn't use. So I mean, I don't know. Did they? I have no idea if they use magnets or not.
I don't think so. I don't think
I
it was
would have put
magnets.
magnets on it. Like I don't know.
Well, then the thing about magnets is then you've got a magnet turn on a big airplane. It probably wouldn't matter, but on a small airplane, having magnets there might mess things up. But it was a pretty cool.
All right. Anyways, back. Let's get back to it. Napalm. 4 more hours with you and Paid. Let's go. Did anyone find any more cool game theory stuff? You guys didn't even look, did you?
Game theory for what?
I was just wondering if anyone found any cool game theory stuff. We were going over the angel problem the last couple days. That's pretty neat. And then we did the Monty Hall problem. I don't know which one that
Yeah,
is. The one with 3 doors and a 2 goat.
Yeah, then they changed the doors, and you're supposed to change your pick once he shows the doors. It's counterintuitive.
Yeah, I just told everyone to look for more cool stuff. Nobody listens to me though. What else we got? Does anyone have anything or?
That's where it technically ends.
All right, what's
Hold
the
on.
definition of the atmosphere? We want to know. We're trying to figure out when the atmosphere ends. So, what's the definition of the atmosphere?
The envelope of gases surrounding the Earth or another planet.
Okay, so you're saying that ends at the Kármán line. There's no more layers of gases enveloping Earth after the Kármán line.
But I mean, it's not a hard line.
There are no hard lines with gases. But are you saying at the Kármán line, that's when the atmosphere stops and there are no more layers of gases surrounding the Earth?
I mean, that's where the atmosphere is technically thin enough to where they consider it for the vacuum of space to start. Carbon.
And if it does end, if the atmosphere does end at the Kármán line, why is NASA saying that the moon is in Earth's atmosphere, which is way past the Kármán line? Like that doesn't even go along with what NASA's claiming.
Bro, I explained this to you like a year ago.
No, I just rebut what I just said though.
No, what they're saying is that there's particles of the atmosphere that extend out to the moon.
No, they said the moon is in Earth's atmosphere. That's verbatim from NASA. Not whatever you just said.
First of all, when you start listening to NASA, and second of all, bro, they're just
It's
saying
an
that there's
internal critique.
particles. They're
It's an
just saying there's
internal critique.
particles of the atmosphere that reach out to the moon, bro. They're not saying the moon is like in Earth's main atmosphere, bro.
They are literally saying the moon is in Earth's atmosphere.
Well,
Verbatim.
the Kármán line, it kind of changes depending on who's defining it. So, like the French, they choose 100 kilometers as the standardized boundary. The US often uses 80, but like calculations say between 80 and 120 kilometers. But the concept is like, it's like a range. It's not really like a line.
Yeah, because it's a gradient. You know what I'm saying? So you're trying to put a hard line on something that doesn't have a hard line.
Right, but
Yeah,
your
so like at
model
least they
says
took
that
on the challenge of like where does atmosphere end and or like where does air end and you know, death vacuum of
outer
space
space.
start. Yeah. You don't really have the Kármán line because that's a range. So you don't have that.
Right, and you got inner space and outer space now, so this is going to be fun.
I'm saying if
Somebody
y'all
explain
understand that,
the.
if you understand that, then why ask where the atmosphere is? You understand that it's a gradient. Like it doesn't just like there's not one point we can point to and say, okay, here is here, and this is where the atmosphere is. The
So
closest
you're
thing
saying
is
it
the
goes
carbon line.
forever. You're saying it goes forever.
It doesn't go forever.
Well, where's it end? You just said there's nowhere you can point and say it ends. But now you're saying it doesn't go forever. So which like
I mean, I'm sure it doesn't stretch all the way out of the solar system or some crazy shit, but I mean, you can find somewhere super far away from Earth and you might find one particle from Earth's atmosphere there. You know what I'm saying? Like it's a
So
gradient, bro.
how do you reconcile gases moving freely but also being stuck to or near
balls.
Earth?
Stuck to balls.
Gravity.
So it allows it to escape so far that you can't tell where it ends, but it's also stuck.
Yeah, some particles of gas escape, yes.
Yeah,
Some
I mean
do.
there's
Some
the
are some are stronger.
geocorona, which is like it's like a
Oh.
cloud of hydrogen, which is considered to be a part of Earth's atmosphere. That's why people say that the moon is within Earth's atmosphere.
NASA. That's why NASA says it. NASA specifically. You're going against NASA if you say the atmosphere ends at the Kármán line. I'm just saying.
Yeah,
No, I
do
ain't
you
saying that
feel
at the
like the
beginning.
moon is within Earth's atmosphere?
Technically speaking,
Okay,
they
so
have
then before
particles
when
of
you
the
said the
atmosphere that reach
Kármán
to the
line,
moon.
which is like 80 kilometers to 120 kilometers to try to like get a point where Earth's atmosphere ends, you're not even close. You're off by like at least 2 miles.
No, I was just using it as that's where they usually say space begins. Is at the carbon line. They consider that now you're in space.
Yeah, the
But the
question was like
atmosphere,
how far does Earth's atmosphere extend? And if you say like 80 to 120 kilometers, the moon is like at least like 10 more miles away from that. Some people say the moon is 238,000 miles away. And if you say like 80 to 120 kilometers, you're off by like at least, let me do it, like 5 miles, at least 5 miles.
I'm sorry for thinking that
At least
Daniel was
5
asking
miles.
me. I should have known that two motherfuckers weren't asking me a good faith question.
No,
No,
it
we
is
I
a
should
are.
have
good
We've
known,
faith
asked
bro. I
question.
walked into the crowd. It wasn't a good faith question, bro.
It is
we've
a
asked
good
this
faith question. A good faith question is a question that's aiming to lead towards a conclusion. A bad faith question is a question that forces a non-conclusion.
Yeah, you're asking me a bad faith question because you're trying to catch me in a technicality, bro. I
No,
thought he meant Earth's main
he asked the
atmosphere.
question, where does the atmosphere end? And if you said, well, some people say the geocorona even encompasses the moon, I think you would have said, okay, you agree with NASA's position then. It's not a bad
Pretty
faith
much,
question just because
basically what
like
you're
just
doing.
because you don't know the answer to a question doesn't make it a bad faith question.
Bro, I do know the answer, but pretty much what you're doing is you're saying we're at the beach and you're saying, "Hey, Carl, what a beach in?" And I point to the parking lot, and you say, "Well, they got some grains of sand, over there at that gas station a mile away from the beach. So is the beach there?" That's pretty much what you're saying, bro.
Hold on. You got a positive claim that there's a magic barrier somewhere, and then somebody asks you how
whoever that
and
is,
what
a
it's made out
robot.
of and where it's at, and you're like, I don't know, it's up there somewhere.
You're a robot. I didn't hear what you said.
But
He
your
wasn't even a
position is a
robot at that.
positive
That's just
claim,
how he sounds.
though.
You're a robot.
I mean, it would only be bad faith if you were insisting that there has to be a sharp boundary and then using like the lack of a sharp boundary to disprove the concept of an atmosphere. But
No,
you're
you're
asking for a boundary in every context that's reasonable.
no, you're asking me where the atmosphere is, and colloquially, right? When we talk about the Karman line, that's technically where they say space begins. Okay, and then you say, "Well,
No,
Carl, NASA
technically,
said that the moon is in the atmosphere." Yeah, okay, they got particles of the atmosphere that reach out to the moon. Okay, you got it.
you said
Congratulations.
technically the Karman line, but no, technically, you're not going to get more technical than NASA, right? And they say technically the atmosphere, encompasses the moon. So
Right. Why do they say that? Because they have particles of the atmosphere that reach out to the moon.
because the atmosphere goes as far out as the moon, yeah, not the Karman line.
Oh, but you can say the same thing about the beach. Oh, they got a grain of
We're
sand
not
over
talking
here.
about a beach, dude. We're just saying
Yeah,
But
about
it's
the
the
I
beach.
same
could easily
principle, bro.
invalidate the beach analogy if you want. So like the beach is a human defined category based on like loose criteria. So you have like the slope, the shorelines, and the usage of it. So like that's dependent on context. The atmosphere is vague due to what's called physical continuity. So it's a real physical system governed by gas laws and allegedly gravity, which it has measurable properties. That like those change continuously and predictably. There's no sharp boundary. The beach has a sharp boundary.
Does it?
Yes.
Okay, so if I find so where does the beach end?
Probably at the boardwalk.
Okay, what if they got sand across from the boardwalk? Would you say the beach is over there, even though there's sand from the beach over there?
Okay,
No.
so that's like
So that's the
asking if I
same
go to
thing.
the park and my child plays in the sandbox, and then we go to the beach and there's sand in the parking lot, and my child sits in it. Now my child is in the sandbox.
That's what I'm saying. That's where you're saying when you say the moon is in the Earth's atmosphere.
No, it would be ridiculous to go to a parking lot with sand in it after I was in the sandbox with constraints, and then I'm in the parking lot with sand in it, and my child sits in it, and now he's still in the sandbox. No, there's physical constraints.
Oh, you're talking about a sandbox. I'm talking about the beach. The beach doesn't have a constraint.
Yes, it does.
Oh, it doesn't.
Yeah, there's usually a boardwalk and then a parking
Did,
lot.
did, did, did beaches exist before boardwalks and parking lots?
Yeah.
Okay, so before the boardwalk and parking lot was there, let's say you found some sand, you know, far away from that. Would you say, "Oh, there's the beach over here"? The beach extends this far because you got a little sand from the beach over there? No, that's what I'm saying. That's the same thing you're telling me when you
Wait,
say
that's
the moon is in Earth's
that's his
atmosphere.
argument. You're getting lost, bro. That's what he's saying. It's physically constrained. You're saying it's not.
No, the beach isn't physically constrained. What are you talking about? The beach isn't physically constrained.
He's saying there's a hard line where we say the beach ends, and you're trying to convince him that because there's sand somewhere. Like you're not following.
No, I
Yeah,
am
like
following. So
this is actually kind of weird that we're taking it to the beach, but I'm trying to invalidate how this like isn't a good analogy. So like a beach has sand, and then at the end of the sand sometimes there's gravel and dirt, and then sometimes there's grass. If this grass is a mile away from the sand and the water, and I'm sitting in the grass, and there's no more sand past the grass, the beach has definitely ended.
okay, well, if you find like 2 grains of sand in the grass, you want to say you're at the beach, right? So that's what I'm saying about. I'm just using it's a loose analogy,
That
bro. That I'm
proves
using.
my point.
Okay, well, I'm using it as a loose analogy, bro, because he's saying that the moon is in Earth's atmosphere because you have particles of the atmosphere by the moon. They scatter out that far, but
Oh,
but it's
NASA.
not the
NASA is
main
saying.
atmosphere.
NASA is saying the moon is in Earth. Not me. NASA is saying it.
Yeah, but I'm telling you the reason why they say that is because you have particles of the atmosphere by the moon.
Okay, that's fine. So when you said at atmosphere ends at the Kármán line, clearly that's not correct because NASA's saying it goes out to the moon.
Okay. Well, if you consider a couple of particles of the atmosphere being out by the moon, the Earth's
Not
atmosphere
me.
is fine.
NASA does. Not me. NASA.
Well, okay, well, fine then, NASA. There you go, NASA. Let's appeal to authority now. Let's appeal to NASA.
Well, yeah, I
But
asked in the
that,
heliocentric model, when does the atmosphere stop?
NASA
isn't
is
that
not
exact?
the herald of the. That's the problem. Y'all think NASA is just like the almighty herald of the fucking heliocentric model, and they're not. It existed way before NASA, and it will exist after NASA.
Who better than to say when the atmosphere is than NASA? They're the only ones that's even been there. Who's been to the
No, they're
moon better
not.
than NASA?
It's yeah, that's weird to say we're appealing to it when literally where you get the carbon line is from NASA.
Oh, it's not. It's other people who have. They have different countries have different places for carbon lines. The other guy just came in here and said that.
Yeah,
You
the
do
Well, if
understand
carbon
that
NASA says,
line.
there's. You do understand that all cosmologists and people who study this shit are not with NASA, right?
so you're saying there's
Okay,
other people
you're
out
just saying a
there.
different. You're just saying a different government space program. The concept
No,
is
I'm
the
talking
same, though.
about
That
in America. I'm sorry, I didn't mean to cut you off. Go ahead. I'm sorry.
no. I'm saying you're saying other countries do it too. But our point is that you're saying we're appealing to someone when you're the one appealing to other people to tell you where the carbon line is.
No, what I'm saying is there's other cosmologists that are United States citizens that don't work for NASA.
So what?
Just
And they
because that's I'm
That doesn't
saying
make sense.
just because NASA says that the moon is in the Earth's atmosphere because we have particles of the atmosphere that reach that far doesn't mean that everybody agrees to that and gotta adhere to Almighty NASA. That's not how that works. They're
Okay, so
being
you can't appeal to
extremely
the
technical.
Okay,
carbon
so
line.
Okay, are you telling me
So wait, we
NASA's
didn't
wrong
land on
when
the
they
moon.
say when NASA says the moon goes out to the atmosphere? You're telling me they're wrong, and these other guys that have never been to the moon, they're right.
I'm saying technically, bro, if you want to say because they have scarce particles of our atmosphere by the moon, if you want to say that that means the moon is in Earth's atmosphere, then you can.
No, I don't want to say it. NASA said it, not me.
Right.
NASA.
If NASA wants to say that, then they can. But I'm saying that's tantamount of me saying, hey, there's sand over here, therefore the beach stretches this far out.
No, it's not. Nothing like that. Nothing like that.
Yeah, it's the exact same thing.
Literally, not the exact same thing. If it was the exact
Well, it
same
is.
thing, we'd be talking about space and gas particles, not sand at a beach.
Well, I'm saying particles of sand. The wind blew particles of sand across the street, so the beach is over there now. That's the same thing with the atmosphere. Oh my God, the atmosphere has scarce particles, 2 or 3 particles over here by the moon. Oh my God, it's in Earth's atmosphere.
Wait, hold on. The wind is blowing by the moon?
No, well, solar wind.
Well, I mean, you're saying our atmosphere is particles. That would be gases, like the wind,
Right,
right?
right,
Or near the
right.
moon, which
Yeah.
means it would be in our atmosphere then.
Wait, what? No, I'm saying that the Earth loses part of its atmosphere, parts of the atmosphere, and some of them stretch out to the moon. A very scarce bit stretches out to the moon. And that's why NASA say, oh, technically the Earth is the moon. I mean, the moon's in the Earth atmosphere, technically.
No, they're not saying there like happens to be a few Earth origin hydrogen particle atoms out there. They're saying there's a continuous gravitationally bound distribution of hydrogen. That's what the geocorona is. That's not saying there's a continuous gradation of sand from the beach to my house just because I have some sand in my shoes and I took off my shoes and I dumped some on my house. There's not a continuous gradation. So no, it's not analogous. Stop bringing up the beach analogy. It's stupid and wrong.
It is because, well, I mean, outside of the beach not having its own gravitational field, of course, those particles are going to be around the Earth because the Earth has a gravitational field, the moon's sitting in it, so those scarce particles are going to be sitting in it too. But what I'm saying is, you're talking about very, very few particles. The moon sits
No,
in a
that
near
you're
perfect
talking
vacuum.
about disconnected material versus continuous, like a continuous gradation process. So like if there is a trail of sand that extended out in a circle from the beach to your house, in other words, your house is on the beach, then yeah, your house would be on the beach, but that it's not analogous. There's no gradient tied to the beach. This is a gradient tied via the geocorona.
Okay,
The
so they have a
particles
beach.
originate from Earth's atmosphere and they continuously and uniformly go out. That's why they call it part of the atmosphere. Not because they
Okay,
found some particles out in space, so like, oh, the atmosphere goes out as far. No, it's because there's a continuous chain.
yeah,
And
it's
they're
scary.
held by Earth's gravity, according to your model.
There's a definitive line. If we go to like somewhere like Daytona or something, or Jersey, whatever, there's places where you can definitively say, I'm not on the beach because you're standing on a street.
Right, so within the globe model, the geocorona is like this. It's a high density near Earth. It gradually decreases outwards. There's no gaps, there's just thinning. In the sand example, it's very dense at the beach, and then there's zero stuff in between. There's roads, grass, boardwalks, houses, parking lots, etc. And then suddenly there's some sand in your house because you took off your shoe and sand is in there. The beach doesn't extend to your house just because there's some sand in your house. I'm
All
just
right, but
saying,
do you
throw away
know
the
how
beach example.
little
It's real bad.
we're talking about trace amounts of atmosphere out to the moon, bro. Trace amount atoms. That's what we're talking about,
No,
bro. Yes, we are. All right. Fuck it. Oh, I'm not gonna argue this no more.
no, it is a steady, uniform gradation
Bro,
in
it's a
your
trace amount
model.
of atmosphere. Let's look it up, bro. Let's look it up. Is there any other glober in here besides me?
They don't want no part of this, Carl, because
It is a
this shit is
continuous,
crazy.
gravitationally bound distribution of hydrogen.
Let's see.
Yeah, I'm a Glover.
Oh, there we go. Matthew, where's the atmosphere stop? How high?
It's hard to define. It's like saying when does a hill become a mountain? It's sort of a gradual thing, so it's not. I don't think it's that interesting the topic.
How,
There you
how
go.
much of the
It's
atmosphere is
gradation.
out to the moon? How much
Matthew doesn't
of
think
the
it's an
atmosphere? No,
interesting topic, and he doesn't know. I think that was his answer.
no. Ask Matthew
Matthew,
how
do you
much
But
think
of
that do you
how
believe
much.
in like the geocorona being like the gradual, slow, gradual, decreasingly outward, and it encompasses the moon?
I don't know. This is the first time I've heard the word geocorona, but it sounds plausible.
How
So
much of the
basically, the
Earth's atmosphere?
geocorona initiated from a guy named Igor Balukin in the Journal of Geophysical Research. He used SOHO spacecraft data, and they found Earth's hydrogen cloud extending to about 630,000 kilometers away, which is obviously far beyond the moon's orbit, which is like 380,000 kilometers. And it's a very diffuse hydrogen envelope. So it's like a very slow, gradual extending from the ball.
Yeah, that sounds reasonable to me. I don't know if I'd call that atmosphere though. It's just like little bits of particles and stuff.
Thank you. Thank you. Oh my God.
Okay, if that's not the atmosphere, then when does it stops before the geo corona or like what?
Yeah, it would stop before that, but I don't know if you could define it. Like, how high does a hill have to be before it's a mountain? It's the same kind of question. Like,
Yeah,
well,
it's a
It's a,
gradation question, but the geocorona is continuous, it's connected, and it's a physically modeled system. So it's not like the beach analogy that Carlito brings up is like, where does the beach end? I mean, if in the parking lot there's some sand, isn't that technically still the beach? It's not as if you found a disconnected part. This would be a connected part of the modeled system.
yo, listen to this. It says at the moon's distance, there are only about zero point 0.2 hydrogen atoms per cubic centimeter. Do you know? Do you understand that if you went outside across the street from a beach and found 1 grain of sand, that's more than
It's
the
not
atmosphere you can
finding
find
one
on the
grain
moon.
of sand. It would be finding like sand slowly diminishing to no sand, but you've never found the no sand point.
Bro, do you know how much zero point 0.2 hydrogen atom is? 0.2 of an atom per centimeter. You know how little that is?
Not a real thing. It's not even a real thing.
Oh,
That's
now
just
it's not
like
real.
saying that when it's windy and then
Point two of an atom.
some of the sand blows a few miles down the beach, inland from the beach. That look, we found the beach still goes 2 miles away. We're
That's
finding
exactly what
sand
I
from the
said.
beach.
No, that's the
Oh my
issue.
God,
That
that's exactly what I
analogy
said, bro.
doesn't work because if so, like the beach ends, right? And then there's a boardwalk and a parking lot and a road and then your house. If you take off your shoe and dump out some sand in your house, that's not the beach.
You just got dirt on your floor.
You have sand on your floor. This isn't analogous because this is a continuous, connected, slow gradation of hydrogen.
Gradation.
0.2
Yeah,
atoms
that's like a
per
gradient.
centimeter. 0.2 atom.
Talk to
0.2
us.
hydrogen atoms per cubic centimeter, bro. That's what
That
we're talking
doesn't.
about.
Okay, so what?
So you go to
Do you know
the
how little
Wikipedia
that
for
is?
the geocorona. The geocorona is the luminous part of the outermost region of the Earth's atmosphere, called the exosphere. It is seen primarily via far ultraviolet light from the sun that is scattered from neutral hydrogen. It extends at minimum 15.5 Earth radii and probably up to about 100 Earth radii. For context, the moon is approximately 60 Earth radii away. The geocorona has been studied from outer space by asteroid satellites and the Galileo spacecraft using its ultraviolet spectrometer during an Earth flyby. It is a gradation. It is not just they found some sand in the parking lot, therefore, like it's a ridiculous. Just throw away the analogy. Stop being stubborn. It's a bad analogy.
Well, I'm telling you, while the atmosphere reaches the moon, it's extremely thin. It's nearly a pure vacuum, and there's zero point 0.2 hydrogen atoms per cubic centimeter.
Okay, so now you've
That's what it
changed
says.
your argument from they found some hydrogen particles, therefore you guys are saying it's the atmosphere. No, it's a gradation. It slowly goes down and down to that point. That's just the furthest they've measured it to be. That doesn't mean they randomly found Earth hydrogen particles out there as if someone dragged sand into the parking lot and then was insisting that the beach extends that far. So I'm just asking you to stop being stubborn, throw away the analogy. It's weak. And it's actually
So
like
does
it
it?
really
Hold
obfuscates
on a
any like
second.
productive
So
discussion.
Gally does. So then the uh, the forces that are driving the hydrogen, 600,000 kilometers out of the extending the geocorona that far. The forces that are driving those hydrogen molecules are are those coming from the Earth, or they are from an external force outside the Earth that are driving that?
I don't know. Why?
So if I was to scoop up some sand and put it in my car and drive it, start driving it away, are you going to say that, oh, look, it's extending the beach? Look how far I just drove this sand. Now
No.
the beach from
I
California
specifically
is in
said
Texas.
no. But that's
Because
not a
the reason why it
uniform
extends so far is
gradation.
because the solar
See, like
wind
the
is
analogy
picking up that
doesn't work because
hydrogen
that's
and
not a
carrying it away,
uniform
right?
gradation. So if the beach
Thank you.
uniformly, slowly had less sand particles that extended out all the way to everyone's house, and you could trace them back, and you see there's more sand, more sand, more sand, more sand. Now we're at the beach. Then yeah, you could say that the beach does technically extend that far out. But if you picked up some hydrogen particles and you went out a bajillion miles and dropped them off there, no, the atmosphere, that's not proof the atmosphere is extending. And that's the analogy. It's a horrible analogy. And you guys defending it is ridiculous because I'm
Yeah, this
steel
is
manning
so
your
bad.
silly
It's like
models.
sandstorms that go
This is
across the
bad.
Middle East carry the sand for like thousands of kilometers, right? The wind picks up the sand and carries that sand for thousands of kilometers, right? So then you would
Jeremy, do
have
you
to
see
see like
like
the
the
Sahara
blatant irony
Desert.
that defending this claim is actually undermining the globe claim? It's ridiculous.
No, it's
That
not.
doesn't undermine the globe claim in any way.
It's a very simple concept, bro. We telling
No,
you,
the
bro,
beach
the
claim. The
reason
beach claim
why.
is ridiculous.
No, it's not. It's very analogous because the reason why, like he just said, the reason why you
Okay,
even
tell
have
me what a
particles out that
gradation
far.
is.
Oh my God, you just gonna just cut me off. But anyway, the reason why you even have particles out that far is because they're being ripped off and pushed out by the solar wind. So if you have a beach and some wind blows and it blows sand across the street, you're not gonna say, "Oh, across the street there, that's the beach over there," because the wind is blowing the fucking sand over there.
Okay, how about this? How many atoms per cubic centimeter would roughly would you say the atmosphere ends then? How many atoms got to be there?
Like saying
Me personally, I take the definition of the Karman line, bro. That's what I do.
it's just like saying how many grains of sand you have to stack before a hill becomes a mountain. It's the same kind of stupid question.
Well,
Okay, so
roughly. I mean,
do you say that if I have sand in my shoe and I dump it out in my house, that is part of the beach? Jake and Carlito, is that part of the beach?
No, that's what we're
Okay,
telling
so
you.
if you say no, the geocorona is the luminous part of the outermost region of the Earth's atmosphere. You are undermining the globe claim with your beach analogy.
You're talking about putting sand in your shoe. I'm talking about the wind blowing some sand.
If the wind blew sand uniformly outwards, the beach is extended, yeah. But you were talking about sand in a parking lot and sand away. You could still call it the beach, like as if it was just randomly distributed outside of the confines of the beach. That's not what's going on here.
So when a sandstorm blows the sand across the Sahara, and then that sand starts landing into cities outside the Sahara, right? Regions outside the Sahara. Would you then say that the Sahara is now in that city? That the Sahara Desert came to that city, or the Sahara Desert is in that region that's no longer considered the Sahara Desert?
Is it a continuous density gradient of sand, yes or no? And I can answer the question.
Make sure you get dinner. Yeah, bro. It would be.
I mean, it's going to be times where the wind is blowing strong and
Super
times when it's
simple
blowing less
question.
strong, which is the same with the sun.
I'm trying to
Right? The
answer your
solar wind.
previous question, so I don't know why you're making another claim. Is it a continuous density gradient or not?
Yes.
Yes?
Because you'll have a little sand in the city. You might find 1 grain of sand in the city. Then as you walk towards the Sahara Desert, oh shit, I found 2 grains of sand, 3 grains of sand. Closer you get to the desert, you're gonna find more and more sand until you hit the desert.
Okay, so then the claim that Earth's atmosphere even ends might be ridiculous because you never know if you find like micro, very, very small molecules of Earth's hydrogen atoms. So you
No,
could
you're
never
taking.
claim that Earth's atmosphere ends then. If that's your
No,
metric,
that's not my metric. You're taking something science is saying,
then
and you're
your
trying to twist it
analogy
to make.
fails. How do you not see how
No, listen,
stupid
bro.
this is?
Because you are trying to take something science says, and you're trying to twist it, right? You're trying to twist it into something else. And I'm
How
telling
have I
you,
twisted anything?
when they say that that the moon is in the Earth's atmosphere, they're saying that there's particles of the atmosphere that stretch out to the moon. You're
Via
taking
a
that.
continuous density gradient, and you tried to use something that was split off, like taking sand from a beach and dumping them out in the parking lot and saying that's similar. It's not similar. It's a continuous gradient.
Then we'll have our dinner. Forget about it. You're
Eat in your
purposely
hot,
not.
Megan.
You're purposely not trying to get it. That's what you're
No,
doing.
your analogy sucks, and you're just stubbornly sticking to it as if it's good. And I could answer Jake's question if he answers my question. If it's a continuous density gradient, then yeah, it would still be a part of the desert.
Bro, my analogy's sick, bro. It's one of the sickest analogies ever
Your
in this.
analogy is horrible.
God has somehow forgotten.
Eat it in your hot mic, brother.
Well, sorry, guys.
Super sick analogy, bro.
Yeah, you're just being stubborn. Your analogy is really bad, and it obfuscates the actual conversation.
Bro, we're talking about 0.2 atoms. 0.2 of an atom per cubic centimeter, bro. That is less than 1 grain of fuck. That's less than a grain of sand.
Is it a continuous density gradient from the Earth? Yes or no?
Define gradient. Define gradient.
Slowly
You see-
dropping from one thing to another, or slowly
Slowly.
increasing from one thing to. Don't interrupt me while you ask me to do a thing, Zanuck. You just got here. Chill out.
Go ahead.
I got the
Wait,
definition here.
he wasn't done.
The definition. You want a
Hold on.
definition?
He wasn't. No, I want to know his because he said something slowly.
Wait, are you saying there's different definitions? What gives the words
Oh,
meaning?
yes, there are. There's different rates. What is the rate of this decay of the atmospheric density? Do you know it?
Okay, that is the
Yeah,
definition.
70 atoms per centimeter cubed.
How many atoms per centimeter cubed?
Zanuck, wait, do you know the topic on the table? The topic is it analogous to say that just because there's hydrogen atoms near the moon, that's equivalent to if I have sand in my shoe and I dump it out of my home, it's like saying, oh, well, the beach extends to my home because there's sand in my home. No, it's not analogous because that's not a continuous density gradient. But if the beach slowly dropped down and down and down with sand and then less and then less and less, then yeah, it would still be the beach until there's no sand. So that's why it's
No,
not
that's the
analogous.
analogy you made. That's not the analogy we made. That's the analogy you made.
You're making two distinct analogies, which both have a lot of truth in them. For example, the reason that some of these hydrogen atoms or helium atoms would then maybe get out as far as the moon and not and remain in orbit is because maybe they had a collision. So maybe it's analogous to the guy with the sand in his shoe walking 1,000 miles and dumping the sand out. Is that part of the atmosphere? Well, yeah. Why? How did it get there? Well, the guy drove his car and took a plane and got out to his house and dumped
Via
his shoe out.
continuous gradient,
So
not a random
it's not. So
distribution
it's,
of
hold on.
atoms
This
near the
is where
moon.
you're incorrect. It's not a continuous gradient, meaning in a equal rate of decay. That's what you're implying.
The
I don't think anyone's
geocorona
ever,
is a continuous gradation. A tenuous spreading cloud of neutral hydrogen atoms forms the outermost layer of Earth's atmosphere, representing the transition from the atmosphere to outer space. Source nrl.navy.mil. It is a continuous density gradient. The hydrogen density decreases with distance, starting from the exobase, roughly 600 to 10,000 kilometers, and extending outward. Density drops from 70 atoms per centimeter cubed at 60,000 kilometers above the surface to approximately 0.2 atoms per centimeter cubed around the moon. The geocorona stretches to at least 100,000 kilometers, or up to 630,000 kilometers, roughly 100 Earth radii, which is beyond the orbit of the moon. It is a continuous density gradient.
Does it ever just stop? Is there
You have a rebuttal?
Does it? Yeah. Does it ever just stop? You're saying it's continuous. It means it goes all the way out to
Okay, so
Mars?
how is the beach analogous, Zanuck? Because that's the topic on the table.
Because
Do
that
you
is
think the beach is
well,
analogous?
because the
Yes or no?
forces are known for what happens with sand, and or there's distribution statistically what happens with sand at the beach rolling out to the inner cities. But we're talking about some statistical analysis of these atoms that will statistically spread out exponentially, and that rate of exponential decay is not consistent. It's not a constant. It's variable.
It would only be analogous if beaches
Even though it's
never end.
exponential, hold on. Even though it's exponential, it doesn't have a predictable or constant rate of decay. It
Yes, it
varies.
does.
No, it doesn't actually.
I read the
You
predictable
misinterpret what you
constant
read.
rate of
It's not
decay.
constant. It's not a constant rate.
I could
Yes,
see why
it
the
is.
logic could be non sequitur too from what they're saying, because if it is the case that I have sand in my shoes, therefore I went to the beach, I could see why the analogy, why their theory would fall apart, because it seems non sequitur. Like they're saying a thing that does, and then they're concluding with something that doesn't follow, which is a definition of non sequitur.
Yeah, there's a lot. There's a lot of areas of space that have zero particles. The rating is just it's not an even distribution. And it's not an even decay. There's sometimes one atom per cubic meter. Sometimes even worse than that. One atom per multiple cubic meters. There can be in the same area or distance from the Earth because it's more
All
of a
right, Zach,
statistical
I'll walk
analysis.
you through an analogy. You tell me when the beach ends, right? You're at the beach, hanging out with the kids, right? You're on the beach, near the shore, right? You go to the boardwalk. Did the beach end?
The beach never ends.
All right, there you go.
You're done.
You're done.
Because it always make its way farther across the boardwalk. Wind, just like the interactions between
Well, I could
atoms.
keep going further and further, right? So like
Yeah,
you're
can't.
in
You
the
can't.
parking lot, did the beach end?
So it's a silly. It's a silly bit because we're with the definition and have one sand catches the wind and it blows out to Kansas. Is that still the beach? Well, yeah, by definition, it's
Wait,
still
are you
part of the
Suzanik? Are you saying life's a beach?
life's a
Life's a beach.
beach. And then you die.
So you would agree with what NASA was saying then, that the moon is in the atmosphere because there's specks of atmosphere out there?
Yeah, technically yes.
Okay,
Well, I
so
mean, by
you're not even on Carlito's side then.
Yes, he is.
No, you're not.
Wait, what? You've just been fighting the whole time that because there's a couple specks that's not the atmosphere.
No, I haven't.
Yeah,
Yes.
that's why I said
What?
your analogy undermines the globe model. Anchovy's been tracking.
You
Oh
don't
my
understand what I've
gosh.
been saying. Jeremy asked me, listen, you said
Oh
that the
my
moon was in Earth.
gosh.
You said the moon was in Earth's atmosphere. I said saying the moon is in Earth's atmosphere. It's like the only reason they say that because you have trace amount of particles that reach out that far. It's like blowing sand off the beach with some wind and saying, "Hey, it's some sand over here. We're still on the beach." That's
Yeah,
why NASA says that shit.
All right, let me see if you're tracking. What was my rebuttal to that analogy?
Fuck, I don't even remember, bro. It's been so long. You said some stupid shit.
I
Bro, you're
repeated several
This is
times.
like a gotcha conversation, right? It's all like, oh, I gotcha.
This kind of
Hey,
is
it
the
was like
issue.
a
So
dumb
like
thing.
you say that I'm engaging in bad faith, but you don't even know what my rebuttal was to your beach analogy. So I can repeat it for you and you can tell me if it fails. Okay?
After you do that, can you tell us what your real point is here? I mean, I'm really curious as to what the real true point is. Like, what are you objecting to, or what are you actually saying? After you
I mean,
answer that.
Jeremy was asking where the atmosphere ends, and I brought up the geocorona, which is the luminous part of the outermost region of Earth's atmosphere because of the continuous gradient. And I would say that according to that model, the atmosphere extends past the moon.
and
No, that's not what happened.
it exposes the kettle logic of the globe.
No, that's not what happened. Jeremy asked where the atmosphere is, and I said the Kármán line, and then he said, "Well, NASA says that the moon is in the Earth's atmosphere," and I said the only reason NASA says that is because they have particles that stretch that far. And I said, like a beach, if you blew wind, you know what I'm saying, cross the street, just because you find a grain of sand, would you say you're still at the beach?
Yeah, but you were
That's
making the
what
point. You were making the point to disagree with NASA, right? And that your line is the carbon line, and NASA's. You know, you even brought up all these points about NASA's not the only country doing this, and
Yeah,
like,
I
come on,
said
bro,
they're
you're
And then
backtracking.
Zanuck directly
technically.
refuted your
No,
analogy
no,
because he said the beach never ends, not at the
no.
boardwalk.
Yeah,
I said
I'll show you
after.
why. Just gonna show you why one more time why the analogy fails. So to say there happens to be a few Earth origin atoms out there is like saying, well, there's a couple grains of sand in the parking lot. You're describing disconnected material. There's no like continuous transport process that links the parking lot to the beach. There's no
Yeah.
gradient tied to a single governing system. So
There
when you're talking about
obviously
the
is.
geocorona, it's particles that originate from Earth's atmosphere. They're held by Earth's gravity, and their distribution is shaped by radiation pressure, escape velocity, solar interaction. There's a causal chain. With the
missed one.
parking lot, there's no causal chain.
There is.
Right,
You left that.
because I said that the beach doesn't have a fucking gravitational field.
So
Right?
now Danik says there is, and you said right. So are you guys agreeing or disagreeing?
We're agreeing that
That
those
says
you
there is
left out something critical there. Yes, there are some causal instruments, and yes, there could be thousands and thousands and millions of people all walking in the parking lot distributing sand granules in that parking lot. Just like they're not just solar effects and other types of escape velocities. What are the escape velocities caused by? These collisions. So these collisions are very analogous to someone just having sand in his shoe and walking out in the parking lot and dropping one. So that's the equivalence of that particular.
Okay, when does that stop? When does that stop then?
Never
So
stop.
by that, okay, then by that analogy, if that is the case, then Earth's atmosphere extends to every part of the galaxy, to the whole universe.
We already know Zanuck agrees. He said that the whole world's a beach, right? He doesn't. Carlito's the one gaslighting us that he hasn't been taking the opposite position this whole time.
But Carlito's not sure if the top of Mount
No,
Everest
but-
is the crust of the Earth or if the
No.
base of Mount Everest is the crust of the Earth. I had to
I
explain
said
that to him.
technically. I said y'all are trying to kill me on the technicality. Y'all tried to bite my head off because I said the Kármán line and said, well, the moon's in the
No, it's
atmosphere.
because your
I
stupid
said that's
sand
a
analogy is why
technicality,
like
bro.
nobody wants to listen. It's like the geocorona is a high density near Earth. It gradually decreases outwards. There's no gaps, just thinning. Your sand example, it's dense at the beach. There's stuff in between. Boardwalk, other thing, road, grass. Then suddenly you find some sand again at your house, and you were trying to make it analogous by saying, "Oh, they just found some of this out there." So that doesn't mean it's the atmosphere, but it's gradually decreasing outward. Now, here's the big issue. It's a categorical issue. So atmosphere can be defined physically as gas bound to the earth following measurable laws. Beach is a category based on environment and processes like waves, sediment transport. It's not just defined by presence of sand. So that's the haymaker. Your analogy sucks. Please don't use it again. It wastes a lot of people's time.
No, my analogy was sick, bro. And I was talking about the wind. I don't know
No,
why
you're
you
done.
keep bringing this other shit up. I was talking about the wind. Wind blows sand or beach. You can find any beach in America. I guarantee you.
Hey, Carl, is it
if I want to
possible
read,
for you to be wrong? Carl, is it
yeah.
possible? Yeah. Okay,
Look at
then why aren't you accepting that possibility right now?
Bro, is it possible for you not to cut me the fuck off? Is that possible? And can you accept that possibility?
Yeah, so extending the
Yep,
atmosphere
I
outwards
just did it.
follows its physical definition. Extending the beach outwards violates its definition.
Listen, I wasn't saying it was a one-to-one analogy. We were talking. You know what? Fuck it. I can see. You know what? Fuck it.
Nice. We can get rid of this
Nice.
analogy.
Good
Great.
job.
That was a horrible analogy.
It was a sick analogy, but I don't
You're
want to argue about
stubborn
it.
and you're conceited. You're not conceding.
Bro, it was a sick analogy. Probably one of the sickest analogies brought up in this Discord ever. Okay, and just because you don't understand it, ain't my fault.
LeBron debates,
What's the
man.
standard? What's the standard for sickness here?
It was super sick, bro. Super sick. That's why I said the question was bad faith because you asked me where the
You
atmosphere
mean like
is.
sick in the sense like it's like dying, going away, not very good, not doing well, right?
No, I mean sick.
Yeah,
Heavy
like
sick.
when someone is at the hospital and they're super sick, like they're dying, they're going, that would be like
No, I'm
what
not
your
about to argue.
analogy.
No, we're not about to argue about sick and its meaning and claim. We're not about to do it.
We're not arguing. We're just
I
being
mean,
funny.
it's just weird because if you agreed with NASA from the beginning, this whole conversation wouldn't have happened.
No, because no. I said NASA says that based off of technicality, bro. That's what I said. You guys don't follow my arguments, bro.
So is it
No, your
true or
analogy
not?
undermines NASA's claim. That's the problem. I just want you to be
No, I
consistent.
didn't. I said if you want to say that because a particle of the Earth's atmosphere is out there by the moon, if you want to say that's the moon there,
Wait,
the atmosphere stretches out that far, you
Yeah, no
can.
one said that.
I
phrasing
said
it
me
that way
personally.
is bad faith though. Like if you agree with NASA, you don't have to make these comments as if you want to say it that way or NASA can say it that way. It's like, do you say it that way?
No, that's why I was getting to next. For
Yeah, no
me,
one said it that
Okay.
way. I said it was a continuous gradation.
Kármán line. I use the Kármán line. Now, just because NASA and Zanuck and other lot of science people like to say, oh, well, we found zero point 0.2 hydrogen atom here, so here's the Earth's atmosphere. Okay, fine. You can
Well,
say that.
That's not what they're saying.
Well,
we're not.
you're the cause of flat earthers then, because what flat earthers are looking for is the real globe. They're looking for the real one. You know what I mean? But if everyone has a different idea of it, then it's like, what is it? Is it even like we need the real one, dude? Could you get the real one for us?
There's no different idea.
Nobody's
What are you
asking
talking about?
who. Nobody's asking who can say what. We're asking you if it's true.
It's true that particles of the atmosphere extend out to the moon. Now, if you want to call that the Earth's atmosphere and say the moon's in the Earth's atmosphere for that, then fine, go ahead. That's on you.
Is a continuous gradient of gases getting less dense considered atmosphere by definition?
Yes.
Okay, so you consider Earth's atmosphere. You're done.
Whatever, dude. Like I said, it's a bad faith argument in my opinion.
It's not bad faith.
Hold
Actually,
on, can you
you're
define
the
that?
bad faith element because you're the one forcing a non-conclusion. I just asked you if a continuous gradation of gases getting less dense is considered atmosphere. The geocorona is a continuous gradation of gas getting less dense. So I asked if those are the same thing. You agreed. So you agree that the geocorona is part of the atmosphere. You're done. And then if you say you're bad faith, you're forcing a non-conclusion, which, like, ironically makes you bad faith.
Not really, because you're talking about technicality, which was my point in the first place.
No, not technicality, just literal definitions of words that you agree to. You're just being obstinate and disagreeing for the sake of disagreeing, not because you actually believe what you're saying. Because what you're specifically saying agrees with what I'm saying. But you're saying no, but like you agreed to it.
No, I'm saying that.
See?
By the moon, you have 0.2 atoms per cubic centimeter hydrogen. All right. Now, if you want to say that just because that presence alone is enough to say that the moon is in the Earth's atmosphere, you can. By definition, you
Yeah,
can.
but so your conclusion is, because you already told us it's true. Your conclusion is they say that because it's true. It's just such a weird, like, what was the point of the whole conversation then?
No, because
Let me
they
try
don't.
to ask
Okay, you know
Anchovy.
what?
When I asked Anchovy, when I asked Carlito, is a continuous lower density of gases in a gradient form, is that considered atmosphere? Did he say yes?
I don't think he's said anything this whole time.
He said yes to that. Anyway.
Here's the. By the way, here's
And I asked
something
if
that's.
the geocorona is a continuous lower density gradation of gases, and he said yes. So therefore, the geocorona is atmosphere. Simple.
Depends on the context, right? If you look at the definition, like if you ask AI, right, it would say there isn't a single sharp agreed upon edge to Earth's atmosphere. It gradually thins out into space. But scientists use a few standard reference points depending on context, right? One of which is the Kármán line used, above this, air is too thin for traditional aircraft to be able to have flight, right? Then they have, the menopause, the thermosphere, exosphere, etc. And then you can go to the geocorona, which is essentially the outermost whisper of Earth's atmosphere, far beyond the exosphere.
Let's go.
If you're using those words like that, though, how do we know what you mean? Like you're saying there. So are you saying the atmosphere is not an actual thing that you don't even know, or it's just a concept? Because the way you're using it is in the universal concept idea of it, rather than talking about it like it is a particular, because it is a particular according to you. It's a specific amount of gases. So for you to say there is no line you can draw where that is, that means it's not physical.
It depends on the context, though, right? Like if we talk about breathable atmosphere, then we're talking about altitudes at which humans can survive.
All right, Jake, can I ask you two quick questions and like just try to answer yes or no? Like so the atmosphere, right? Do we define that as a continuous gradient of gases getting lower in density?
I don't think that the gradient is part of the definition of an atmosphere. I don't think that's a required definition
it's not
in
a
atmosphere.
gradient. How would you
That's
define
not
it?
that wouldn't be a full definition because we have gradients in places that aren't the atmosphere.
So Earth's atmosphere, do you guys define it as a continuous gradient of gases becoming lower in density as you go further away?
Yeah, I'm fine with the definition. I don't know about Jake.
Jake, are you fine with that definition?
I mean, at the most basic sense, atmosphere is just the layer of gases surrounding a planet, right? Now, because of gravity, obviously,
I want to
hold on
ask
a
two
second.
questions.
Because
I guess we're gonna get into the weeds.
Because of gravity, it's going to be there's going to be a gradient there, right? But in its simplest form, it just means the layer of gases surrounding a planet. Gradient is not part of that definition.
Do you agree
You
that
guys are
Earth's
making this hard.
atmosphere is a continuous gradient of gases becoming less dense the further you go away from Earth? Yes or no?
So theoretically, if you had the technology,
Dude, it's a yes or
if
no,
you had the if you
please.
had the, if you had the technology to create separations in layers of gas, and it isn't a continuous gradient, you just had gas, perfect vacuum, gas, perfect vacuum, like shells of that. All those
You just
shells
say
would
yes.
still be considered. All those cells would still be considered part of that planet's
Did he
atmosphere.
ask you for
Even though,
Earth's
even though there's
atmosphere?
no continuous gradient, that would still be considered an atmosphere. So
So, like, the
this,
definition of bad faith is to try to not allow a conclusion in a conversation. So I asked you if Earth's atmosphere is a continuous gradient where gases get less dense the further you go away.
I'm
Pinky
going to change my
answered
definition.
yes.
I'm going to
no,
change my definition to no.
no, because there are sections in Earth's atmosphere where you have lower density and higher density in its shells. Because once you start getting into interactions with the solar wind, you get this layering effect where you can have lower density below higher density, right?
Yep. I agree with Jake.
So then
I can
any
give you my
density
definition.
gradient. So then as long as there's a density gradient, you guys are good. Doesn't matter if it's going up or down, whatever, it doesn't matter. That's called Earth's atmosphere, right?
Our definition doesn't have a requirement of a specific gradient. It's just
All right, I'll
a
try
layer
to.
of
I'll
gases,
try
a
to.
layer of gas.
I'll
I'll
try
tell
to
you my
tell you the
definition.
definition.
It's a layer of gases that surrounds the Earth, held
So
in
do you
place
agree
by
that it's
gravity.
like an envelope, right? A gravitationally bound envelope of gases surrounding the planet,
Yep.
characterized by a continuous decrease in density with altitude?
No.
I wasn't done.
Oh, sorry. I
You don't
already
think
would
that
say no to that
wait, you
part.
don't think that
Sorry,
the
go ahead. My
atmosphere is
bad.
characterized by a continuous decrease in density of gases?
My
No,
definition
because
is
for
a
example,
layer of gases that surrounds the Earth.
on the surface of the Earth, you could have very hot air very close to the surface, a few feet off the ground, where the density is lower than the gases a few feet above it, right? So you
You
don't
know
have
what?
you don't have a continuous gradient of decreasing density. And when we get higher up and we start interacting with the solar wind, you can get these areas of much lower density uh, that are below higher density.
Just change it to any gradient. These guys are. This is bad faith at this point because you're trying to make the definition so vague that nobody can pinpoint your position.
We gave you the
So
definition. The definition
basically,
is a
That's
layer of
just
gases
bad
surrounding the
faith.
Earth.
That's
We
bad
already
faith.
gave you the
So if you
definition.
Google it, if anyone were to Google it, yes, Earth's atmosphere decrease in density and pressure continuously as you gain altitude. Air pressure drops exponentially with height because gravity pulls most gas molecules down towards the surface, making air thinner higher up. While density and pressure decrease steadily, temperature fluctuations are not continuous. They rise and fall depending on the atmospheric layer. So that is how atmosphere is defined. You could try to change the definition and say words have no meaning. So anyway, we're gonna go
No,
with
I asked
definition because that's the definition.
ChatGPT. Well, I asked ChatGPT and it gave a different answer.
What did you ask ChatGPT?
What is the atmosphere? It said the atmosphere is a layer of gases that surrounds the Earth held in place by gravity.
Can you ask ChatGPT, does the atmosphere decrease continuously in density, the gases, as you go higher in altitude?
That's not a definition of what the atmosphere is. So if you want to have a different conversation about that, we
It's a
can.
question, not a definition.
it's actually
I
an
can ask it. I can
ontological.
ask it if you want, but that's
Are you
not. That's
saying
not
the
the.
being
Yeah,
of the
ask if
atmosphere
Earth.
in reality doesn't exist that way?
So the question isn't about in atmosphere or the atmosphere. The question is, do you agree that Earth's atmosphere decreases in gas density as you gain altitude? That's the question. So when you get a definition that has nothing to do with like Earth's okay, so my social atmosphere is just the people I hang out with, so technically you're wrong. It's like a really ridiculous way to not address the argument, and it is bad faith. So if you
No, I
ask
think what you're doing is bad
ChatGPT,
faith.
does Earth's atmosphere decrease the gases? Do they decrease in density as you gain altitude? If it tells you yes, then I can continue my line of questions, but you guys won't say yes. You initially said yes, then you circled back because Jake said no, because you guys don't want to give a concrete definition, because you guys don't want to have a conclusion of the conversation. You're here to
I'm
force
sorry
a
we're not stepping into your little trap, but
Right,
like
yeah,
this
they
is what
have different
ChatGPT says the
definitions of
definition
atmosphere.
is. We can look up in Google and see if Google gives us a different definition,
Yeah.
but you're changing the question now because we didn't
Let's
get
look
the
up
answer
the
we
Webster.
wanted.
Let's look up the Webster definition.
Does Earth's atmosphere, as you increase altitude, does the gas decrease in density? That's the question.
Yeah, I asked the question. By the way, I asked that exact question, and the answer was, in general, yes. In general, Earth's atmosphere in density does
Show a
decrease
screenshot of the question you asked, please.
but in a perfect uniform way at every time. Hold on.
Yeah, could you show the exact question you asked? And also, it better start with what you just started with in the answer, so that way you don't ask it a different loaded question, because I know you asked it a loaded question. Like,
I can't
show
fit it
how
all
the
in
Earth's
one
atmosphere is
screenshot
in a
here.
perfect continuous gradient. I guarantee you asked a loaded
Here's the
question.
question that I read it exactly. Okay, does Earth's
Nope, please
atmosphere
show a
decrease
screenshot. I don't trust you. One time, I was debating you, and I asked if you were using ChatGPT because 30 minutes were wasted looking for the source of your quote. And we said, "Did you just use ChatGPT? Because it kind of gets quotes wrong one time." Like, and you wouldn't admit to it. We couldn't find the source, and you said no over and over again, and we found out you were using ChatGPT. So I'd like to see an exact screenshot of the question you exactly asked.
I think I remember that. Good
Yeah,
way to
wasting
pull that
30
back in and
minutes.
just
It
keep
turns
beating him over
out-
the head with it every chance you get. That was good.
If we back
Well,
up for a
listen.
little bit, it's just, the whole problem is that different people have different definitions of atmosphere. I don't know why we're arguing so much about it.
Yeah,
That's why he wants to
over-
drag us into a definition that he can say that's incoherent.
Well,
Yeah,
debates are typically over
Like,
semantics.
No,
I can
I'm
hear you
asking
guys.
a very specific question. I'm asking, does Earth's atmosphere, as you gain in altitude, decrease in density of gas? What definition am I asking for there?
Well,
the answer to
your
your
tactic
question
midway,
is it
so
depends
now
on
we're
what
doing something
definition
different.
you're using.
I posted the exact screenshot since you didn't believe me.
Well, they said it's a dynamic system. It could be higher in density at a higher point, but so besides the technicals, the conversation's very simple. Do you agree with NASA that the geocorona goes past the moon? I mean, we don't have to get into the technicals. It's just, do you agree or not?
Yes, the geocorona does go past the moon. The question is, do you want to call that atmosphere or not? Some people yes, some people no.
Oh, so
Well,
Jake, you
is the
did ask it a
geocorona
loaded
part of the
question,
atmosphere?
and this isn't the question you initially asked when you said you asked it. And this isn't the answer you initially got when you said you got it. You asked it a different question, and it actually agrees with me. Yes, Earth's atmosphere doesn't just end at a fixed height. Its density decreases smoothly in a gradient as you go up higher. So when you asked it an honest question,
it says,
it
but not in a
agreed.
perfectly
It says
smooth,
yes.
uniform way.
When you asked it the first dishonest question, it gave you a different answer. You said yes, but not perfectly uniform, etc., etc. So if you want to share the first dishonest question you asked it, you can do that. But this isn't the first thing you asked it because this says yes.
I literally started reading. I said, in general, but not in a continuously, perfectly smooth, uniform way, which is what it said, which is the opposite of what you just said.
Where does it say in general? Is it the first
It's
picture?
not uniform anyway. I mean, I guess if you consider exponentially uniform.
Yes, in general. Can you not read? Yes, in general.
No, Beast just asked it. Yes, Earth's atmosphere doesn't just end at a fixed height. Its density decreases smoothly in a gradient as you higher. Yeah, you didn't post your prompt. Beast asked a very simple question.
I did post my prompt. My prompt is in gray. It's in the gray box.
Where is it?
I don't see it. Maybe it went into the chat.
Oh, you know what? I posted it in an audience text. Hold on.
By the way, some people are saying in chat that this is just like a semantical debate. It doesn't sound like that to me, because if you have I mean, there are semantics in any type of discussion, and when there's a claim by these kind of mainstream perpetrators that there's this globe idea, and they're putting words to it like the atmosphere is a thing that ends at a certain place, and then you have this outer space, and they say astronauts are going to outer space, kind of a thing. That's a definition. They're calling that outer space versus the globe atmosphere. So there are words that are used in these models of what the Earth is. And it is pretty significant when you have the difference between a globe in a vacuum, because if you took a ball and put it in a vacuum, we all know that there's no way you could make like a livable atmosphere right on the outside of that ball in a huge vacuum chamber on Earth. So there's something else claimed to be going on, that this globe thing has this atmosphere that we live in and we breathe air, and it's very, very different than this outer space medium that they claim you have to put spacesuits on and you'll die. You can't be out there without a suit on, and so on. And so there are pretty significant differences of what's being discussed, and then how far that extends out between what the words that are used for this the globe's atmosphere that we're living in and on, that we treat as stationary. There's no detection of motion, etc. But somehow when you go up there, all of a sudden you're in this other medium, and so on. So where that defining line is would be a pretty important distinction for that, if someone's going to put that forward. And also, if the whole atmosphere is supposed to be rotating with the globe, then is it also rotating is the gradient rotating hundreds or thousands of miles out there? Is that gradient also rotating and brushing by the moon as it's rotating as well? So you have that factor too.
Well, they're just arguing to argue at this point. They agree. They said they agree with NASA that the geocorona goes past the moon, but then he also said, if you want to call that the atmosphere, but that is the geocorona is the atmosphere. So it's like, how are you saying both at the same time?
Well, here's a good frame of reference. Hold on. Here's a good. Hold on, my turn.
If the answer to the question is
it's my turn.
So if you ask, does Earth's atmosphere decrease continuously in density as you go higher, and the answer is yes, then is the geocorona a continuous decrease in density as you go farther away? Then the answer is the geocorona is Earth's atmosphere.
Okay, this is the point I want to make. Let's say you buy a vacuum chamber off of Amazon, okay? The best one you can get on Amazon. Okay, if you were to go to where the ISS is, which is way closer than the moon, okay? You're going to have the air density there is going to be, it's like 100,000 times less air density than the best vacuum chamber you can buy on Amazon. By the time you get to the moon, it's so thin that asking like all this stuff that you guys are asking is pointless. There's virtually the molecules are so few up there that it's like that's why it's sort of like a gotcha question about trying to define the atmosphere, but
that's why it said that depends on the context. That's what the ChatGPT prompted said. It depends on the context that you
geocorona
use
is
it.
the luminous part of the outermost region of the Earth's atmosphere, called the exosphere. It is seen primarily via ultraviolet light. It's part of the exosphere.
Yeah, what's the density there? The air density.
Non sequitur.
No, it's not. It's just a question. We're just having a normal conversation. I'll look it up. What's the density?
Question is it part of the Earth's atmosphere or not, according to the globe model?
Okay, let's look it up. What's the density?
I got it here. I looked it up. Yes, the geocorona is considered the outermost part of the Earth's atmosphere, specifically within the exosphere, is a faint luminous cloud of hydrogen atoms that extends roughly 630,000 kilometers into space, which is about 50 times Earth's diameter, stretching past the moon's orbit. While nearly a vacuum, it constitutes the atmosphere's final boundary before space. That's because they know it's a particular and they have to make that claim. So the real globe says so.
I mean, like we can find a different source that will define atmosphere at a different density point and do a cutoff there.
Oh, you guys
The thing is, the globe doesn't have a problem with this. It's not, because everybody understands that making a line it's just an arbitrary line anyway.
So
yeah, not
Pinky,
Wikipedia,
are we
not
in Venus?
NASA, so you can't use those sources for arguments then.
Are we in Venus's atmosphere right now, Pinky?
I mean, no, we're not.
No? So where does that one end?
I don't know.
Okay.
I don't know. There's not like there's not an exact line where it ends.
Where does the Earth one end? Well, if we're not in Venus's, then it had to have ended somewhere. So
Yeah.
you don't
So
know?
somewhere between here and Venus, it ended.
Does anyone know? Does NASA know?
That's
No,
a
because it's not
positive claim. So where is there? They're asking where. You said somewhere in between. Okay, that denotes that there is a place where it's happening.
Yeah, like where does the thermosphere end?
The
Dude,
geocorona
we can
extends
Google
way past
these.
the moon.
Could it be where the gravity's so weak it no longer holds air molecules?
No, it's not defined as that.
That would play a factor
Virtually
as
is
well.
not defined as that. There's a bunch of sources in the chat. You can read about it.
Are we in
See,
the
my
sun?
understanding is that converting the density in the geocorona to core is like 10 to the negative 17. I was under the impression that we don't even have devices that can measure air density, and that those numbers are basically projections based on mathematical models of how like particles behave.
As a flat earther.
Okay,
You
that would be
know,
a flat Earth
well,
claim.
no, I mean,
So
like you
this
can
is
say
from the
that, but we
European Space
have
Agency.
measured density in the atmosphere up to 10 to the negative like 10th at least. I mean, I don't think you guys comprehend how absolute not pressure that is. And that's
I'm gonna
below we
post
hit
a
any sort
quick
of
thing.
dome, right? There's zero
Yeah, you guys
pressure
don't
and
understand.
we
It's
haven't even
not an
got to the
argument.
dome yet.
So this is from the European Space Agency. Earth's geocorona from the moon. The Earth and its hydrogen envelope, or geocorona, as seen from the moon. This ultraviolet picture was taken in 1972 with a camera operated by Apollo 16 astronauts on the moon. A recent discovery based on the observations from the ESA/NASA Solar and Heliospheric Observatory (SOHO) shows that the geocorona extends well beyond the orbit of the moon, reaching up to 630,000 kilometers above Earth's surface, or 50 times the diameter of our planet.
I mean, at this point, it just sounds like you're arguing to argue. I'm going to be honest. Like, you either think it's the atmosphere or you don't.
And like I can pick one. Let's say no, it's not the atmosphere.
Okay, the European
that's
Space
fine.
Agency and NASA disagree with you. Here's a
You're
specific
a flat
article
earther.
from the that's a flat Earth claim. So the European Space Agency says Earth's atmosphere stretches out to the moon and beyond. Here's the article. You can read all about it. It cites NASA. If you disagree with that, that's fine. But that is the case of the current state of the heliocentric model.
I just define atmosphere differently.
I just define you making claims as differently. So right now you're not making claims. Like this doesn't say anything.
Okay. I mean, I can choose whatever boundary for the atmosphere I want, right?
I mean, boundary doesn't even mean boundary. I can just define boundaries whatever I want. So, like, if we just change definitions arbitrarily, then we're not getting anywhere. No one
Well,
means
where is
anything
the
when they
definition
say
for
anything.
atmosphere that says that it extends beyond the moon?
I don't know people that study space that you would appeal to.
I mean, would you accept that?
It's an internal critique. Why would you ask what I would accept or not?
Because I don't know. Would you accept it?
What I
This is
accept is
really bad
irrelevant.
faith.
If I'm saying internally in this model, whether or not I believe it's true or not, this is what it says, and you say, it doesn't say that because I define it differently. Would you accept my new definition? No, it
No,
doesn't matter what I believe. It's an internal critique.
I mean, it's like what constitutes space. Different countries define it differently. I know we went over that before, but that doesn't mean anything. It's just different countries define the boundary of space differently.
Okay, which
Doesn't
countries
mean that there's not a
contest the
boundary.
fact that the exosphere is part of Earth's atmosphere? Go.
Sorry, what was that?
Which countries contest the fact that the exosphere is part of Earth's atmosphere? Go ahead.
But I don't know. I don't look to countries. I was using that as an example of two.
You said different countries
groups.
say differently. So
Don't
which
interrupt.
one?
I said two. Well, I was using it as an example of countries that differ on the what the boundary is between for space, essentially.
So why would you say different countries say differently if you don't even know if different countries say differently?
No, they do for the boundary for space, but not necessarily for the atmosphere. I don't know. Maybe they do, but
Okay, this is about whether or not the exosphere is considered Earth's atmosphere, and why we're talking about that. Kind of just like throwing mud on something and then saying, "Why is it all muddy? What makes an orange? What like? Why is an orange an orange?"
Well, it's this universal talk, you know. They're claiming it like the atmosphere is like this thing that it's more conceptual. It's not really, you know, scientific or anything like that. That we could go and measure it or anything like that. But then, you know, they want it both ways. That it's made up of all these physical things, and we know exactly what it is, and all like that's called kettle logic, Pafinky. You need to look that up, dude. Kettle logic.
I'll
I just want to
definitely look that
also
up.
point out that Jake asked his ChatGPT, does Earth's atmosphere decrease in density continuously to where for every millimeter change in increased altitude, the atmosphere becomes less dense? Whereas when Beast asked ChatGPT, does the Earth's atmosphere decrease in density like a gradient as you move higher in altitude? It said yes. When I asked Google the same question, does Earth's atmosphere decrease decrease? I'm going to say decrease continuously as you increase in altitude. It says yes, Earth's atmosphere density and pressure decrease continuously as you gain altitude. So if you ask ChatGPT a loaded question, it's going to give like a loaded question with like nuance added. Does Earth's atmosphere perfectly decrease in density as you go up higher? Yeah, of course it's not going to give you any type of like concrete answer. So like the
Yeah,
goal
I got
is
three. You asked for
and
examples.
add
You asked for
needless
examples, and I have a few here. So collisional
needless
atmosphere.
vague nuance doesn't help the conversation because we're looking for clarity.
Yeah, but those
Okay.
answers are just in general. They're not in specific. They're not getting into the nitty gritty of it, right? They're in specific. They're just in general, not specific. That's why
Okay,
if you
the
want a specific
exosphere
answer,
part
you
of
have to
Earth's
ask a
atmosphere
specific
or not?
question.
Yeah, I agree. Okay, so I found some examples. Collisional atmosphere. The definition is the atmosphere is the region where gas behaves as a collisional fluid, whereas molecules frequently collide, and the boundaries of the exobase. So according to this definition of atmosphere, you would not include the exosphere as part of the atmosphere. Second one is continuum fluid regime, which is an engineering definition, which is used in aerodynamics, CFD flight physics, which says the atmosphere is a region where air can be treated as a continuous fluid using the Navier-Stokes application. And the third is a sensible atmosphere, which is used in weather, aviation, and human relevance. So these are three definitions of atmosphere where they would not include, they're not including the exosphere in it.
Earth's atmosphere, right? Definition of Earth's atmosphere.
Correct. Yeah. So if you ask like a meteorologist that's working, that's gonna they send up stuff on balloons, they don't consider that up there the atmosphere. It's not part of their realm. I would even question whether the exosphere, the density up there, has actually been measured. I think it's something they saw. They saw like the photo that you were talking about, and then they hypothesized about what the presence of what particles would cause that behavior.
It's probably
Okay,
like
so
mathematically inferred,
in
right?
the
There's no direct
collisional,
way to. There's no direct mechanism to measure it.
thanks, Jake. So the collisional atmosphere definition, where does the atmosphere end if it's not past or beyond the exosphere? Because the way that you framed it was that it ends before the exosphere.
Yeah, it says the boundaries of the exobase.
Where's the exobase?
Before the exosphere.
So right before the exosphere?
I don't know, to be honest. I chat GPT'd it, obviously.
So we don't even know?
Where does the exobase end? Because I feel like it's just the whole concept of the question is, I feel like it's intended just to be a trap. Like if you ask, if you're talking to somebody and they're like, yeah, I do meteorology, we measure all the way up in the atmosphere, density, we measure temperature, and then you guys come along and you're like, well, technically you don't, because you guys don't send balloons up past the moon, right? It's like, it's kind of like a dumb argument for a gotcha.
No, the argument was
that's
about
just
whether
your
or not the
opinion.
Silly Sand analogy worked. And then some people agreed, some people didn't.
I think I missed the analogy, so.
And it was like if you find sand in a parking lot near a beach, did the beach continue to the parking lot as if it wasn't a continuous gradient, like the atmosphere wasn't a continuous gradient? But the fluid, like collisional atmosphere, they have a specific criterion which is arbitrary, but it's for their purposes. It's the atmosphere ends where gas particles no longer collide frequently enough to behave as a fluid. So that's just in a very specific, like that's taking it to a very nuanced, specific thing. We're talking about gases slowly decrease. Like you can no longer consider it a fluid at this point. That's 500 kilometers above sea level, which will to 1,000, which will vary with solar activity. Whereas I think a lot of people agree that Earth's atmosphere extends out further than 1,000 kilometers.
Yeah, they're saying like
the
you're not getting
aerodynamic, which is the
collisions,
carbon
which
line.
means like if you have an air pressure in which there's not even enough air molecules to create collisions, do you need a container for that? Like it's not even going to be pushing
Yeah, you
against the
need a
container.
container. Yeah, for any kind of molecules to exist, you need containment.
Why?
Why? There's no. This is what
You need
this is
because you
saying.
have
Oh, God.
because you need a universe in order to have things.
So
So
the
there's your
universe is the
container.
container.
Yeah, there you go. So yeah, exactly. So there's no such
You're
thing
talking
as
past each other now.
molecules without
Your
containment.
defense.
I'm talking about gas pressure, obviously.
Yeah.
Like
Let him finish speaking. I mean, Zach, you said the beach
I'm just
extends
talking about.
forever, so.
No, I mean your defense of so now you admit that there could be we also could agree that we could be in one big solid universe with boundaries, but that's not the reason we have gas pressure.
But you said the beach extends forever, so it would stand to say that the Earth's atmosphere extends forever by that criterion.
If you define it as just particles that came from the Earth, but the atmosphere is actually something that shows that it's surrounding the Earth and stays around the Earth. So you have to find out what point these atoms are leaving the Earth, and they wouldn't be considered the atmosphere. Just like
It's
the
the gas.
beach doesn't go past the parking lot.
Gas molecules are the necessary precondition for gas pressure, right? You have to have gas molecules, and you're going to need a universe in order to have gas molecules.
Great. So we have everything that you talk about existing needs to be the prerequisite is having a universe. Okay, we all agree. Everything, no matter what light, gas pressure, bunny rabbit,
your container.
everything needs a universe.
But now you're avoiding the question, Toro, because the question is if gas molecules don't collide enough
getting more and more pedantic with
to be
every type of
considered a
requirement you're
fluid.
making.
Oh, sorry, Zanuck was talking. My bad.
I mean, you got to make your point clear. What are you really trying to ask? And if you're saying we just don't think it can exist because we don't believe this atmosphere has any reason to surround the Earth and have a gradient, which it does, in the gas law and the law of atmospheres describes it almost perfectly. The air has weight. That's it. End of story. Done. Next topic.
Yeah, next topic. And I just want to add to Pinky. The reason why I wouldn't really go with the nuanced definitions of atmosphere is because I could just say my social atmosphere extends I don't know 100 miles from where I live. So therefore, if I define atmosphere as my social atmosphere and all the people that I know, you know what I mean?
It's not the same
very
thing though.
arbitrary.
We're talking about physical characteristics. Your social atmosphere isn't a physical characteristic.
Yeah, it's more of a mental problem.
No, because
these are all dealing with the gases.
The other atmospheres he brought.
Well, let me respond to it. I think it's a fair point, but the way I'd respond to it is by saying that the general definition of atmosphere is the layer of gases that surround Earth held in place by gravity. Every definition I gave you is within that context.
Right. And also, what if you start eliminating things like hydrogen or individual atoms? Let's say molecules. So if we say, where do the molecules end in our atmosphere? That would probably be a more valid question, and then we might have a more narrowed answer, but it's still not going to be defined at exactly 123.657 miles. You'll find the last, oxygen molecule or nitrogen molecule.
I wasn't even making a definitional argument. I was just asking the question if Earth's atmospheric density and pressure decrease continuously as you gain altitude. And the answer should be yes, because any reasonable person would say yes. And then does the exosphere behave like this just like the rest of the atmosphere? The answer is yes. So therefore, the exosphere is part of Earth's atmosphere.
I would contend that the exosphere acts like this because I don't think we've actually measured any pressure there.
Nice.
I think it's all a mathematical model. I would say go up as high as we've have actual devices that measure it, and that's probably as far as I'd be willing to make a claim about it.
Based, reasonable take. Thank you.
And Galley, your social sphere extends all the way to Utah, buddy. I just want to put it out
Extends all the
there.
way to Romania, man, and New
Yeah,
Zealand.
I just want from Romania to Utah. I want to put it out to Vegas, the likes.
We
I
got a
took your
Utard
image.
here with us.
I put your image into a reverse image generator, the one of the Earth's corona, and also looked it up with some star charts. Turns out that there is no constellation to match that image, and so therefore your image that you provided is therefore fake and gay. So just throwing it out there.
Did you? Well, I hope we all agree that this gas pressure that we can measure, or that is even defined by what gas pressure is, would you all agree that in order to have gas pressure, either a gas molecule has to bounce off of some container or a sensor, or bounce off another molecule or atom? Would you agree? Would everyone here agree that that's the only way gas pressure can happen is if there's a collision?
Not a collision.
Is there anyone that doesn't agree with that collision theory or idea? Can you have
not
gas
a collision,
pressure
but a container?
No, I've already talked about the Gaussian collisions being no different from the side of a container from those atoms or molecules hitting each other. There's no difference at all physics-wise. Rate of change of momentum is defined as a force, and that's what happens. This force is over an area. That area of force is a pressure. Now let's go back to the basic question I asked and see if everyone agrees. Because if we don't, then we have a serious problem. Does everyone agree that pressure, gas pressure, is, by definition, a collision between two or more molecules or atoms off either the surface of a container or off of each other?
I'll agree to that.
Anyone? Okay, good.
No,
Anyone
he's
not agree?
he's trying to back you up into well, if you agree with this, then this is happening there.
I'm not.
Yeah,
No
Gally
gaslighting.
did it a minute ago. Let Zanuck do it now.
I don't know if that's elegant, because a container would be, I mean, if you're using the molecules of the container, then maybe, but like just two random gas molecules crashing into each other, sure, it might change the trajectory of those said molecules, but that doesn't necessitate that there's pressure might change.
Okay. Can we stop there for a second? So yes, we always know that this interaction, this collision, will result in a change of direction by definition. That change of direction would have to be, if these things have mass, be a rate of change of momentum, which is defined as a force. That only happens when there's a collision. It only happens when there's a change of direction. No other way that can possibly happen. It can happen off of each other, or it can happen off of a container. But the containment of the atmosphere, as I've said for many years now so far, does not require a physical membranic container. All it needs is weight. Weight, by virtue of weight, the airs and the gases, by virtue of their weight, contain.
Zanuck,
Can you replicate it?
I know, but that just to make sure that everyone's clear on it, by virtue of their weight, that contains the molecules in an atmosphere.
In order to say this, though, you'd have to know where the atmosphere stops to know that.
I don't think that's a requirement at all.
You don't have to know where it stops to say that you have this thing that's containing it, but you don't know where it ends.
What did I say? See if you're paying attention, because you're talking kind of over me. What did I say contains the atmosphere?
The force of gravity, but regardless of what it is, though, regardless of what it is, in order to know that it's being contained, you need to know where that containment is happening at. Where is it happening?
I disagree. I don't think you need to know that at all.
You don't even know where it's at. You're just saying there's this thing happening. I don't know where it's at, but trust me, guys, it's happening. I have no idea
that's not what
where
I'm
it
saying.
is.
That's not what I'm saying at all. I'm saying that
where is it?
We have an atmosphere. How do you know? Well, we can measure this pressure gradient, and we can breathe here. We can't breathe there, and it goes up forever. But I know we have it. Where does it end? I don't know. Does that? If you don't know where it ends, then everything you said is invalid. That's not true. That's patently
you're
false.
You're saying that it has this containment, but you don't know where the containment is.
But that's not part of the answer. Not a requirement of the answer.
But how can you say there's this thing you don't even know where it is, though?
That's like saying, can you answer this question? 4 + 4 and you say it's 8, and I say, well, where are you
No, no, it's
located right
like
now? I'm in some forest. You don't know exactly where you're at. No, then that answer is incorrect.
No, that's
no, it's like
different.
saying
No, it's not different. It makes no sense. It's a non
It's like
sequitur.
saying unicorns exist, and then you say, "All right, where's the unicorn?" And I'm like, I don't know. It's out. They're out there somewhere.
That's not at all what I'm saying. I mean, don't. That's a
That's
little
more
further back.
analogous because he's going with something you're saying is
No,
physical,
because
but you
have I
can't
shown
find like
evidence?
where it starts, where it ends, all that.
No. I would show you the unicorn. I'd bring you his horn. I'd cut his horn off and say, "Here, see, here's the horn." I cut it off his head. I don't know where is he now. I don't know. He took off after I cut it. He was pissed off at me.
You
But
gotta
here's his
stop killing
unicorn.
rhinoceroses.
How do you know it's not a rhinoceros horn? Bill, I can do a genetic evaluation of this particular horn and say it came from a unicorn. See, I've given you evidence now. You're saying, "Oh, but we don't know where the unicorn is. We don't know where it is. You don't have it. You don't. They exist, but you don't have it." I had it, and I let it go.
You have
I have the
DNA.
unicorn's horn.
You have DNA that's actually from unicorns.
I have the horn from the unicorn.
What?
I cut it off. I told you. I'm paying attention.
Yeah, my question is, what are you going to compare it to?
Saying
You have to
that I
have
that I know the unicorns exist, and I don't know where they are. That's not
Yeah, but you
analogous
said
to.
you're gonna
I have gas
compare it.
pressure. I measure it. It's tangible. We measure the gradient with all the forces and elements. Books written, many books written on law of
You're
atmospheres.
trying
Atmosphere.
to.
You're not letting me finish, are you? Because you don't want to listen to me.
Do you think that someone has a unicorn horn somewhere in this world?
If you were saying there are unicorns exist, you would do that by to strengthen your case for you knowing that unicorns exist and espousing to think that they do.
Can you wrap?
Take it in, DNA test it, and compare it?
Yeah, there would be anything that matches.
What are
it.
you going to compare it to?
More evidence. Horns off of a rhino. Horns off of a spotted lizard. Horned lizard. Horny frogs.
So you don't
You know
have
what I'm
another
saying. Look,
unicorn to compare.
Someone brought a silly analogy. Now you're just like double downing on a silly analogy. No, I didn't say.
I am.
Unicorn. I didn't say the equivalent of or the analogy of unicorns exist. I can't show where they are. They're up there somewhere. I said we have air pressure, gas pressure, follows all these laws that we've developed through of gas laws and law of atmospheres, and we don't know where it ends. That does not say, oh, everything we said now is irrelevant and unsubstantiated, because it's not. It means quite the opposite. We don't know where it ends, which means we don't know where it ends. It doesn't mean anything else other than that.
Zanuck, when you say we don't know where it ends,
When I say we don't know where it ends, means we don't know exactly where it ends.
yeah, that's what I'm saying. Everywhere we've been so far, have we been inside Earth's atmosphere?
By how you define Earth's atmosphere will determine whether we have been there or not.
I don't know. How does NASA use it? We should probably go with NASA, right? Because they're the space people, the space experts.
Well, they talk about space starting at the Kármán line. They also talk about the Earth's corona. They also talk about all sorts of things in physics.
Contradictory things.
These atoms or molecules that are
things
still trapped gravitationally to the Earth. I think any of these atoms, I think Jake said it or someone else said it, any of these molecules or atoms that are gravitationally attracted to the Earth, trackable, and see the results of them being attracted to the Earth, having weight, etc., that is our atmosphere. Anything that is not gravitationally attracted to the Earth is probably not our atmosphere.
Okay, there's a thing in logic and it's a fallacy and it's called kettle logic, which is a rhetorical device, which is what you're using, and it's wherein one uses multiple arguments to defend a point, but the arguments are inconsistent with each other.
So is the
It's
question.
like the fallacy of the week.
Yeah, this is the one I wanted to bring to the table this week.
So is the question. So they're kind of in parallel. They're in unison. The more ambiguous you make the question, and the more ambiguous the answer becomes.
Your evidence is that you're bringing forward, like, you remember how you said one says it stops at the Kármán line, then another says it goes past the moon? That's what I'm talking about. That's a rhetorical device that you're like, yeah, exactly. You're saying we have to look at everything analytically. If we look at it in the big picture, none of this scales up and works.
As it shouldn't, because that's the definition of being specific versus being ambiguous. Don't you understand? See, you just painted yourself into a corner. You're not going to be able to get out now.
Oh, being analytical, you can. It's like you're saying that a guy who knows all the parts of how a car, all the intricate parts of how the car works, doesn't actually know how the car works on the grand scale.
In every possible application, no. Like for example, I would be a good example of that. I build race cars, I fix cars, I do everything. I've been doing it my whole life, right? Do I know everything about cars? Is there any limits to my knowledge? Is there
Yeah,
any
but
limits to
that's
my
you're
I
on
even
the other
drive cars.
side.
Is there
You're
limits to
on
my
the other
abilities?
side.
Yes, there's limits on everything.
Yeah, you're on the other side. You're on the macro side. It's like cars exist, dude. This you're saying I have all these particulars that add up to this thing that's containing everything, but then I don't know how to find the thing that I'm talking about, the big picture, the whole car. You know all the little ins and outs of the engine, all that cool stuff, but then all those little parts when we put them together make a whole contradictory story that doesn't work in reality.
Your analogy just fell apart on its face. But if you want to try to reconstitute it or fix it, I'm more than willing and patient to listen to you. But so far, we do know the atmosphere. We do see all the evidence that supports the atmospheric gradient. The law of atmospheres is a prime example of how we can do that.
Okay, where does it end?
I think the law of atmospheres talks about where it ends. In fact, maybe it does. In fact, I have a book here. We can probably I pull it right now. We can see what it says. But I guarantee what it is going to say is they're going to say space generally, as someone mentioned that word generally, stops at Kármán line. Why? I don't know. They thought it's a good spot where basically every change above 60 miles seems to be a very small change. So we're going to say, it's for all practical purposes, airplanes can't fly there, even no matter how
Okay, and
fast
then
they
we're
go.
gonna find another source that says the atmosphere extends as far as the exosphere.
Right. Because now
Okay,
we're talking about
that's my
atmosphere being.
point. Thank you.
No, you weren't listening. I
Now
even
we're
made
back to
that
the
point my
kettle.
last one so it would stick with you and it just slid right off like you have a Teflon brain. I said that they generally think that that's a spot where no plane will fly no matter how fast it's going. There's so few particles at 60 miles high that it just planes won't fly. That's generally what the Kármán line means. There are still particles above it, still part of our atmosphere. Then there's this charged hydrogen atoms and things and the particles that are outside of the Earth, this exosphere type of thing. That's another dimension.
Are
That
they
has
within Earth's gravity?
other qualities. Are they attracted to the Earth gravitationally? I think some of them are. Maybe some of them aren't. I don't know. I don't know enough about it, but I don't think it makes all the other determinations or classifications wrong because, as I said, it's contextual. There's a context for what the space means in general terms. Specifically, you can say, well, is there any particles or anything charged or anything that we can see, luminous particles that get affected by the sun that are around the Earth and stay around the Earth? We'll say, oh yeah, there are. What do you call that? Well, they call that this exosphere or whatever other names they have for it. I mean, this is not that hard to understand. It's not. I'm not trying to argue with you. I just think it's kind of funny that you have to really have a concrete answer where
So what's
everything
the
is
official stance,
contained as
Zanuck?
knowledge and there's
Zanuck.
no error and is hyper specific and we know exactly at 560,000 kilometers there's not one particle past that.
This is all kettle logic.
Hold on.
The whole
Hold on.
thing.
Zanuck. So the official stance is you don't know where the atmosphere ends. That'd be the official
Yeah.
stance.
As far as what is defined as the atmosphere, we have no idea where that really ends specifically, accurately.
Okay. That's a nice, simple answer. Fine. You don't know where it ends.
Thing bouncing to each other, okay? It's a constant measure progress, if you will. Yeah.
Yeah, I'm gonna, I'm not claiming to know anything. I'm the dumbest guy in the room, but the only way I can try to understand it is like, you know how we look at time as like a measurement on a line. We can say 1 minute ago we were talking about the petri dish, right? But like in order for our human brains to like understand time, we have to look at it like that. But like, if you believe in God, or even if you don't believe in God, let's say you believe in Big Bang theory or whatever, if everything we know ceases to exist, time doesn't stop. So that means like time never began. Like all time exists all the time. And somehow they're like manipulating that in order for a circuit to exist
both an on and off position at the same time, and I can't wrap my head around it. But that's the only way I can try to explain it to myself.
I have a big problem with this time thing. Time is a measurable concept, a man-made concept. Okay, it's not a physical thing. Okay.
What does that even mean?
Time is not a particle or a wave. It's not. It's a concept, like a watch. Yeah. It runs linear from our understanding, but yeah, only the reference to this is a watch. Okay.
No, watch is a physical thing.
Yeah, but this represents a concept. Okay.
Concept
But
of
time
what?
itself,
It's just
it's not physical.
it's just like the quantification of the rate of change or something like that. You know, the breaking down of it into increments is arbitrary, but surely time as a concept or as a it's not a thing. I don't quite know how you describe it, but it's it's real. I mean things change, so
Progress of existence.
that concept is real.
The
It's
progress of
our
existence.
interpretation. But go ahead. John, go ahead.
Oh no, I'd kind of finished. Like it's the, I mean, I've heard the argument said, okay, if God created everything, then that means He created it before it existed. Like He had to exist before it existed, the thing which He created. So before is a temporal term. It exists within the framework of time. You can't exist before a thing without time existing. So, ergo, the argument is God cannot be outside of time because he had to exist either before or simultaneous to the creation.
Time is the progress of existence.
Yeah, it's a logical contradiction, and it's a thought experiment. Yeah, what was first, the hen or the egg? Okay.
Yeah. What do you think, Zanuck? What do you think time is?
Well, what it is the progress of existence. We move
Yeah,
through time.
okay. So the measurement of the rate of change, or the
rate of change.
I'm saying it. I'm saying it more clunky than you are.
I don't know if it's just a concept of rate of change. I think the rate of change would be whether it's accelerating or slow. That's relative to something else. But just the progress of existence alone is time. We don't know how fast it, or if it's what that rate is. It doesn't have. It can be variable, but it does have to change.
Yeah.
It's kind of
I agree. It doesn't have to be 60 minutes in an hour.
Right.
That we ascribe that value.
Right. Well, it's kind of like an analogous to velocity versus acceleration versus speed. The speed is whatever that changes over time, and acceleration would be the rate at which that change over time occurs.
But yeah, that's right. Even through the entire accelerations, there is incremental speed existing at every one of those moments, isn't there?
Right, but the change of the change. It's the second derivative of speed with respect to distance, where speed is just the first derivative of speed with respect to distance, and so time is kind of analogous to that. Just the.
But
I guess
like,
it would just be.
Sorry. Regardless of like state of matter or change or speed, time never ceases to exist. You know, like time will always be there. So how was there like ever a beginning, or was there ever a beginning? Is time infinite in both directions?
Kind of has to be, doesn't it? I think. I mean, but then the argument arises: well, if time is infinite in the past, how can we ever arrive to here? Which then gets into, well, every moment exists individually. So, yeah, I don't know. It's a bit of a head fuck if you ask me. But
That's the
You know, if there's
classical
an infinite
mindfuck.
past, if there's an infinite past, you'd never arrive at this point. And yet here we are.
Yeah, I'm not even going to pretend like I understand.
Well, that's a profound statement. I never heard that one before, and that's actually pretty interesting.
Yeah, I liked it too.
I'm going to go back
I
to
don't have
smoking pot
I
again.
don't have a solution. Yeah, I don't have a solution for the problem, by the way.
I'm going to sit here and think about this for so long. I'm going to go back to smoking pot again just to try to stop thinking about it.
or use TMT. Maybe you'll find the answer.
I need a laser and DMT. That's what I need.
I just did a search on that statement we both did. Wow, we're both kind of right. Time is, in fact, at first when it came up with the rate of change, then I said, is time a rate of change, or is just a change of existence, as I was kind of saying. And it says, we're both right, but it says time is more accurately described as the measure of the change of existence, rather than the rate of change. Though both are debated in physics and philosophy. So we both were.
Yeah, but I like this explanation because we measure time with a clock.
You can measure time with anything, or I mean, anything can be a clock. I guess that can measure the change of state with the passage of time, with the change of its change of existence can be seen. Anything that changes existence can be
of
used.
course. Yeah, if we put this example to the movement of the sun and the moon, yeah, you can say it's a cycle. Yeah.
Well, it'd be relative to that, but what if you just had an hourglass? Because that would be related to the pull of gravity. What if you had something like, I guess the decay of the cesium atom? Then that's why they have atomic clocks. That becomes the best way. Then it's independent of.
And the rate of change is variable as well, isn't it, Zanik? Because time slows down as you approach the speed of light. So the story goes.
The rate of change changes as well. So that's kind of like jerk in the physics, into the Newton analogy. You got speed, acceleration, and the change of acceleration is jerk. And then snap, crackle, and pop, if I remember correctly.
Yeah. See, okay, here's a bit that I don't understand. So let's say, I wave my hand across in front of my face for 1 second, and then if I was traveling close to the speed of light, in my field of relativity, that waving of the hand is the same amount of time, but it's different somewhere else. That could be 10 seconds somewhere else. So that the rate of change, because that all of that time is measuring the change of my hand passing in front of my face. So the rate of change. Geez, I've just confused myself. I don't even know what I'm trying to say.
Yeah, it's hard for our.
It's variable. It's variable though. The change itself is constant. The speed to me that my hand moves is no different, but in respect to the theory of time, it is actually a different period of time it takes, depending on where you're situated relative to me waving my hand.
Supposed to be in a different gravitational field, it slows down or speeds up too, according to relativity. Yeah. If you're real close to a black hole, your time will be dramatically different than here on Earth.
Yeah, wait, but you have to use a reference. This is always a clock, and we're using this concept. Okay.
Yeah, but the clocks tick differently. So a clock close to a black hole, it may take a month to tick it 1 second by. It may take. Well, they've sort of measured this around different planets, but if you believe that, if you don't believe it, then I guess But they say they've measured it, like in different, like around Jupiter and stuff like that. They've measured it real precisely and shown that it's true.
But here's the point. is it a measurement or is it a reading?
Same thing.
With a device such clock. Yeah.
Same thing. You compare two clocks.
Yeah, but if you watch on your clock, yeah, you take a reading. You did not a measurement.
Yeah.
Right.
Yeah, you set two clocks to be as accurate as you can possibly make them. You send one to a place like orbiting Jupiter that has a very strong gravitational field, and you keep one here, and you measure the difference in them. And one will tick slower than the other.
I would say you compare the difference, but you don't measure it. But that's yeah, I can do that. But.
That's is a measure. It is a measurement. That's what they say they do. I mean, I've never done it. I'm just telling
It's
you
a
what.
question how you define measurement. But hey, anyway.
Right. I'm not trying to get into a big argument that they've absolutely done it or not. I'm just saying that's what is
cool.
said. You know, that's what they say that general relativity predicts.
So the story goes.
So the story goes. There's a good way to put it.
But then you got to think
Just really,
the comparison
just
between the
off topic.
two.
Sorry, my bad. Go.
If you're comparing the two clocks, right? The one that we have here, we know as seconds and minutes and hours, with this one that's at Jupiter. Again, it's like a man-made measurement, because if you didn't have the one on Earth with the time that we know to compare to, those seconds and minutes and hours that would be slower would seem the same. You know, like it's just like a man-made system that we've created to wrap our heads around time.
If you ever watch that movie Interstellar, they used this concept in the movie, and they got it straight from general relativity. And they go to a planet that's orbiting a black hole, and you hear a tick in the background the whole time that they're on that planet. They're only there for like a couple hours, and you constantly hear a tick in the background in the music. It's like tick, tick, tick. Every tick that goes by was something supposed to have been like 7 hours or something like that, or a month or something. It equaled up. So then when they came back, 20 years had passed for the people on Earth for like their 2 hours that close to that black hole. And they used the actual math out of general relativity to determine just how much time's supposed to be different between that strong of a gravitational field and Earth.
Yeah, but to be fair, it's
a theory. It's a concept.
Hypothetically, yeah.
Yeah.
Okay. Then I agree. The problem is when we reificate the concept of time to a physical thing, this is the definition of pseudoscience. I'm so sorry, yeah, but that's my position. Reificated concepts. Okay.
Yeah, look, I'd agree with that. I'd say that the thing which that concept describes, we all experience it. You know, our life goes by, and so you can't deny it. But yeah, I don't think you can reify it into something tangible or yeah. I don't even know the right word to use, but I think I'm on the same page as you.
Well, you know how like when you're a young child, let's say 5, 6, 7 years old, like a year seems like a really long time, and then the older you get, it seems like time goes by faster.
Hell yes.
Yes.
I think it's because, like, think about it this way: if you're 5 years old, 1 year is 20% of your life. At 50 years old, 10 years is 20% of your life. So, does 10 years to a 50-year-old feel the same as 1 year to a 5-year-old? If that question makes sense.
Yeah, it does.
That's funny. I'll give you an example. For me, when I hear 90s music, to me, the 90s weren't that long ago, but it was fucking 30 years. But genuinely, yeah, that song came out in 1998. That wasn't that long ago. And then I have to check myself and go, shit, that was a long time ago.
Yeah, I still look at cars from like 2000 as not old cars.
Not
You
that
know?
old. Yeah, yeah. I'll tell you what to do, Cole. Next time you see a car like a 98 Camaro or something like that, think okay, so that was 28 years ago from now. Think of when you first got your driver's license at 16, 17, then go back, whatever year that was, go back 28 years, and I bet you'll go, shit, that was an old car to me back then.
Yeah, yeah. It felt like, yeah, when I was young, get my driver's license, it felt like a 30-year-old car at that point. It was really old.
Yeah.
Yeah. Another thing I question is like lifespan. Like, so like a field, the average field mouse lives what, like 2 years? I don't know the real number. Let's call it 2 years. Does that 2 years feel like 75 years to the mouse?
Yeah.
And if that's the case, you know how like a mouse, the sound a mouse makes is like a little squeak. Well, if he's living on like a different time scale, to him, does that squeak sound like our voices do to each other now? Like, because it's slowed down?
I don't know. That's
Possible. Yeah.
This topic is
sounds like it's roaring like a lion to
Yeah,
its own self.
You guys probably think I'm smoking pot right now, but I swear to God, I'm not.
No, but does the mouse sound like Barry White to another mouse, you know?
Yeah, he's like, hey, what's up, mate? But all we hear is,
Yeah. That's funny.
Shit.
What? All right.
Hello, everyone. Everyone, hello. Anybody hear me? Hello. Hello, everyone. Hello. Everyone, answer to me, please. Anyone hear me? I want to talk with anyone. Hello. Hello. If someone hear me, talk with me. Hadi, low flat. Everyone, hello. Batman, lies. OWU, YouTube, Chris, Crit. Hello, everyone. Hello. 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 Look at me looking for. أيوة.
Is there anyone here? Hello.
Welcome to 24/7 Flat Earth Discord. Please try to remain civilized and cordial. If you have any questions, feel free to ask. The floor of the universe is Earth-shaped. Feel free to ask any questions you may have.
The simple fact that you're standing here listening to me means you've made a glorious contribution to science.
Outer space is science fiction.
You know, we call them our yearly shows, right? So you have exhibitions, basically town exhibitions, and all the carnival rides come to town, and we have the showground open, and well, they charge you to get in, but anyway. So, but at the pavilion, you go there, and there's competitions, art competitions, photo competitions, knitting and crocheting, stitchwork competition. Wool is on display and gets judged, and prizes given out. Vegetables, or like what you were talking about, or your pickles and preserves. A whole range of cultural skills sets on display once a year in every town in Australia for that town. Like, it's people go and enter in their skill, right? You know, the products of their skills, and have it judged and, you know, awarded if it's deserving. And I think that community should really super encourage that, right, to happen, because these are the things you're talking about that we've got to keep alive. Because there are still some people out there who know how to do this stuff, and if the world went to shit, they would survive better. You know, they'd be better off than other city folk who've like only ever read about this stuff, right, and seen this stuff in museums. And there is cultures out there. You know, there's a small percentage of the earth that's actually still preserving and keeping that alive. You know, it's great to see. There's all these there's people, you know, that are like talk about being doomsday preppers, right?
Yeah.
Man, people are just living like that anyway. They're going to be, you know, they know what they need to deal with to survive. You know, in harsh regions and things like that. There's, like you said, there is a world out there that we're even totally unaware of. People living in ways that would seem very, very primitive to us now. And they probably aren't even aware of our existence, to be honest. And you have groups of people wanting to like segregate themselves, basically, like disassociate themselves and disattach themselves from modern Western society, and they're out there. Don't worry, they're out there.
Yeah, if the apocalypse ever happens, you guys know where to go if you're ever looking for beef tallow. I got you.
There's always the Amish. They're like humanity's last backup plan. Looks like Jesus just entered the chat. Speaking of which, and it's somewhat on topic, but you know the country of Georgia? You know what's so fascinating about Georgia? They had a series of kings for 1,000 years. And their bloodline relatives are the House of David. They were Christian and relatives of Jesus's family. This is mainstream history for the country of Georgia. And even today, there are relatives and descendants who claim that lineage.
Yeah, every family should really like have a story to tell somebody in history that's, you know, from their lineage that they can boast about and brag about and feel pride in having, you know, come from, right? I don't see anything wrong with that. Like that, and lineage and ancestry should be honored and remembered, respected. You know, how many people can like talk about their, you know, great 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 grandfather? Know any stories about him?
Yeah, it's pretty rare. I mean, I used to think it was normal. You know, our family has deep roots within American colonialism, going back. Like, you know, I can trace my family here back to the first settlers in Virginia and Massachusetts, and even to England and Wales before that. I didn't realize that this was extremely rare to do until I was much older. You know, and this came from family Bibles. I'm not sure if this is the way it is in Australia, but you know, in America, typically you had a Bible with a family tree in the front, and you would record your family tree going back from the Bible that preceded that, and so on.
Family Bibles, we used to have that in the UK. That fell out of fashion about 40 years ago, of like the last generation or so.
Yeah, I would say it's probably not in fashion now either, but
No, I don't know anyone over here that follows things like that. We've got whole books dedicated to genealogy. So if those who are into tracking, like my mum's done her family, and that traces right back to Urquhart Castle, and which is a couple of 100 years. On Dad's side, it's a bit scattered, but Mum's side's pretty straightforward.
Yeah, my wife's grandmother, she has the family Bible that has the family tree in it. I don't know. I don't think my side has anything of a family tree.
some of these Bibles used to have the Hebrew cosmology depiction of the earth in it too, with the earth on top and Sheol below and heaven above.
Yep.
My grandparents and great grandparents used to talk very fondly about the World's Fairs that they attended. I mean, even through the 80s and early 90s, they used to talk about it all the time. All the pictures, all the fun memories. And floods, strangely enough. Yeah, floods.
I think it's that. Um, you know, local flooding that gives a lot of people reason to think that Noah's event was a local flood because local floods happen all the time.
Yeah. I have a grandma who used to talk about, I'd first heard about this in the 90s from her family records about our ancestors' encounters with blue-eyed natives that they called the Welsh-speaking Indians. And I came across this much more recently in my searches, and I was freaking gobsmacked. I used to think Grandma was crazy. Have you guys heard about the Welsh-speaking Indians in the Appalachians?
No, I'm sitting here a little bit gobsmacked, mate. Welsh speaking Native American Indians. That's a bit fucked up.
You
Did they
want to know
say?
how? You want to know what the story
They're
is?
probably war Titan.
I'll tell you what the
Welsh don't
story
wear.
is.
It's
Was it anything like the Vikings settled around 1000 AD over here?
Close but far.
Dan.
The son of King Arthur, the grandson of King Arthur, fled because of the Saxon invasions and took fleets of ships and people and sailed out west to a land that they heard existed way beyond the west. The story goes is they crash landed in Mobile, Alabama, which is on the Gulf of Mexico, and they went up the Mississippi. They went up the Mississippi River and built settlements. Yeah.
Okay. How much credence do you hold to that story?
I would say I'm 50-50 on it, and I could be swayed either way.
I would say plausible.
I would have said, yeah, definitely plausible. I just don't know how they would have ended up in the Gulf of Mexico, unless that's where.
Well,
yeah,
think about how airline flights go. They go up over the northern Arctic, and then they come back down on the other side. And the way King Arthur left, the story was that he traveled to a land in the far north and was never seen again. Well, if you go north from England or Britain and continue going north, eventually you're going to run into Canada, United States, Gulf of Mexico, and so on.
Well, the thing is there are artifacts that have been recovered that speak to this, and there are stories from the colonial days in the 16 and 1700s in America of encounters with people, with natives with blue eyes, and who had interesting words that were recognizable by some of the settlers who came from England in the 1600s and Wales in the 1600s, and understood that this to be some kind of strange Celtic, if not Welsh, cognate.
That's really fascinating.
Yeah, that's it. Like, we've got old records of these encounters from 400 years ago, where people are like, "Well, this is freaking weird." Like, they have blue eyes and they've got these Welsh sounding words.
How many generations or years later, after their arrival in America from Wales, were they discovered to be these Welsh-speaking blue-eyed Indians? Is it like straight away, 100 years?
We're talking about maybe 700-800 years between.
Fuck no.
Okay. Yeah,
that's crazy.
I mean, it gets even crazier than this, guys. Like, I mean, they're like amongst the Cherokee tribes, there were certain rituals and words that were used that freaking rabbis of Israel had studied. Yep. Sheepdog, you know what I'm talking about?
I know what you're talking about.
You know what I'm talking about.
There was also an elder, I think it was Peru. The elder would recite Shema in Hebrew rather than speak in the I think it was Peru.
Like, the Cherokee have certain rituals that are the same as ancient, like Old Testament Jewish rituals. And then the Cherokee also have stuff going on before and after those rituals that the ancient rabbis thought were lost in time, and kind of connect the dots for them. I don't have any more information much to say about that, but
yeah, there was also
DNA connection.
Well, yeah, the DNA part, it's like the North American or the American natives, they've got the most ties to everyone everywhere, and but what I was trying to remember the name of the YouTube channel that interviewed some Native Americans who went to Israel and some dancing and singing at the wall, and the Israelites were telling them, "Yo, stop saying that. Stop saying God's name. You can't say that."
Yeah,
And
I heard that too.
their tradition was once you start singing and dancing, you don't stop until it's over. And so they were furious by the end of it. Why are you saying our God's name? And they're like, what are you talking about?
Yeah. I've got the impression almost that North America, maybe South too, was almost like it used to be known in antiquity, perhaps amongst the elite. And I think and I wonder that they used to come here for vacations to get away from everything and then go back. Almost like it was a big secret. And there's so much evidence of trade and exchanges and knowledge between these two places. Christopher Columbus, when before he decided to sail west, whoever he was, some say he was like a wayward son or prince of Poland or something. Whoever he was, right? I mean, the record stands that he had done this thing. Whoever he was had done this thing and sailed out west. But he had visited Istanbul, and by his day, like Istanbul was new, it was Constantinople for over 1,000 years at that time. The true seat of the Roman Empire, not Rome. And he went there because he knew that he could acquire maps. And he left with those maps. And those maps today appear to have coastlines from Antarctica and Brazil drawn on them. And these are maps that probably were created in the Dark Ages.
Do you guys know the equivalent New Zealand story to this?
No.
Well, there is a real tradition among Maori here of a whakapapa, they call it. It's like a genealogy. Whenever they meet another person, then they talk about what boat they came on and what their mountain is and their river. So they've got a very rich history of like connecting their genealogy as far back as they can. But a lot of people think New Zealand was first, inhabited like 1,000 years ago, right? But, Polynesians coming from the South China Sea and Hawaii and stuff like that. But there is a whole bunch of still living red-haired Maori with green, blue eyes and very, very different. But they're still all tattooed up and completely in the original. They've been there forever, right? And even Kupe, when he came to New Zealand on the Polynesian, he talked about the redheads being there. I think they even taught them how to make fishing nets and stuff. But the thing is, right, because their whakapapa was so rich and that they were keeping their history, this one woman, red-haired woman in the Taupo area in the middle, the volcano lake, she said that her family were persecuted redheads in Persia, and they fled in an exodus, and they went first to the North of America, then they went to Mexico, then they went down to Peru, and I think they were in Peru for many, many, many generations, and then they went to Easter Island, and then they came to New Zealand like 4,000, 3,000 years ago. And what was amazing was there was a series that's very banned called Skeletons in the Closet or Cupboard, I think. And they did her DNA because she was swearing that she came from Persia. And it totally checked out, like it completely checked out. And all her little grandkids, they're still redheads and blondes. And they're clearly like, she's got old photos of her family, her relatives, and it goes way back. And yeah, it's just a really fascinating story. It's like a 3-part series. You can find it sometimes, maybe on Rumble or BitChute or something. You could probably find it. But yeah, it's really fascinating. And there's a lot of evidence as well, because there's a lot of relationship, like with the kumara, the sweet potato comes from South America. The Maori is really a melding of cultures of Polynesian and these people that came from South America, and that's what makes it quite interesting. But yeah, that's the what I've been looking into. Wow, did I shut down the whole room?
No, just soaking it in.
Just one word. Shut down the whole room.
I think he
And
shut us down when he said they were called the Fucker Papa.
Fucker Papa, yeah.
And it'd be spelled with a PH.
WHAKAPAPA. Oh, I've got to go to work soon anyway, guys, but I love listening to you always.
Glad you could be here.
Appreciate the story. I'm still trying to get over Welsh people being it, Native American Indians, and this whole red. I didn't ask earlier about the red hair, but the red hair thing is really interesting, especially in New Zealand. It's really far away from red hair is apparently naturally supposed to be found in the world.
Yeah. And I mean, they've found redhead mummies in China, haven't they, as well? But there's another piece of evidence here in New Zealand, and it's allegedly at the Te Papa Museum here in Wellington. And it is a moa bone. What they used to do is chase those big moa birds into mud, and then they would like machete them at the legs and go and eat them at a fire near the mud pod. But one of those mud areas got covered by lava flow that is provably, according to the scientists, 3,500–4,000 years old. So they're all going on about, Maori being only here for 900, 1,000 years, but there's such a different history. And I think they cover it up because it's not convenient for their whole New World Order plan to have, racial division and people, being treated differently according to race in New Zealand. It's gone pretty feral here.
Especially if
it's
they've
gone
got
feral.
land claims and so on. Yeah, especially.
Yeah, so they don't want anyone to sort of stop that fight between Maori, probably mostly Polynesian Maori, and what they call Pākehā. We're called Pākehā, which I think is so rude. But basically that identifies us as being,
like
the white New Zealanders. Yeah.
Yeah. Sounds racist.
Yeah. It's ridiculous. I mean, I think they just want, the usual division and chaos so that they can bring in their UN bullshit.
Yeah. Seems to be the usual MO.
Mode of operation.
I honestly feel like we were mixed and nobody gave a shit. My honest opinion. Like, in
Yeah,
Virginia,
I reckon too, Jimmy.
I'm pretty sure it's Virginia. I could look it up again, but in the late 18s, early 19s, they were starting the process of relabeling people based on their skin color. So in that time period, there were a lot of people who were Native American suing hospitals and government for labeling their child black, and they were losing their Native American status. So effectively, they were missing out on, long-term benefits that would be theirs. And today, like people, I'm sure there would be people that are actually like able to trace themselves to Africa, but you got a lot of Black Americans who could be mislabeling themselves because they believe the propaganda rather than, knowing their actual history and actually being Native American, only because they decided to relabel people at a specific period of time. And then, everybody lost focus on that because between that point and now, you've got, in the Americas, MLK and that whole time period where you separated people based on color on the bus and, eating at different buildings and all of that jazz. Like, it got lost in the sauce.
Very, very good point. There's just certain things that I just don't, it baffles me. Like, how can they just not see it? How can they just not get it? But, again, I guess everyone's different.
Yeah. I know we were talking about this a bit before. Like, you look in the field of geodesy, right? Geodetic surveying. Literally, people who are paid to measure the freaking earth for a living. And what do they do? And what do they admit? What do they have in their textbooks? And how do they apply it? They measure Earth flat and then break their perfectly good flat Earth measurements and bend it around an imaginary ball. Like, what the hell? And you guys are okay with this? You guys have been doing this for like 200 years and you're okay with that?
Right.
Right? Like, and if you question the process, like saying, wait, why are you putting the cart before the horse? Why are you assuming a reference ellipsoid before you, start to wrap your measurements around it?
Right.
Because it has to be, because it has to be. It has to be a globe, guys. Come on, everyone knows it's a globe. Like, ever since Eratosthenes, measured shadows, and even though it didn't prove anything either way, it gave us enough to believe in the globe. So the Earth has to be a globe. Like, everybody, come on, dude. How could they put moon men on the moon if it wasn't a globe? Like, come on, guys.
Yeah, exactly. And it's interesting about that too. I was just watching something the other day, and I guess they were kind of focused on Buzz, like because in his late years, like they're really having to watch him now because he's going in interviews and still like, no, you didn't, like they keep replaying these, the videos of him saying that. I think there's four or five different videos of him being interviewed and him literally like, no, like that's not what happened. And
because we didn't go, and that's the way it happened.
Right.
You didn't see us. You saw an animation.
Yeah, he legit said that to him. And you can see it in Conan's face. He's like, wait, what? Like, wait, are you supposed to be saying that? And then he even like makes a joke, like, I don't remember, he kind of just waves it off, like, ah. That's interesting.
You can go back further to like the Sputnik thing. And this is the focus of my research on history, is the transition point between Earth and space, the space program in its infancy. When Sputnik was first claimed to be a piece of self-orbiting space junk, it was not as widely received by the public as you're led to believe today. There was total skepticism. First off, people didn't believe it just because the fucking Russians said it.
Right.
Second off, you had people writing into newspapers, like university professors of physics and shit, saying there's no fucking way that the Russians could have done this the way they said they did, even if Earth is a globe, and here's why. And then, to me, the biggest tell, guys, the biggest tell is the United States Secretary of Defense, Charlie Wilson. Yeah, Charlie Wilson's war, that Charlie Wilson, right? He said at the advent of Sputnik that it was a cheap scientific trick.
Yo.
So I'm like, oh, is he like
Sorry to pause it there. I just want to point out, wouldn't that be what you expect during a quote unquote space race? Each side dissing the other, downplaying their achievements, accusing them of fakery, that sort of thing, doubting. You know, like that's what you'd expect between two warring factions, right? If it was a war, truly a war, right?
Yo, is this channel rage bait, or do you guys actually believe that Earth's flat?
There's no belief necessary, bro, because it's a lived experience.
How is
Right?
that a lived experience?
Well, do you see any
Have you not?
curvature anywhere?
What?
Do you feel any motion?
You can feel an emotion. Have you read the gravity?
No, it
Your
doesn't matter
entire
why you
has
think that
Earth.
is. It doesn't. Hey, we're talking about what the experience is before we get to the excuses for why it is, right? Do you agree? Do you agree that it's a lived experience? The Earth
mentally
being flat and
referencing some kind
motionless?
of scientific tricks that the United States was contemplating at the time in order for him
Pause that
to
again.
come up with the idea that this could be a scientific trick? Like, why would that be your
Right,
first
stop it.
impression upon hearing of?
Do you agree that it's a lived experience?
What? That
Okay, the Earth appears flat and feels motionless. Yes or no?
okay? Yes.
Right. So no belief is necessary, right? It's a lived experience.
But have you ever traveled in plane,
Yes.
or maybe wait, exactly, hot air balloon? Have you ever traveled in hot air balloon?
No, I haven't actually. That'd be fun.
Go travel in hot air balloon. You will see the curvature of the Earth.
Really?
That's
Anybody
real.
else up for this, man? Because I've got to do some other shit in the background. I can't. I can, but I can't at the same time. You hear, Jimmy? India? Crit? Anyone? Oh man, he's gone. Never mind.
Man, I just thought that was still the recording.
Oh really? Never mind.
Yeah, because it paused, conversation continued, and well, it's playing in the background obviously because it was a recording. And so I was like, all right, this must be a new video. And then you was like, I can't have
Yeah.
time. Pause. Yeah, my bad.
Yeah, and there's a glitch too, like because it started replaying there. Somebody joined just after he started talking. There's a glitch where if someone joins while the bot's paused, it resumes it, and it's like gotta pause it again now. And you don't want to stop it because, like, if they do what he just did and leave, then yeah, like it's worth stopping it if you know there's going to be like a lengthy conversation out of it, but not if they're just going to dip after like a few sentences. All right, I'll resume. I only stopped to just point that out. Like, yeah, there should, like, you should find that sort of shit like in the newspapers and in the textbooks and from that period, right, where one side was like, you know, critiquing the other, like saying, "Yeah, sure you did," you know.
Well, I mean, they were, right? Like, you got the Polish, the Russian, and I want to say Swiss, but I really can't remember. They're all saying, like, nobody's been to space, NASA didn't go to the moon. And then when we point that out, it's, oh, well, there's this special reason that causes it to be a void example, even though I asked you for an example of somebody whistleblowing.
Right, yeah. Like, you get these people that come in and say, well, if they didn't, you know, if they didn't do what they said, then Russia would have pointed it out, right? It's like, how do you know they didn't? How do you know there was, how do you know there wasn't, you know, that kind of thing going on? Have you read through the newspapers, have you? You read all the scientific journals, did you? There was nobody said one thing like that, not one.
Sputnik, that is a scientific trick. What trick is that, folks? What's the trick? What trick was he imagining? Does anybody have a clue? Let's say you globelings out there, you folks, anybody listening, you believe Earth is a globe, okay? Let's say that Charlie Wilson was also a glober and the Earth is a globe, okay? Why would Charlie Wilson call that a scientific trick? What makes it a trick? What makes it scientific? What do you think he was thinking about? Any idea? Was it freaking balloons? Was it satelloons, raccoons? Was it some kind of weird like radar radio interferometry bouncing off a firmament? Whatever the fuck it was a scientific trick that he was thinking of.
Yeah, it's interesting too because matter of fact, I believe Sputnik was the first thing that they used to check the measurements that were done back in the 1800s in regards to the how thick, or should I say how thin, how less dense the air was way up there. I believe the Sputnik one was the first one that they said it matched their math. So they literally mathed out space before they even got to it, and then they just said, "Oh, it matches our math," so we were right.
Isn't that funny?
Yeah.
There's also another curious point. Where in the late 50s, early 60s, they were transitioning from balloons to self-orbiting satellites. And the story's messy. You can read conflicting reports about rocket launches and the payloads that they delivered. In some reports, you'll read that they deployed balloons, and in the same or different reports with the same launches, you'll read that they weren't balloons, but they were self-orbiting satellites, and they kind of fucked up.
Yeah.
So, case in point is like not Explorer 1 and Explorer 2, which were the answers to Sputnik, but we're talking like Explorer 8, Explorer 9, and going on beyond that. At one point, they were saying that they were launching self-orbiting space junk, that the space junk itself would pop off balloon satellites as it would self-orbit itself.
Oh.
You know, they kind of covered all their bases there.
Right.
Yeah, and they can't go back, right?
So
They can't go back. Go ahead, T-Dub.
You got this balloon attached to something that's experiencing neutral buoyancy. Like, what's the purpose of it? I guess to get it there, then it's just useless, or what? Like,
one of the craziest things I remember seeing was a documentary by Bell Labs. I've posted this in our home server. If you go to #satellites and 24/7 Flat Earth Discord, you'll find it. The Echo 2 deployment, and the Bell Labs documentary describes what they were doing. They said that a rocket went up into space, and about 1,000 miles altitude, it popped off stage 2. And stage 2 was a capsule that
that blew open, exposing to the cosmic rays a gigantic neoprene trash bag. And inside this neoprene trash bag was some spring-loaded mechanism that included what they said was powdered helium. In the documentary by Bell Labs, they said when this powdered helium was activated by cosmic rays, that the powdered helium turned into gas and exploded this balloon. And now the Echo 2 satellite was fully deployed at 1,000 miles high as a gigantic balloon full of helium.
Wow.
At 1,000 miles. How high do balloons go today? They say 120 miles. How come you have a helium inflated balloon at 1,000 miles?
And for what purpose? To hold it up?
To hold it up. But they also said, hey, it's providing a reflective surface for radar to bounce off of, so you can track its position. So, fast forward like 20, 30, 40 years, right? And you know what they've got now? They've got some super special technology where the device inflates at 1,000 miles altitude and hardens. That's right. Just like when the dentist holds the UV light against the filling that they put in your teeth and the liquid turns into a hard shell, they claim that they capture the ultraviolet cosmic rays up there, and it takes the balloon that they inflate and hardens the exterior into a super tough exoskeleton. And then they pump out all the gas inside. And now it is so buoyant because it's empty, like a vacuum.
I wonder how many space turtles died choking on these space balloons.
I know, right? So they're doing this shit, right? And like the rest of the country, the rest of the world thinks that they're putting out space junk with solar panels, but they never show you the gondola and the balloon. What's also interesting is the balloon material is so thin that radar passes right through it, so you can't even like scan it. And then if it's dark and non-reflective and all that, you'll never see it. So it kind of makes me wonder, right? When they show space images, but they don't show stars, it kind of makes me wonder if the reason why they don't show stars is you're going to realize that there's something the size of a fucking stadium that's black and it's blocking out the stars as the camera pans around and moves.
All right. Yeah, they don't show the stars because the black is in space.
And you know what? They actually show you black balloon satellites. Look no further than the U.S. Air Force program. And a satellite that is called OV-1-8. You can Wikipedia this shit. OV-1-8. OV-1-8. Wikipedia satellite. And you will see a massive black balloon with a hexagonal wireframe mesh around it. And this was in the late 60s. It's a freaking stealth satellite communication balloon. But, flat earthers are crazy for coming up with this shit. Well, yeah, we just find stuff on the internet and tell people about it. Sorry.
Yeah, sorry for us wrecking your Christmas.
Yep, we've got some loyal listeners in the chat who are posting images of it. Look at that. Look at that. 1960s technology, folks.
Looks like a giant soccer ball.
That thing is said to have been floating at 1,200 miles and flying at over 17,000 miles per hour.
Crazy.
A balloon, people. A balloon. Fucking balloon, guys. And this is during that whole transition period I'm talking about, where it's like they're trying to figure out how to get their fucking story straight.
Yeah.
Yeah. At some point they ditched the balloon and just showed you what's dangling underneath it.
Pretty sure eventually there's going to be another point where we come to and realize, oh wow, we've had this new technology. They're like, yeah, we've had that since 2026, but we didn't see it. It's like 2045. We're barely seeing it. We're always behind. So what they're saying we can't explain right now, well, I mean, I'm pretty sure eventually they're going to. They're going to be forced to.
Hello.
Eventually, at least.
I posted a GIF with that supersonic rocket sled going about 6,500 miles per hour. And when I watch that, I try to imagine what double that would look like, and it's just mind melting.
Yeah, or 3 times that even.
Yeah,
right.
it's crazy.
Yeah, 2.5, 3 times it. Yeah.
It's definitely crazy to think that they think that they're going to convince us that there's something moving faster than that. I don't know, maybe
it is, right? Maybe there is something exotic going on.
Yeah. You just don't know.
I'm open to that too.
Same.
You ever dig into Robert Bassano and his research?
I'm not good with names. Post it. I'll see if I've seen it.
I can't right now, but he had a channel called Planete Veritas, and Quantum Eraser and Catexus used to do live streams with him. He's the guy that called in, like he would take the NASA phone book directory and call random people and try and expose NASA.
I love that.
We need more of that activism, folks. We need people doing this shit. Listen, government employees are open source. Their phone numbers and contact is open source. It's not illegal to go find their names and phone number and contact them and ask them questions. You're allowed to do that. America.
Right.
But he had a really interesting way to conceive of the world. He wasn't necessarily a flat earther, but more like a super duper oblate spheroid earther. He had this whole thing about relativity too. He kind of accepted some of it, but explained it in a different way. You know, that satellites, when they're sent up, experience general relativity, and the higher they go, the further out they get, the more that they can send and receive signals as such that it allows for essentially trying to grab information from the future. I know it sounds crazy as dog shit. But I mean, if you were exposed to all the kinds of things that he was exposed, you'd kind of understand why he was way out there with some of this stuff. And the blackness of space wasn't empty, but rather superfluid helium. And you would pull up like University of Maryland astrophysics department papers on this very subject and superfluid helium vacuum theory.
Oh, cool.
Yeah. I mean, he was way out there, and the sun is a gigantic ice ball, actually, and it's not really hot but cold. Like,
wow.
But I mean, this it kind of just highlights what is going on here. That the further you dig into things, the more you find greater possibilities of not only being wrong and the mainstream being wrong, but other crazy off the wall batshit things that you'd normally dismiss as being more likely true.
Right.
He's got some great podcasts. Like he talked about the freaking radiation anomalies over Earth. So like there's some parts of the world where airline pilots fly that they can pick up multiple times higher dosage of radiation than they would there than other places. That's why they have to wear those badges that turn black gradually over their careers once they receive, and the threshold limit of rads that they have to retire as pilots. So pilots who routinely have to fly through these regions of super high radiation have shorter careers. So he's going into that. Like there's so much shit on his channel. Planete Veritas. If somebody could post that channel, you're going to get it all. You're going to get balloon satellites. You're going to get all this crazy shit we're talking about and so much more. You're going to listen to him calling NASA and talking to the deputy director of the Hubble Space Program and the deputy director of Hubble saying that he never had direct access to the data from Hubble.
Wow. Not even he did, huh?
Not even he. Yeah, the guy who's in charge of it. Number 2.
Got to tell you something.
Yeah. It's like, oh, why would I need access to that? I mean, I have, there are all these other people that do, and I don't have to get down to that level. Like, why would I need that? I get all this gate kept information, and that's fine by me.
Yes.
Thank you, Timbo, for posting that. Robert Bassano. Hope he comes back. He came back briefly to say hello. He was interviewed a few years ago. But I mean, that guy uncovered so much. He just had to dip out. He disappeared.
I think there's a lot of stuff missing from that channel as well. So I don't know where to find
really?
all the old stuff. Yeah.
I know his Google Drive got taken down, and I tried to get as much stuff off of that as I could, and then it was gone.
I think the only one that I would know that might have all that old information would be Flat Earth Dude.
Really?
He knows him, so.
Oh gosh.
Yeah.
I almost don't want to dox myself, but I think I met him once a long time ago. Based off of where he said he used to live and what he used to do for a living, and based off of what I remember, I think I met him in Maryland.
He did a lot of photography, right? Like moon photography and stuff.
I don't remember
lives.
that. I wasn't around back then for his heyday. I'm kind of a latecomer. I've been in this since 2021.
Really?
Yeah.
Rookie.
You know way more than I do.
Yeah. Well, maybe because I'm a bigger nerd and I spend a lot more time on the internet.
I was going to say it might be the profession. That might be the difference. I build shit. You study shit.
Yeah, true.
Good to see everyone again. Anyway.
Yeah, good to have you back, man. It's been, you've been sporadic off and on here past year or so.
Yeah, it's hard to find the time, but I'm always around. I'm always listening. Helio's YouTube's not on anymore, so I got to find the other channels, but I just haven't looked properly.
He might really, because I think his YouTube bot is still in right now.
Let me have a look.
Flatloid is the one that says YouTube, and Helios is red with the
Yeah, I've noticed sometimes I go to Helios channel and it's not there.
Whoa.
Yeah, it's not live.
Whoa.
Yeah, it's not live. It's not live at the moment. You're getting an echo T-dub. I think. From your...
It's not me. It's Max. It's not me. It's Max.
Max. Max.
Oh, sorry. More XSC. I'm just going to mute him since he has no freaking social awareness.
I got to say, guys, like, I'm so freaking grateful that there's so many Australian flat earthers out there. It just totally eliminates all the stupid shit we have to deal with. And people are like, oh, you're a flat earther. You think Australia doesn't exist. And then, like, 10 of you blokes show up and be like, I don't know, whatever in your Aussie accent. Like, fuck off.
Yeah, we're here. Yeah, we're here. We're in Australia. It exists.
I mean, it must really, like, these trolls, it must send them for a loop. Like, oh, fuck.
Yeah. I wish they knew where that actually came from too, right? Remember that guy? I reckon there was someone going nuts, right? It was like, fuck, I can't believe any of this stuff anymore. Can't believe anything what they tell me. For all I know, Australia doesn't exist. And that's where it came from. That comment, that was it. And then they go, flat earthers think Australia doesn't exist. So fucking... That's dumb.
Not discounting the whole, history of discovery of Australia is weird.
Oh, yeah.
Right? Like, the Portuguese found it like 300 years before the British.
Yeah, and the Dutch as well. But they say when they found it, there's like maps of Australia with a sea in the middle of it, like that you could sail up through. And but these are what some of the maps say. And then if you actually go onto the map and look at elevations and stuff like that, we got this huge lake in the middle of Australia, Salt Lake. And if you follow the path where the old map is, it goes right through the middle of Lake Eyre and through the Eyre Peninsula in South Australia, and then goes into the Gulf up in the north of Queensland. So it's really fucking weird stuff, man.
Yeah. In America, California is depicted as an island with coastal cities on the inner part.
Yeah, yeah. And there are records of that being a sea there.
Yep.
Because that's a pretty deep depression, that area where it's supposed to be.
Right. I think that's the Wine Valley. I think that's like Napa Valley.
Is that the same area as the Salton Sea? Would that be the same area? Or is that up higher?
Oh, shit. I should probably know, but I don't know for sure.
The Salton Sea is in a depression.
It is? Yeah, because that's all dried out now, right? Because there used to be fucking like water skiing and holiday homes and shit like that. I don't know what it's like now. I watched a documentary about it, how the land's just fucking dead. Because they stopped water from going into it from one of the rivers. I don't know. History's definitely not what they tell us, but
dude, we've got in America, we've got a history of Russian forts and land holdings down from not only Alaska, where everybody knows that used to belong to Russia, but down through California and even on the island of Hawaii in the middle of the Pacific. It was all Russian. Nobody talks about that shit.
Yeah. And then how do you how do you go about confirming any of this stuff, right?
Well, I mean, the old maps from Russia confirm it, but in American history books, they don't talk about it, which kind of makes me wonder. Like the American Eskimo Indians in Alaska, like a vast number of them are Eastern Orthodox Christians.
What?
Yeah, I'm not joking, dude. Going back hundreds and hundreds of years.
What's their language like? What's it related to?
I don't know. I don't know, but
Yes.
I mean, they know
Maybe
Russian. They know Christian Russian saints,
Yeah.
and there are churches going back a long time too. And there's like even today there are historical sites in California that are like old Russian towns and cities. And what's interesting is you got to understand this is like way before the Soviet commie era. This is when the Tsar of Russia was in control, and like Moscow was the third Rome, and all of that. Like there was a lot to Russia, and Russia's prominence has been totally diminutized since the Bolshevik Revolution for everybody in the world.
Yeah, they just wiped it all.
Yeah, I mean, the Bolsheviks killed 3 times as many Christians as the Romans did in like 1/30th of the time.
Yeah, but no one learns about that, do they?
Nope.
They only talk about, I'm not gonna say anything, but
I know it'd be great to talk about it.
Yeah, a portion of them, like a lot. Okay, if we believe the numbers, but like, what about the rest of the people that died during those wars? Like, are they not to be a protected people? Like it is
right.
Weird.
Collateral damage.
Yeah.
There's such a thing when it comes to human life.
Yeah. What about the gulags and stuff like that as well? Like it's fucking millions and millions of people, hundreds of millions of people, just slaughtered. If we're to believe the history. Right? It's like another thing that I know I'm way off topic now, but China's population, right? How does a population grow so quickly when they have a one-child policy for so long? And there's only one generation since it's been lifted. How the hell does that happen?
Yeah, especially the Mao Revolution didn't do anything to help that country at all.
Yeah. So where did all these people come from?
I just don't think the Chinese know how to count. The abacus doesn't go that high.
Yeah, I think it's a fake population.
I'll tell you where they came from. They were Cabbage Patch Kids.
Because you got to wonder, right? Because it's such a private place. Like, we're just getting information from them, right? No one's going in there and counting their population and doing a census. They're just going, oh yeah, we've got 1.6 billion people. You go, yeah, okay, they've got 1.6 billion people. I always had this theory because we got a lot of Chinese people in Australia. I reckon that they send these people over with like say lots of Chinese money in their account, right? They come here, the Chinese just put digits in someone's account, and then what they do is they come here and they buy property with it, transfer it into real Australian dollars, and then they rent them out, and then the rent money that comes from that gets taken back to China and laundered as real money, and they get real money from it, from fake digits in an account. How are we to know how much money's in their account? Like they're just bringing over digits and buying property with it and laundering it into real money, and we're the idiots that are letting them do it.
We didn't have this problem when we had gold and silver, because if you didn't have gold or silver, you didn't get anything.
Yeah, how do you police anything, right? If China's got its own banks, they just create money out of nothing. I mean, we do it, so Why wouldn't they, right? Exchange fake money for property. It's a really great idea.
I think so. It's starting to. It's going to be warm soon. Like freaking goodness. And like I'm going to be doing a bunch of observations. Yoder's going to be doing a bunch of observations. I think Matrix said he got a camera, so we're going to be doing. We're going to start. I'm going to start cranking it up. So I'm going to be cranking out content. So, and DJ, they said DJ used the last one I did against McToon, and McToon freaking spurred out or something. I want to hear that.
Yeah. I'm planning to do this. I'm planning to do the same thing. I'm planning to buy a camera that I can use for infrared and do observations to confirm my optical framework. So all of us are going to be doing some good experimentation that is going to fuck them up.
Yeah, I got plans to make a ton of content this year. I'm gonna be doing tons of just 101 stuff. I think there's a huge gap at the moment where all the when people come in and they say, "Oh, do you guys have some videos we can go and watch?" I don't know what to send them because I don't want to send them any of the Eric DeBay stuff or the ODD stuff or anything like that. So I'm gonna, I'm just gonna make a lot of 101 stuff, just covering the basic questions. So the same 20 questions they all ask when they come in. So different time lengths and stuff like that. Right now, I'm working on the McToon debate that I had yesterday. Just got some interesting ideas with that. I'm going to put together my own video where I played.
Where'd you have it? Where was the debate?
What's that? Oh,
where
it was in
the debate?
QOps. Yeah, QOps server. It's
Because someone last night sent me.
Mm-hmm.
Charlie Handsome sent me a link to that anti-truther live.
Yeah, that's where it was.
Oh, okay, that's where it was.
Yeah, I've got the replay. I've downloaded the McToon one, but McToon's audio was cutting out. His audio was cutting out sporadically, the whole time. But the anti-truther league one, the audio is perfect. So spliced with
good.
Yeah.
So he was on his stream. He was on his. He was live streaming.
He was live streaming, and QOP was live streaming as well, and it was hosted on QOP server.
Oh wow!
And I was listening to it. I wasn't planning on debating him or anything like that. It was I was sitting there. It was 5 a.m, and I was listening to him. He was kind of wrecking that, it was DeMarc and people like that in there. So he was just making fun of them, making fun of flat earthers in general. And I heard him saying a bunch of things that I was like, all right, well, he's made a bunch of claims. And if I go in there now with some of the information that I have, I can make him, shoot himself in the foot.
To the fire, right?
Yeah, because what he was talking about, I was sitting there listening, and he's saying, "Oh, I did an observation of a sunset the other day, and it was perfect conditions where the water temperature and the air temperature were the same, so that mitigates the refraction. And then we got a perfect sunset because we had perfect refractive conditions."
Oh my god, what a setup, dude! He freaking T-balled it. He set it up like a T.
And so I had to get in there. It was 6 o'clock in the morning I was so tired, and I'm just like, screw it, I got to get in. So I got all of your stuff saved in my server for that 10-mile observation with the boat. So I jumped in there. And look, right before I jumped in there, he was acting like Mr. Nice Guy, because when he's in control, he acts like Mr. Nice Guy.
Of course,
right? He picks up his puppy dog and he's laughing and smiling. And what he did, he told everyone, "I've just demodded someone from my YouTube chat because they weren't being nice to someone." It's like, everyone, you need to be nice to people. And even if people share different views, you just have to be nice, right? It's very important in life to be nice.
He was saying that dirtbag.
Yeah, he was saying that.
Wow.
Yeah, once I heard him say that's when I had to jump in, because I knew he was gonna spiral. He's never spoken to me before, so I jumped in. I was being super polite, super friendly, and I was just laying out the observations step by step. I stayed super calm, and I was just going over all the details. He was very patient. He was being very nice to me, letting me pull up all my files and go over it all step by step. And then once he realized he started to get cornered, right? Once he started to click that I had all of the things that were pointing towards it not working on a globe, that's when he just turned into this freaking globlin, man. He just
Globlin?
He was yeah. Oh, it was crazy. It was crazy. Have you guys seen those foreshadowing videos?
No.
Foreshadowing? It's like a guy is so he's in it. Basically, it's a situation where someone's talking about doing something and it turns into an absolute disaster, and they start freaking out or something goes wrong, and it shows them talking, and then it starts showing clips of them freaking out while they're talking. It's called foreshadowing anyway. But I'm going to put that at the start of my video that I'm making right now, because he went to madness for no reason at all. I just stayed super calm and polite, and he was freaking out. He called me. He was just. Once you listen to it, I won't spoil it.
I can't wait, man.
Kind of fun.
Yeah, man.
Yeah, it'd be good if we could we could just play it through the bot and listen to it sometime in here.
I'm looking forward to that.
Yeah. Yeah.
I listened to it. You're great. Like, you remained completely calm. It was, if someone didn't speak the language and they were just listening, you clearly won just by that, because you just remained calm and patient and in control, and you just sounded so much more confident. And he was slimy.
Yeah, he was trying to be slimy, and I made him contradict himself a bunch of times. Like, firstly, he said he had a gotcha, right, in your observation. He said, how come I can see a buoy off in the distance when the camera pans over to the left, and the bottom of it's missing behind the horizon? It's like the furthest one out. And I started saying, well, that's absolutely ridiculous, right? Are you saying that you can't have bottom-up obstruction on a flat surface? And he said, yeah, you cannot have, it's impossible to have bottom-up obstruction on a flat Earth. Mm-hmm. And he was just setting up for failure right there, because I started getting into sinking refraction. I asked him, do you know the definition for sinking refraction? He said yes. And then he laid it out exactly how it is described by the mainstream. And so I was like, okay, so that means that something could appear to disappear bottom up. Like, I read out a bunch of definitions. I said, so something could appear to disappear bottom up on a flat surface, yes or no? And he just went silent. He wouldn't respond. It's actually, it's kind of funny. I won't spoil any more.
Oh my God. I've been trying to get them to admit that for freaking 10 years.
He admitted it. He said, so first he said it's impossible to have bottom-up obstruction, and then about 10 minutes later he said you can have bottom-up obstruction on a flat Earth. He was forced into it. He couldn't go against it, because he would have,
How long till it's ready, dude?
Yeah,
he's been trying to avoid that one for years.
Yeah, I'm working on it right now. It should be ready in a couple hours. But
take your time. There's no pressure. We're chomping at the bit, but seriously, no pressure.
Yeah. I mean, all of the audios, like, I got that right now. You can just skip to the part in the live stream and listen to the whole thing anytime. I'm just putting together a better edit of it, but I've got a crisp, clear audio version on QOP's live stream, and we can just play it now if you want, or later or something.
I know. Well, I don't want to steal your thunder, man. Are you clipping it, or are you just gonna play it like?
Oh no, that's fine. We can just stick it on now. That's fine. That way I don't have to rush my production.
You didn't have to rush anyway, man. You be thinking about these guys. They're fucking on me. They get this out.
I just want to hear him get fucked. Come on.
All right.
I mean, I
I'll
have
bring it
to
up.
grit my teeth waiting for, listening to McToon's voice.
It's good. It would be better. Yeah, it's good to watch his expressions on his face.
Yeah, I bet.
It's kind of funny. But yeah, I'll just bring it up now. Here, I'll just check what time it's at. We can just seek forward on the bot, right?
Just remember, once you finish the video, once you've edited it and stuff like that, to let all of us know so that we can publicize it and let everybody know so we can watch it.
Awesome. I will. Yep.
So can I make an animated clip out of it? I'll make McToon a goblin. A goblin.
Lovely.
Was it really if you debated the other day? He fucking snuck off somewhere to that server. And
He ran away. He ran away.
That was good. That was good, man.
I didn't listen. I can't stand his voice, man. He's such a fake dude.
Yep.
I just get angry listening to him, man. Like, because I've talked to him a couple times, and he is intentionally deceptive, and I can't stand that. It's like somebody yeah, I'm gonna go in there, and they say it nice for some reason because they're saying it in a quiet, mild, meek tone of voice. That somehow they're not saying something bad because they said it quietly. No, dude, you're being completely disingenuous and basically stretching, manipulating, lying by omission in a nice voice. Like, just because you're not boisterous about it doesn't make it any better.
Yeah, it's like those annoying bitches who talk in baby voices and go, "No offense," and then say something atrocious, and you're like, you do realize just saying no offense in the beginning doesn't justify the rest of it, you know?
Yeah.
You're going to get triggered at what they're saying at one point.
I'm already triggered.
You're going to get triggered at one point. Yeah, but then it gets...
Am I in it? Do they mention me?
Yeah.
Oh, dude, really? Yeah, here we go.
It's all about you. Yeah.
Oh, fine, son. Then. Yeah.
Oh, hell yeah.
I'm just trying to find the exact point where it starts.
It made me so mad I had to pause it several times. So just be prepared.
Oh, dude, I love it. I love the hate boner, man.
Yeah, because I was listening to him. He debated QOP. Yeah, he debated QOP on QOP server, and I remember him saying one thing. Like, he was kind of walking over QOP because QOP's kind of new to FE. But he was saying how why are all flat earthers such pussies that they can't present a single long distance observation and then go over it, right, and put the math to the test, put the globe math to the test. Why are we all such pussies that we can't do that? Isn't that what we do?
Yeah, you told me about that. They said that. It's pretty so ridiculous, man. Just it's like when they say there's no evidence for a flat Earth. It's the most ridiculous thing. It's like they're gaslighting.
Yeah, they have to be, right?
That's why I just ask them. I go, well, why do people used to believe it in the past? And what they'll say is, well, they were stupid. Yeah, but they still believed it based upon the evidence they had. It looked flat. That was evidence, right? That's what they based. So there is evidence. You might not agree that evidence proves the Earth is flat, but it still is a piece of evidence regardless.
All right, I got it ready. What's the command for the music bot in this one? / or? / works.
Yeah, it's /.
All right, and then I'll just start it, and then I'll seek it to 1 hour 32. A second. Work.
Sorry.
I concede. You win. You flat earthers are superior to my humble globe zealots.
You guys hear that?
Well, no, I just
Probably-
freezing temperatures.
He probably has him muted. That might be the logical thing to do in those
He's a
situations.
whore. That's why. Well, I have
time lapses, and so like the first time lapse is, an hour or so, and the second time lapse is 2 hours. So each time lapse gets longer time embedded in the time lapse. So all right, here we go.
Oh, so you can see the trails, but you can also see them moving.
Yeah. All right. I have it's on my Dropbox, but I have Dropbox off while I'm streaming. So I'm sorry, I can't pull it up right now.
Yeah. If I could jump in for a second, I don't mean to change the topic, but if we could maybe go back to the you wanted some flat earthers to present some observations that are credible for flat Earth.
Yes, that'd be good.
All right, I got one to present. Can you hear me properly? I got to speak quietly because it's 5 a.m. here in Poland.
Yeah.
All right, so I'll be quick. I'll grab the observation and I'll just present it. I'll present it in the side chat so it doesn't get lost in the text chat. If that's okay.
Okay.
All right, just give me 1 second. I'll present exactly what I was presenting in this debate in the live stream voice text. Near Boston.
Dude, you're the best. Thanks.
All right, so I'm going to post the first image. All right, so this was taken from 15-foot observer height. Okay, this is a Nikon P1000. In the side chat.
Oh, there it is. Okay. All right.
All right, cool. So we've got 15-foot observer height. We've got a Nikon P1000 with that's been infrared converted. Okay, and we have a. All right, just 1 second. I just paused it for a second so I can bring up my Discord on a different browser so I can just copy paste everything straight in.
Okay, just DJ, just to correct you, it's not an infrared converted P1000. It's a full spectrum P1000 with an infrared filter.
Ah, okay.
Now, an infrared converted would mean like they put the filter right on the freaking sensor. You can do that. You can get the film. So you take the infrared cut filter off. So the sensor has a film, an infrared cut filter film. They peel it off. That makes it full spectrum. They can convert it by taking an infrared filter and applying it right to the sensor, right? And then you have an infrared converted camera. This is a full spectrum camera. They just took the film off. I changed it into an infrared camera by putting a filter on a lens filter, instead of a sensor filter. There's no difference. I'm just saying.
Gotcha. I'll remember that for next time. All right. Just a second.
The good thing about it is that you have flexibility because I can buy any number of infrared filters, right? 750, 830, or 840 or something, or 850 and 930, and they make even 1100 ones.
If you do the internal conversion, can you still use it normally, or is it just infrared completely?
I think it's just stuck on infrared.
Oh, that's ridiculous. Yeah, I'd definitely not do that.
And with the filter, you could cut like all the UV because the multi-spectrum it'll pick up the UV unless you cut it out. So you could get a UV and infrared filter that would turn it back to a normal camera, basically.
Well, Toon says infrared doesn't mitigate refraction.
That's their new thing, man. It has no effect on it.
All right, ready? I'll hit play again. Go. 15-foot observer height, like I said, and we have a ship track in the distance. Okay, we can see the distance markation on Google Earth. And then we can see the red line, right? That's where the geometric horizon distance would be. Globe.
Okay.
Now, all right. So now, right. Next up, we have the ship. All right. So this is the screenshot from the ship tracking. All right. Just a moment. Here it is. Okay. So we have the coordinates here. Scarlet Isabella, and if you have a look, the coordinates match up on the Google screenshot.
Okay.
Okay. All right. Next up, we have a buoy that's basically between the ship and the observer. Okay, and the time that the observation was taken was around 3 p.m. And we have a reading from the buoy of the water temperature and the air temperature at 3 p.m. So I'll just post the data from that in the side chat. 1 second. All right, so here we go. There's that. And the temperatures. 1 second. It's the next one. All right, so we have air temperature 45 degrees, and we have the water temperature 45.9. Pretty close, right? If anything, it would work against flat Earth, right? We could have a slight bit of upward refraction, maybe. Okay, so now.
Well, all right. How far up is the air temperature at the top of the buoy?
Yeah, so you can see a picture of. Well, it's reading the air temperature. Yeah, it's probably not too far up above. Yeah, I'm not sure how tall the buoy is. Could look up the height of the buoy, but.
Okay.
Yeah, it's the reading that would go onto the the weather report, that kind of thing for that particular area. Okay, so next up, all right, so here's just a picture of the clock. So a picture of the clock was taken at the location just to show you that the observation was done at the time that buoy reading was taken. Right, so the guy that did the observation, he specifically, like you did with your sunset, right? He waited to find a day that was going to have pretty much uniform water and air temperature, and he's using the infrared as well, which helps a bit. All right, cool. Okay, next up, just a picture of the camera setup. Sorry, I'm a bit unorganized with this, but in just a second. All right, here's the camera setup. All right, so now I'll grab this is just a GIF of the observation. There's a ton more footage than this, but this will be helpful just for the presentation. All right, so we got did that post? Oh, 1 second. All right, it's just uploading now. All right, so this is the observation through the infrared from that camera. And what we'll see the ship that's 10.6 miles out. Okay, and you can see the whitewash on the bottom of the ship. The ship's 10.6 miles away. And we have the geometric horizon distance should be at about 4.6 miles. Now we've pretty much mitigated the refraction issue as much as possible here. If anything, the refraction works slightly against FE.
All right. What was the the distance to the ship?
10.6 miles. Right. So it should be about 22 foot hidden, something like 2 stories, 2-story building, a bit more than that.
Yeah, I wouldn't.
Was the buoy also at 10 miles?
The buoy's in between the two. So if you scroll back up to the picture of the buoy, okay, with the data of the buoy, you can see the buoy just there. It's basically in between the ship. You can actually see it when he zooms in.
Who was the original source? Was this a YouTube video, or where'd you get
No. This was my friend. You guys probably know him, Indio.
Oh yeah, I know Indio.
Yeah. Oh, sup, Jesse. Good to see you, man.
Good to see you.
All right. So yeah, I can post Indio's video of it. 1 second. So this is his video. It might have a bit more footage than I showed. If you contact Indio, he can show you a ton more footage of it and give you a bunch more details. But here's his video about it. All right. So with that, water to air temperature, like to have this work on a globe, you would have to have a refraction coefficient of something like 0.8, right? Like a huge amount of extreme refraction. We don't have the conditions. We don't have the meteorological conditions.
I get
present.
I got about 0.3 as a necessary refractive condition for that.
All right, so I'll just pop in a screenshot from Walter Bisland's. A second.
According to Andrew Thomas Young, it takes about 0.13 degrees centigrade per vertical meter to have circulating rays. In other words, the ray of light matches Earth curve. So, and it wouldn't even need to be that much, since the observer was not at they were a few feet above. So it wouldn't.
Well, the observer's at 15 feet, right? And we have what would cause upward refraction. Okay, so it would work in reverse to that. So we're not going to get.
But now, why did you put hidden zero?
Hidden zero.
Yeah, that's why it's got hidden zero.
Oh, that's because yeah. Okay, cool. So what I did with this one was I slid the refraction slider up until the boat had 0 hidden height. Okay, and that would have so to have 0 hidden height on the boat, which we see in the observation, you would have to have a refraction coefficient of 0.81. I mean, even if we put in
I'm not seeing 0.
Okay, we can see the whitewash from the boat. Yeah, we can see the whitewash from the boat at the bottom very clearly. And to have 0 hidden height, basically you would have to have a refraction coefficient of 0.
But I'm saying I don't see that it's 0 or that everything is seen.
What do you mean? There's nothing obstructed, right? It would be obstructed behind the horizon. The horizon should be at 4.6 miles. Okay, we don't see a horizon in front of the ship that's blocking anything because we see the whitewash from the ship. And also, the horizon should be 4.6 miles, the geometric horizon.
So what would be the hidden height, assuming
22 foot, assuming no refraction, with standard refraction, which shouldn't be possible in this case because we have what would cause upward refraction. So obviously we're not going to have 16%. We're not going to have that downward refraction. But so even with standard refraction, it would still be the bottom of the ship would still be hidden by a certain amount, and the geometric horizon wouldn't be much further away. Okay, it would be 14% further away.
How high was the observer? The camera?
15 foot.
In the boat?
Yeah, with standard refraction at 16 feet hidden. How high up on the boat does the whitewash go?
It doesn't look very high in the observation. I don't know, have another look at it again. I mean, it's probably not something you would be able to measure exactly.
Do you have a picture of the boat from fairly close that you can compare the two?
Yeah, I think so. Again.
So what we could do is, if we know the boat and how tall it is, we know how many degrees per pixel in the vertical, and so we actually could tell how high the whitewash actually is appearing.
Right. So this is a horizon test as well, by the way. This is a geometric horizon test. Okay, so you would have to say that, like, where are you seeing the horizon? You're not seeing the horizon in front of the boat because you're seeing the whitewash. The amount of refraction you have to have a horizon at 10 miles, okay, that would be 0.81 refractive index. We don't have the meteorological conditions present to have that.
Well, you have a very limited snapshot of the meteorological conditions. Just to be clear, to be fair, you have one point of temperature above the surface.
Yeah, but it's in between point A and point B.
Elevation.
Well, it's in between.
But you don't know. You don't have a vertical temperature reading, so you don't know. Is it colder another foot up? Is it warmer another foot up? You don't know that. You don't know even the height of the air temperature reading. So you don't know the meteorological conditions, so you can't say definitively that there is zero refraction happening.
Okay, well, what we do know is that we have warmer warmer water than the air temperature. Okay, that would cause upward refraction. Okay, this is better than any observation from any globe earther that I've ever seen. We literally have a buoy that's giving a reading right at the time of the observation between point A and point B. It's not like this is a decent quality observation. Also, we're using infrared as well.
Right? I don't care. Infrared is nice because
he did not present measurements of Earth curve.
Listen, buddy, you said you just checked that today, the parallax thing, though. Can we maybe bring you back to a more fundamental question, like, what we were speaking about, the surface of the Earth, right? The surface of it. If you were standing on a globe or a sphere, you're standing on it, right? That's what you believe. You're standing on a sphere. Is that correct?
That's right.
Yeah. There will be a drop over distance from your position, away from you, in all directions, right? Because it's a sphere. It's dropping away from you, the surface.
How is it dropping away from me, the surface? What do you mean?
Change rate of slope, it will be... it will be changing the altitude, the ground.
Yeah, for example.
It will be dropping away from you, from your line of sight, the observer.
Yeah, the horizon, yeah, the horizon. Okay.
But that's the thing, though, that the sphere that you think that you're standing on, it will require a specific rate drop, and that can be tested. It has been tested to check if it's there. Like people, you can go outside, you can go to a body of water, you can do either measurements or long distance observation. There's even laser tests that have been used. And you can come to the conclusion that there is no curvature because there is no drop over the distance that will conform to the drop of the sphere, the globe, the globe Earth that they claim. It's not dropping, it's not curving. So how can it be a sphere if it's not curving, though? You see? You see the issue there?
Not really, because it's a giant sphere.
So this like phenomenon is not that like
So it's a giant sphere, so it's
sudden.
not curving. That's what you're saying.
I'm saying that it's like slowly curving.
Okay, it's curving, right? So it is curving. Exactly what I told you. So you're agreeing with me. It has to be curving, but it's
Yeah,
not
it's
curving. You get
curving.
that?
No, I don't get that. But it is curving on a
Oh, it
very
is
long
curving.
distance.
You're saying it is curving.
Yeah. So the argument
Do you
is
have the
that
method? Do you know who measured that curvature? Do you have that available? You said it's curving, so you probably have like some type of method that was used to determine that, right? Like it's curving.
like
That's what you're saying.
my own logic. That's my method. So who measured this? You know
Your
this?
own logic. Can you describe that? Your own logic. What was the logic that you followed to come to the conclusion that the Earth is curving? What was that?
Okay. Can you answer me this question? Who measured this curvature of Earth?
No one has measured the curvature of the Earth because it doesn't exist.
Okay. That's if that's the answer, then.
Yeah, but that's what you're saying. No one has done it. No one
Okay,
has measured the curvature, but it has to be.
Let's.
You're saying it has to be there, even though nobody has discovered it or measured it or seen it or showed it. You're saying it's still there, even though
I have
nobody
one more question.
has measured it.
What about gravity? What about gravity? How do you respond to this?
Bro, come to a bring. Remember, you mentioned logic. Just try to come to a logical conclusion about this one, because if you can't figure out the ground that you're standing on, or the waters across the surface of the Earth, how are you gonna figure out gravity, dude?
I don't know. So let's maybe find out this one.
Yeah, let's find out. Yeah, so let's do a long distance observation, right? We can look at many examples in the chat. I'm gonna jump in the text. Maybe people, if you look in the chat though, there might be people posting things now or before our conversation. There's probably people posting different observations from the surface of the Earth, and by you just looking at this stuff, you can safely come to a conclusion that there is no curvature, the no curve that is attached to that globe that you're thinking, the globe Earth, 3,959 miles in radius. Because remember, it has a specific variation, specific variables, and that stuff can be tested for, and it has been tested for, and the test shows that it's not there. So it's not that, because if it was that, if it was a sphere, that the curvature will be there, and we will be able to test for it, but it's not there after the test. Let me check the text real quick, because I got a
I
few
don't know
things.
what you're talking about, but can we talk about something I know what we're talking about?
You don't remember the curve? You said it's a sphere. The sphere is curving.
But okay, bro, wait. So there are some like proofs about things that are like I want to say non like. Fuck, I forgot the word, but they're like non-direct proofs. So, for example, like human is a human because it's like an animal because it has, I don't know, evolution, or it is born.
Yeah, now
like
you're gonna go claim stacking. Now you're saying about, bro.
No, I'm not claim stacking.
You are now you're saying we have evolution even though you don't have that. You don't know what that is. You don't know what that word means, and now you're gonna use it like it means something. To the conversation that we were having before. You wanna move away from the curvature.
No, bro, but I didn't.
Something.
Wait, you're a fucking idiot from what I think right now, because I haven't done anything, and you're like preventing me from doing like haven't done anything, bro. So shut up and let me finish. So
you just said let's move away from the measurements of the curvature, the thing in question, the elephant in the room, and let's talk about something else. And you said yourself, I'm indirect. So let's go away from the direct evidence and go to something else. And I'm trying to keep you on your feet, down to the earth. You go into something else, la la land, imaginary, fantasy. and I'm trying to stop you from doing that.
No,
If you want to do it, we can try.
Shit. Okay, let's try because okay, so the gravity. So why is
What's
there
that?
gravity?
Tell me. Okay, gravity. What is that? Tell me. What is it?
So this is the thing that Earth has some mass, like huge mass, and therefore it produces gravity that pulls object into the Earth, yeah, with its weight.
Okay,
is
this like words that you read somewhere, or this is like a demonstration, something that can be tested and shown and tested for? Is this something like that you have showing?
It can be easily tested. So
hey, James,
what is it? Oh, go ahead,
Jim.
DJ. My bad.
Oh, I was just gonna say, okay, so it's pulling everything towards the center of the globe, so that would mean the water should be curving. Jemsy already debunked what your gravity claim, because if gravity was real, then the water would have to be curving at a certain rate. So Jemsy already debunked your.
You just told me that you don't believe. You just told me that gravity is not real.
No, it's you that believes in gravity.
So what you've got? Gravity.
Could go, DJ.
Well, just speak one at a time. If you have gravity, that means that the water has to be curving. Jemsy just showed you that the water's not curving over distance. If you had gravity, it would have to be curving over distance, but it's not. So.
Yeah, but I don't know. Is the water curving? Yeah, I mean, it is curving. It is curving, like slightly.
Actually, no, it's not.
Well, every time we go and test it, this has been done thousands of times. There's a zero curvature. Bless you.
Just mute yourself, brother. Being toasty.
Why do objects?
It was two sneezes. It was two sneezes, man. It's fine.
Okay, why do objects simply fall on Earth and they fall? Yeah.
So an object gets dropped, it goes down. So therefore, you've assumed we live on a sphere because of this action, this show. Here we go. I've got a pen. I let it go. It went down. So therefore, my table is curved. I hope not, because I like things to stay on my table.
Yeah, that doesn't follow logically, bro. Like you're saying, okay, I see the water droplet, the pen dropping, like exactly the example that he gave you. I pick up the pen, I let it go, it goes to the floor, therefore I'm standing on a sphere? How does that logically follow?
That Earth has certain mass and certain mass, so therefore objects fall on Earth with some like speed, and the speed is equal to their mass times this g. Yeah, this what is this? 10 meters per second square. Yeah, like this. So
except that not everything drops at that rate, because helium goes up, it doesn't drop that way. We have hot air, we have many things that don't drop at that rate. That rate, that's only an agree upon. That's a convention. That's people said, we agree that a lot of things drop at this rate. So we're just gonna say that everything does. But that's just people saying that. That's not. You cannot demonstrate that everything drops at that rate. That's not reality.
I don't know, like you were telling me about elements, and they behave different way, the elements, than like normal objects.
Yeah, and we know the behavior of water, and we know that water doesn't attach itself to the outside of spinning spheres. We know the behavior of that. We know that water lays horizontal on the surface. We know that. It can be demonstrated.
Okay,
it can be measured that the water is not curving to the rate of the globe. So the globe is just falling flat, falling apart.
Okay, so let's assume that the Earth is flat. So why is it like this? When you go to the end of the flat Earth, why don't you fall down? Or when is the end of this?
When you go to so you just made up an imaginary place in your mind, and you think that imaginary thing doesn't work, and you are trying to ask me about it.
No, that is a model that is like flat Earth in my mind. So
A model in your mind, yeah, exactly what I said. Something that you made up in your mind that doesn't work.
No, but
you're just telling me that whatever you're imagining doesn't work for you. So now you're trying to tell me to explain how it works for you.
No. Yeah. Okay. So can you explain me your
Has anybody
model?
in here?
Shut
Has
up.
anybody in here tell you about the edge of the end of the world? Anybody in here made that claim that you're trying to push that to someone
Okay,
in
there
here?
is geometrical, I don't know, object like a circle, and so I can see the borders of the circle on the paper, on a piece of paper.
What have you ever thought about this? What if the ends of the world are unknown? What is that? That's an unknown that you don't know. I don't know.
Okay,
Have you
what
ever
about
considered that?
So can you answer me this one question right now? Is it possible when people discover these unknown ends of the world, do they fall down?
Who's that? Who discovered the ends of the world? Tell me. Go ahead. Tell me.
You.
Me? No, I had no. That's I haven't done that.
Okay, I don't know. Ferdinand Magellan.
Brother, I'll answer your question because I can't bear this 1 second longer. Nobody thinks the edge of the world, there's the edge of the world. No one thinks the earth is an object that you can hold in your hand if you were a giant. Okay? And fall down, that doesn't even make sense. Why would it fall? Where would it fall to?
Like outer space, vacuum.
It would fall to space. So I guess we could just push things off the edge to go to space. Dude, wasting our time with rockets, right?
Okay, but you're like contradicting yourself because he told that we haven't discovered the edges according to him.
Indio, he thinks that in the internet that people label flat Earth, that's us.
Yeah, we don't think the Earth is a disc in space floating around. Does that help?
Can you explain me what this is according to?
Earth is not in outer space. It's not inside of something. It's just the Earth, and that's all there is. Above the Earth, we see stars, sun, and moon, and all the celestial objects.
Phenomena.
Yeah, phenomenon, whatever you want to call them. There is no outside the Earth.
It's like a simulation.
Just to give you it's like saying, hey, what's outside the universe? Right? Doesn't even make sense to even ask that question. There is no outside. It's all there is. The Earth isn't the sun. It's not a planet. It's not a moon. It's not a ball. Did you understand all that, Hal? Friend?
No, because this is like very abstract from what I think.
No. I mean, so they say that in modern cosmology, the universe is flat. Okay, this is what they say, that the universe itself is flat. Where's the edge? Can I fall off? Can I go outside of it?
Wait, we don't. Modern cosmology doesn't say that. It says the universe.
Yes, they
do.
It
does.
They say it's an asymptotically flat space-time.
That's news to me.
Okay, Google it. Flat universe.
No, I'll trust you on that. Honestly, I'll just trust you.
No, don't trust him. Don't trust him.
Well, is he a little liar? Is he a liar or something?
No, I tell the truth, but you guys still, in your head, you'll still think that the universe is not flat. Like, in their cosmology.
Oh my god, if I'm saying I trust you, I'll trust you, bro, please. Just trust me that I trust you.
Okay. Well, all I'm saying is
I don't know what you're saying.
I don't think the universe is flat. Unless you count just the Earth as the universe. So we know the Earth is flat from measuring it to be that way. And I heard you mention gravity, like why things fall. No one knows why things fall. No experiment can be done to determine why things fall. I mean, if you know the experiment, just tell us. I'm all ears.
I think that's the best answer for that, because he sounds fairly new, but that's straight to the point. No one knows. That's the truth.
I kind of want to bring up the whole thing of what was general relativity, that like you can't devise an experiment to tell the difference between acceleration and gravitation. I just kind of want to bring that up because I feel like it's related. Like,
yeah, there are experiments. This is actually something. It's just, I don't mean to just be a freaking contrarian, but the gravity acceleration equivalence has never been actually proven, and there is actually a physicist working on demonstrating that. Does have some data that the acceleration, the inertial mass and the gravitational mass are not actually the same thing. And he's been doing these experiments by dropping different elements in his, I guess you would call it theory, hypothesis is the number of neutrons within the nucleus of an atom determine its inertial mass. The guy's name is Sky Darnos. He's a physicist. You can check out his YouTube channel and watch all his experiments. I'm just saying.
Mm-hmm.
But within the framework of relativity, Einstein said yes, inertial mass and gravitational mass are equivalent, but that's never actually been proven to be true. But the difference would be very small anyway. So.
Oh yeah, what do you guys think of the physicists then who sold these ideas? Like, do you think they were just a big bot with the government or something?
No, they're just wrong.
Okay.
Oh. Yeah, you heard me wrong, right?
No. So I'm just trying to figure out like.
You guys can't conceive of it. You guys are like, you guys think they must be lying.
No, not like that. I'm just trying to figure out like what, like, okay, so but you do believe that it's been.
The physicists that said the Earth is a spinning sphere in the vacuum of space, they sound pretty sure about it, but they're just wrong.
Okay, so
what about other planets?
You think that they thought they were telling the truth? You think that they think they had it figured out, but were wrong.
They believe what they're saying.
Okay, and then the government took that idea and perpetrated that as a lie.
Hold on a second, just one second. I've talked to physicists. Actually, I've debated person with a PhD in mathematical physics in this server. Okay, twice, 2 different ones. Okay, and when it comes down to it, when we ask them, they don't actually know the Earth is a globe. They just believe it. They've never done any experiments. They've never seen any experiments done. They've never done any measurements. They've never done anything. They just learned it when they were a kid and just continue to believe it.
Okay, and so the government took the mistake of the scientists that the Earth is a globe. Oh, sorry, because that.
What do you mean by
like the city, like the lady?
What do I mean by the government? Like
the lady at the tax office?
Like NASA and stuff.
Oh, like NASA.
Because NASA is like affiliated with them.
Yeah. You guys are in trouble with the NASA thing. So a couple months ago, Donald Trump signed an executive order turning NASA into a spy agency. So
yeah, I know. Yeah. So my question was like, do you guys believe that the government took the mistake of the scientists that the Earth is a globe and continued to perpetrate it as a lie for some gain?
It's not a lie if it's a mistake.
Yeah. Yeah.
You know what a lie is, right? That lie is.
Yeah. No, I'm confused because I thought I used correctly. Yeah, they're lying that the Earth is a globe when it's flat. What you believe?
No, I don't believe they're lying. I believe they're wrong, that they're mistaken, that they believe what they're saying, which means they're not lying. There's a difference between being lying means intentional.
Yeah. Okay. I talked to a guy before, and he was like, "Yeah, I believe the government is lying about it." So I'm just
Look, the government lies about a lot of shit. So I mean, their official policy is to lie.
Very true. But can you tell me something?
Policy. They actually argued that in front of the Supreme Court, federal government. The official policy of the United States government is not to tell the public the truth.
Hey, can you tell me? What about other planets?
Case was
Because I don't
Akaba
know.
versus Ashcroft. In case you want to know what case it was argued by Ted Olson, Solicitor General of the United States.
Can you tell me about other planets? Is
Just
there
wait a
anything
minute. You're
like
gonna get a reply to the
planet?
other
I
planets.
covered,
Okay.
brother. I covered the other planet thing. Earth isn't a planet, so there's no other planet. It's not other.
Yeah, the issue that you're having though is that you're in your premise. You're saying you think the Earth is already a planet. What about the other planets? And that's wrong. That's a wrong premise. It's a false premise because the Earth is not a planet. And when you look up to the sky and see the luminaries, and some of those we call them planets, the Earth is those things are nothing like the Earth, and the Earth is nothing like those things. So the Earth is not one of those things.
What about some like like photos like we have? Is it Photoshop from other planets?
Well, no. The problem with those is that there's no way to test them. And they're not even consistent amongst each other, right? So you can look at any random so-called image of the Earth, and they don't look like any other image of the Earth. And number two, you can't even tell. Because you've never seen the Earth from that point of view, there's no even way to even tell if that's what the Earth looks like. I mean, for all you know, the Earth is a freaking giant egg. You'd have no way to know if, their picture of a ball versus an egg. You can't tell. There's no way to evaluate them. And we know they have to be fake. You know how we know that? You know how we know that any image depicting the Earth as a ball is fake? Are you curious how we know?
It's composite images.
No, we know they're fake because they depict something that doesn't exist. And we know it doesn't exist because in those images claims to be the oceans of the world. And we can go out to those oceans and measure the surface and demonstrate that those oceans don't curve on their surface. And if they don't curve on their surface, the image must be fake. Just like if I went to Times Square, right? If they showed, hey, here's a picture. It's Times Square. There's a big pink house in the middle of it. And I go there and there's no pink house.
Yeah,
it doesn't matter how many pictures of the pink house in Times Square there are. I know that those images are fake because there's no house there. Okay.
Yeah, the images will be a misrepresentation of the Earth. So the Earth is a sphere and the oceans curving around the sphere. And when we go to the oceans are not doing that. The images will be a misrepresentation of reality.
There you go.
Bro, the images can be fake.
See what we do, we go out to reality and check what they tell us to be true. Okay, they say, hey, the Earth is a ball. It has a radius of 3,959 miles. The rate of curvature should be roughly 8 inches per mile squared. If in 10 miles, the Earth should drop down 66 feet. So we can go out into the world and test all these things, right? To see if what they're saying actually is out there in the physical and natural world. And when we go out and test it, and just like you could go out and test it, you're going to find what they're saying can't possibly be true because it's really not out there in the world. It's only on television or on a screen or in a book on it.
Can you maybe tell
when you
me?
turn off the screen, when you turn off the TV where you saw the globe and you go outside, you check the surface of the Earth, that's nothing like what you saw on the TV. Go ahead, Tassie.
Okay. Can you tell me? So why is it like this? That official narrative is that the Earth is round, it's in space, etc. Why?
At this point, first of all, we'd have to read men's minds, but it's at this point it's a Western tradition. It's like being born in a Christian country and then you're Christian. Right. So you're born in the West and, they tell everybody the Earth's a globe, but everybody just passes it on. Like your parents, right? They probably told you the Earth is a globe. Do you think they know? Do you think your parents have any knowledge of the shape of the Earth?
No.
No, they know some basic
Yeah, they were told, right?
Stars,
they were told by their parents, and their parents were told by their parents, and their parents. You see what I'm saying? It's just like a tradition passed on. None of these people actually know, and that's what I was trying to tell you guys earlier. I've talked to the people, the scientists that you think know, and they don't know because I've asked them. I've talked to them. I've talked to people that are satellite engineers and pilots and surveyors and physicists, cosmologists, astrophysicists. We've talked to all these people over the last 10 years, and they don't have any information that's different than you.
What about this, like comets or like meteors? Do they? I mean, there are some stones that fall from above to Earth, yeah.
Yeah, there's also cats and dogs and fish and animals that fall from the sky too. So what?
There's also fish that falls from the sky, though. You know that?
No. What do you mean?
Never heard of the reign of animals? It's been going this is documented for 2,000 years. There's sometimes
No,
there's rain animals out of the sky.
What do you mean? Nothing like this exists.
Okay.
Anyways, real quick about the rocks in the sky, there is a difference between the phenomena that we see, like we call sporadic meteors or meteors, and then there is the cartoon version of that. Because remember, if you're standing on the ground and you look up to the sky and you see a phenomena, and let's say a rock falls from the sky, and then you go pick it up, right? Okay, cool.
Yep.
That doesn't logically follow that the Earth is a globe, though, because then you go then you have the question, where did this rock came from? How did it happen? You're gonna be asking those questions, and then you're gonna have one of those guys showing you a cartoon, right? And then you're gonna look at the cartoon, and the cartoon is gonna show you the misrepresentation of the curving Earth, and that rock came from outer space. But that's just an explanation. They don't actually know that. That's just a misrepresentation of what happened. Go ahead.
Okay, so is the theory that we are like alien zoo? Is it good one?
Eh?
Like humans are alien zoo, yeah? We are like animals of the
that's
alien.
a misrepresentation of the use of the word alien, because alien means foreigner, someone from other land. And alien, you can also use it in fiction. So whenever you speak about outer space, aliens, that's fiction. If you're speaking about people from other lands or coming from other places, sure, you can use the word alien. But what you're thinking about, the aliens in Star Wars that look like frogs, speaking different languages, no, that's just cartoons and fantasy.
Yeah, there's no as far as other land, there's no land in the sky for people from other lands to come from.
That we know of. That we know of.
Have you noticed? Yeah, I just want to bring up. Have you noticed that we just keep talking about this subject, and your mind keeps going back to outer space over and over and over again? Even though we're talking about the Earth, you keep thinking about like what's up in the sky instead of what's under your feet.
Yes.
And then you're wondering why is it that you even think this way?
Because
imagine we were talking about your house, right? And you just kept talking about your neighbor's house. I said, dude, but what's your house made out of? And you're like, man, my neighbor's house has got frickin' vinyl siding. And I'm like, but what about your windows in your house? And you said, well, my neighbor has gutters on. Like, this is what you're doing over and over again. It's like a mental. Like, bro, listen. I'm not like giving you shit. It's like, but we observe this to happen all the time. Is that when we talk about this topic, we end up talking about everything but the Earth and talk about everything else in the world.
Because this claim is like, honestly, because this claim is like, I've never even heard anything like this, so that's why.
Well, everybody
he sounds really new to the topic, though. Go ahead.
Yeah, I am really new to the topic.
Yeah, so brother, now let's imagine nobody ever told you that the Earth was a giant ball. Would you have figured it out on your own without being told?
No, I wouldn't, probably.
And every single person I've ever asked has said that same thing. They said, I never would have figured it out. Okay, that means it's not obvious that the Earth is a ball. It's not obvious. It's not obvious from your daily experience. If you go up a mountain, go in an airplane, go to the ocean. Anywhere you go, it's not obvious at all that the Earth would be a ball. It's like a mental construct that humanity is like constructed in our collective mind.
Oh, shoot.
But there's no evidence for it in the physical world. That's the problem. That really is the issue. And that's a problem, right? Because science is supposed to be empirical, right? It's supposed to be based upon observation of the natural world, not conceptualizations of the natural world. So if science is empirical and they say the Earth is a globe and it's supposed to curve, the water's supposed to curve all over the world, and the most of the world is water, I should be able to go to a large body of water, and measure this curvature in the natural world. But no matter what distances we try to measure it, it's not there. And we're talking, like, for instance, the world's furthest photograph is 425 kilometers from the French Alps to the French Pyrenees. Okay, let's just see something like, I'll top of my head, 4 miles of drop. That's how much the surface of the Earth is supposed to curve down from that person's eye level, something like 4 miles. Okay, so this drop, there's radio transmissions of 10,000 miles. There's LoRa chirp radio, which is like a low power technology for communication of 800 miles. There's all sorts of evidence that the Earth is flat because the limitations of a curving surface just don't seem to exist in reality.
The limitations of a curving what?
Yeah, a limitation of a curving surface. So if we're like far apart.
Okay, yeah, I understand.
Like there's supposed to be a bulge of Earth between us if we're farther apart, right? Because the curvature of the Earth. We ever heard like ships go over the horizon and the Earth is supposed to be blocking the view to the bottom of the boat? Have you ever heard that?
No, can you repeat, because I didn't get anything what you.
Yeah. So if a ship sails away from you, this is what they say: if a ship sails away from you, it'll disappear bottom first, then the mast, right, in that order as it sails away. And they say that this is due to the curve of the Earth. The ship is going around the curve of the Earth.
Mm-hmm.
Yeah, this is what they say. This is what I'm talking about.
Yeah, that's what I also knew. Yeah, that's what I know. Like when you have the sun, the sun is setting. Yeah. So this also considered the proof that it goes that disappears in the horizon. So this is where you cannot see no more. Like
yeah. The sun goes over the horizon and goes underneath your feet. So when it's midnight and someone says, "Hey, point to the sun," you point down, right? So where does the sun point down? That's so funny. I mean, yeah. So this is the idea, but when this is actually tested, because just watching the sun do something or just watching a boat, that's one thing. And maybe there's optical phenomenon happening due to the meteorological conditions that make it look a certain way. But can we actually test it from this subjective interpretation to find something objective and actually measure the surface of the Earth to actually see if it is actually curving? Okay. And all these tests show that it's not, all these measurements. So one thing you can do is, like, you can take a laser, you can shine it across a body of water, and you can measure its height, how high it is above the water along its length, to see if that height above the water increases, right? So let's say I start at 2 meters above the water, shine a laser 40 kilometers, and then go to the other end of the 40 kilometers and go and measure the laser height above the water. Well, that laser should be 127 meters in the air.
Yeah.
Okay, but when these tests have been done, it's the same height above the water. It's not way up in the air.
Okay, so did they like try to, because their mathematical proportion can be counted, yeah? So you like cover this distance you divide this. What was this kilometers? The
40
distance.
kilometers.
40. So maybe that's not enough. 40 kilometers because.
Well, I just gave you what the globe says. I gave you so the laser should be 127 meters in the air. That's what the globe predicts.
Ah, okay.
Okay, but they measured the meter they measured the laser 1.5 meters above the surface.
1.5, and it was supposed to be
127. 127.
So it went up a bit. So it's
that's
like
2 orders of magnitude. That's not a bit.
That's not a bit. You're saying.
That's the difference between having a penny in your bank account and $1.
It's like a skyscraper building, like a giant skyscraper building.
Yeah, 44-story building. That's its equivalent of a 44-story building versus a 4-foot man.
Okay, yeah, I understand. Okay, but I'm gonna honestly, I'm gonna count this on on a piece of paper in a moment because I'm curious. But can you send me the link to this, like laser?
Yeah,
or
sure thing.
Okay.
Just to give you a little background, I'll give you a link. It's a PDF. It's got all the measurement results. It was done in Lake IJsselmeer in the Netherlands, which is like a saltwater lake that they made out there. And they did a series of tests. And then they went back and did some of the tests again to replicate it, to make sure. And they had like meteorological stations. And it was a very thorough test. This was actually like the 4th or 5th time they did this type of laser test, because every time they did one, people would complain that you forgot this or forgot that. So this was like a culmination of like 5 years of attempts, basically. So I'll post it in the side chat without further ado.
Okay. So maybe like one more question. So like, well, how is it like with North Pole and South Pole? Why does this magnetism exist on Earth? Hello?
Oh yeah, because compasses only work because of magnetism. So how do you guys explain that? It's a good question.
So magnetism's the shape of the ground now.
Yeah. Okay. So, God, I'm gonna answer this very quickly because I'm looking for that thing. Anyway, so compasses don't point towards the North and South Pole. That's a myth. Compasses actually just align with the magnetic field. Okay, so whatever the field lines, whatever direction they point in, the compass aligns with them. It's called magnetic declination. So magnetic declination in some places is 90 degrees off of what it should be, such as in the South Pacific. So if you were in the South Pacific and you were following your compass north, you'd actually be traveling east.
Okay, seriously?
Yeah, seriously. On all like navigation maps. In fact, I was looking at a U.S. A Coast Guard chart today, and I didn't know this. With the magnetic declination where I live is something like 15 degrees. So that means like your compass will point 15 degrees different from what you would call true north in Boston Harbor.
That's explained in my question is like, how do you guys explain that? Because we explain like all of that through the globe model of the central core being like kind of molten iron, and
Yeah,
that
explanation's horseshit though. Have you thought about it for 3 seconds about that explanation?
I mean, I was taught in class basically like charges. Man,
well, let me say, like,
I can just say crap like charges. Sounds kind of BS.
Did they teach you about the Curie? Did they teach you about the Curie temperature when they taught you about that?
What's the Curie temperature?
The Curie temperature is the temperature at which metal loses magnetism.
Not all. Wait, sorry.
Metal loses iron and nickel, and any metal loses magnetism at a certain temperature because they can't align, right? Because the thermal motion is more random than its disorder from thermal motion is greater than the order of the magnetism, right? So it can't stay in an ordered state to actually create a magnetic field. Yeah, this is called the Curie temperature. It's like 400 degrees Fahrenheit for iron.
So you really don't believe that there is this
the Curie temperature.
metal core?
No. Why should I?
The metal core is only an idea that you got it from a cartoon, bro, from a depiction. You saw it in a book, it was depicted by someone, and they said this is how it is, but they don't know that. They just made, it's just a baseless idea. Nobody has verified that.
They put a lot of work in like proving this.
How did they prove
a lot of work?
I want to know how they proved it. How did they prove that there's a molten iron core? Did they take a sample?
Sick. And I thought I'd be able to drop astronomy. Now we need to take it to ask these questions.
Well, astronomy is a pseudoscience.
Okay, well, this is also. I mean, pseudoscience. This kind of.
Well, I mean, can you give us an astronomy experiment?
That debunks your experiments.
Any astronomy experiment of any type, anytime, anywhere.
I mean, an astronomy experiment. I mean, then sure.
You can't do an experiment, and you're not doing science, right? So we need an astronomy experiment.
I mean, you could just let's say you're gonna map the rotation of the Earth by looking at a constellation and finding the constellation across different times.
That's not an experiment, dude.
Yeah, it is. Sure, it is.
Experiments figure out cause and effect relationships of natural phenomena. Right. So a natural phenomenon would be
so if you see the effect of the hold on, can I go? You see the effect.
You said that the observation.
Yeah, we agree. You see the effect, dude. That we're trying to figure out the cause of the effect.
Yeah, so then you figure out the cause, and you figure that it's because of the rotation of the Earth. Or is that not valid because that's like just a random explanation? Because it's a valid way to explain the effect, like the thing that you see can be explained by rotation of the Earth.
The explanation is the cause.
Well, okay, but we need to do the experiment. That's a nice hypothesis. The rotation of the Earth is the cause of the stars moving. Great, nice hypothesis.
Yeah.
Where's the experiment demonstrating that?
I mean, you use a telescope. You'd find the constellation. You'd try and find it again in another time, and
that's the effect. We want to know the cause.
So you're looking at okay. So in the experiment, you have to have the cause first. In the experiment, is that a requirement? You have to have the cause first.
No.
No, you don't have to.
Yeah, so I'm observing natural phenomenon of constellations like switching in and out in the sky.
That's the effect.
That's the observable phenomena. That's the effect. Yeah.
Yeah, then I explain it using a cause, which is the rotation of the Earth. Is that not valid?
No, you don't explain it. You do an experiment.
Yeah, just put it. Listen, bro. Just putting it in words, like you grab a pen and put it on paper, and you say, "This is my explanation why I see the luminaries doing what they do." Right? And you put it on paper. That explanation is not a demonstration, just because you wrote it down or you said it with your mouth.
So there is an alternative explanation to that. There's a celestial sphere that rotates around the Earth. How do you know that that's not it?
Okay, fair enough. Okay, yeah, fair enough.
You see what I'm saying is like when you do this, if you don't do the experiment, then you can have all sorts of alternative hypotheses about what the cause could possibly be. And this is why astronomy isn't a science, because like all they can ever really do are get correlations of phenomenon, but they can never get like cause and effect relationships because they can't do experiments on astronomical objects, right?
Just drop astronomy. Just go for astrobiology.
Astrobiology. The hell is that?
Exobiology, bro. Aliens from dirt in the sky.
I don't think my university offers that.
I'll get you that. Hold on. Let me get that. So someone else talking while I find that link. Unless someone else
I think we
goes.
need to just go for that.
So yeah, we can fill the air with maybe more questions or more comments.
Okay, I have a question, another one. What about these like rockets? Do they really fly somewhere?
Yeah, they go away from your view, most of them.
What about the movie? Like I don't know that they are 25,000. Like this is like the first cosmic speed, and this like 25,000 kilometers per hour. No, sorry, this is like
You see how they show you a cartoon when they say, "Look, it's going 24,000 miles per hour, the rocket or whatever," right? You see how
Yeah, the
you see when
cartoons
you're
are to
looking at that.
explain cartoons are to visualize and to explain to make it easier to digest. They're not
Easier to digest, yeah.
They're not like I forgot. They're not like a ruse or like a mask to hide some sort of.
Yeah, but this is the thing, though. Rockets do work in reality. We do have.
Why do they gotta help us digest it?
Yeah, rockets work.
Because not everyone.
So...
Yeah, we do have rockets, but rockets
because it's
rockets
bullshit, bro. It's literally propaganda. Like,
yeah.
Wait,
okay, they fly somewhere. They fly somewhere, rockets. So, like, where do they fly?
Yeah. Don't they retrieve them in the rocket's graveyard in the Antarctic, in the Atlantic Ocean? Don't they have they retrieve them over there?
Okay, but I don't know. So, but it's like is flying possible? Like flying a plane?
Yeah, the plane requires they have to assume a motionless flat Earth to be able to make the airplane practical and safe to the engineer to get on it and for them to put their families in it and transport them from point A to point B. They have to drop the globe whenever they decide to build the airplane, and then the pilot as well has to do the same thing, basically throw the globe in the trash bin to operate the airplane.
Okay.
You know, the pilot never takes into account any curvature of the ground, any movement of the ground below him.
Okay, I don't know. It maybe makes some sense. Maybe. Do you think it's gonna be like in the future? It's gonna be like I don't know, popular with you? What you
Well, in the
represent?
past, it was popular, right? All of your ancestors, all civilizations across the world knew that the Earth wasn't this globe. It's just today's biggest religion in the world at the moment. Maybe in the future, people will just drop their religion and think about something else. Maybe acknowledge reality for a change.
yeah, and you might think like, what's he saying? It's a religion. It really is a religion. It doesn't have a deity.
No. I understand the thing with religion that this is like the shared belief that people like gather around. Yeah.
Also, it supports a bunch of other ideas, right? That a Big Bang.
Yeah. Okay.
Which is like a creation story, creation of the universe story. Same as like the Lord said, "Let there be light." And then there's like the creation of man, right? That came from evolution, according to them, which came from naturalistic reasons. A man evolved from random processes of this Big Bang random universe. And
wait.
Well, I mean, what I'm saying is that
you also don't believe in evolution?
Why would I?
No, you believe in evolution, yeah?
No, I do not.
Why not?
Yeah, why should I?
But so what do you believe in? Do you believe in creationism, that God created humans?
Yes.
So this is this is your religion. You're Christian, yeah?
Yeah, I'm a Christian, but that's independent than this.
Interesting.
The Bible says, the Bible says prove all things, bro.
Okay, but
I can prove the Earth is flat based upon what I've gone out and done myself.
Okay, are there any flat Earth guys who believe in evolution?
Probably. I don't know.
Okay.
Why do you believe in evolution? I mean, to be honest, you probably couldn't even define what evolution actually is in the first place.
I think I can. So this is the adaptation.
State the theory of evolution. State what it is.
So
Exactly what.
for me, this is the
Not for
not
you.
exactly for.
Oh, not for you. The actual theory of evolution, what it is.
Yeah, the theory, not your theory. The theory.
Okay. So the organisms change to fit the environment, and the organisms that aren't fit, they die, and they change to adapt to the environment to
No, it died. It
pass
stopped right there. You
their
stop. He said they died.
genes. To pass their genes, and they die. Those who are not fit, they die. Yeah.
Okay.
If he died, that's not evolution. Go ahead.
Okay, so let me there's a couple problems with that. Genes code for proteins. They don't code for body morphology, which means body shape and form, right?
Yes.
They know this because of experiments done with these worms that don't die, that cutting them in half and then manipulating them so that the pieces regenerate, right? So these are called flatworms.
Yeah, flatworms. Yeah.
Yeah, so you can cut them in half,
Yeah,
and then
parasite.
so what they stop, Chancy, fucker. Yes, parasites. So what they've done is they've got these worms to basically, by using an electric field, to cut it in half, and the head, instead of the head growing a tail, they get it the head to grow another head. It stays a headworm, right? But it's all genetically identical, but their body morphology has changed permanently. You understand?
That's right.
So, yeah, it's the work of Michael Lewin.
Okay, I understand. I understand.
Yeah. Okay.
Thanks.
So that necessitates that the genetic material does not hold the body plan of organisms. It's something else.
Doesn't it? Okay, something else.
No, it doesn't. It doesn't hold the body plan. The DNA only codes proteins. That's all it does.
Okay.
So there's a big freaking Achilles heel, and then there's the problem of actually making proteins which would actually be useful. The space of proteins is so large, it's something like 10 to the 167 power. The probability of you finding any useful fucking protein in that space is well beyond how old the universe is. The universe would have to be something like a million times older. Okay, so
from what I know, proteins are only on Earth, are they?
Yeah, but there's so many variations of proteins, right? Did you know that the odds of a single protein forming by chance is 10 to the 167 power?
Yeah, I know that this is like a very small chance. 10 to the 100 of 60 what?
167 power.
Okay, power. Okay.
That's impossible. That's not a small chance. That's impossible.
Okay.
If you want a particular protein and said, I'm going to do it by chance, you would wait longer than the age of the universe by that number is like 10 to the 23 power.
But wait, I mean, there's these experiments with the primordial soup. Do you believe in this primordial soup even?
I mean,
no.
Does it got onion?
Because there. No, this is like these amino acids swimming in this like something water or no? In water?
No, it's not possible. What they saying happened isn't possible. Do you understand? Probabilistically,
yeah,
not
I understand.
Well, I mean, there's an open challenge. It's just an open challenge.
Therefore, there is a God. Therefore, there is a God.
No, I believe in God for completely different reasons than this.
Oh, okay.
My argument for God would be a logical argument that has nothing to do with evolution, or I don't have a naturalistic justification for God.
Okay, I think I consider myself like a thinker, like independent thinker, kind of. I would say so because I kind of think and I try different ideas, like your idea. I tried it for a moment.
I don't have an idea. What is my idea exactly? My idea is I go out into the world. It looks flat because it is flat. That isn't much of a stretch of imagination. In fact, that involves no imagination.
Yeah. It involves it's like simple observation. Yeah, okay.
Yeah, and just take it for what it is and like stop adding shit to it. And other people have said that observation that we all see, everybody has seen, that's got eyes. They've told people, there's people that say that's an illusion, that you're just too small. That's actually a big ball, and you're just too small. You can't see it. You have to go to a special place, but you can't go there because you don't have the right stuff. Only these anointed people can go there and see the ball in its full glory, but not you. Everybody else.
So,
and then they also say, also hold on. They also say the Earth is spinning. You see the sun and stars move, but that they're not moving. You're moving. They're basically telling you that your entire perception of reality is some sort of illusion.
It's nonsensical. Your perception of reality is nonsensical because your senses are telling you something else, but reality is something else than what your senses tell you.
Yeah, I agree, but
reality is
from what
nonsense,
I know,
bro.
From what I know, these theories are supposed to enhance your senses in a way. That this is something I don't know, by just scientific microscope and telescope.
Yeah, but no one's ever used a telescope to look at the Earth and see if it's a ball, and seeing that it is a ball. Not with a telescope, that's for sure.
Actually, when you use the telescope and you look at long distance observations, you see that it's not a globe. If you see far enough, right?
So would you maybe
Look, bro, we're not trying to listen. Let's just go. We're not trying to convince you of anything. There's no way we're ever going to convince you. We're not that good where we're going to overcome, basically the indoctrination and you've grown up in Western society and you've been bombarded with this idea. We aren't going to overcome that because it's regardless of what you think, it's integrated into your identity, and that's how it is with most people. Yeah,
Okay.
so we aren't going to defeat that. The only thing that will ever defeat that will be you testing it yourself. That's the only way. That's the only way. It's not the only way. That usually the other way is having some crazy anti-flat earther try to defend the globe and see how shit their arguments are. That turns people into flat earthers. But the only way to really prove something to somebody.
To the clinic where they send where the rich people goes and they do the brainwashing. Yeah, we can send you there too. Probably that might work. Just kidding. Go ahead.
Yeah, we could do that.
So why?
Oh, hold on. I was going to make one more point. Okay. The only way to prove something to somebody is to demonstrate it, right? Because if you get them and you say, "Hey, if I do this, this will happen," and then you actually do that, that's proving it. That's proving it in a way that's undeniable. So what I'm telling you is, if you want to prove what the Earth is, you have to demonstrate it. It's not here on the internet. It's not in a book. It's out there in the world. You have to actually go test it.
So what about other
That's actually the difficult part for a lot of people to go test it. That's where a lot of people just don't go and do it. Like going to Revere when it's 45 degrees and doing observations for an hour or so. A lot of people cannot do that. I mean, they're too lazy.
Okay, what about other I'm asking you some other question, not about. Can you answer me other scientific questions? Hello.
Yes, you can ask another question.
Okay, electricity. So it works, yeah.
Electricity works?
Yeah.
I thought it was unemployed.
What unemployed?
Just kidding. Go ahead.
What works? What was that? I missed it.
Electricity, he said.
Yeah.
Yeah. I mean, I can switch the light bulb on and it lights.
Okay.
So I have electricity, and that's great phenomenon. So it works.
Okay. Is there more to this?
Yeah, there's some scientific theories about that, and the other way, it's about like the Earth is round. And
see, now this is a good example. This is you brought up the perfect subject matter: electricity and magnetism. Now, it was experimented with for quite a long time, and a guy named James Clerk Maxwell came around, and he made a theory of of electricity and magnetism. And he used something called the model he made, the mathematical model he made was used the ether. I don't know if you ever heard of the ether theory. He used this mechanical model to make the model of electricity and magnetism. Okay, but nowadays nobody believes in the ether, and they say the ether doesn't exist. So we're literally using a model based upon something that they say doesn't exist is actually real. Now, the lesson in all this is that mathematical models, even though they quote unquote work, don't always define what reality is. And this also leads to my second point about this, is that when they tried to use Maxwell's equations, now it was great in the lab, but it sucked when you came to trying to engineer the electrical system, right? And they couldn't really get it to work. You had burnouts and frickin' all sorts of problems trying to actually engineer electrical power transmission. And then other people came along, such as Tesla, who actually made what we use now for the alternating current. He freaking invented it, and he didn't use any of Maxwell's stuff. He was purely an experimenter, an engineer, right? And then you had Steinmetz, who was like an engineer who came up with all the formulas for actually electric power transmission and power lines, right? So it wasn't the scientists that figured out how to make it work in the physical world. It was the engineers. And the scientists, at least back then, they used a method the scientists themselves say doesn't even exist. So it is a good example. Yes, electricity works, but it isn't the scientists that make it work, it's the engineers. Because they don't care about why it works. They only care about does it work. You understand? The theory of why everything's happening, they don't care about the causal mechanisms or anything like that. They're going to use whatever mathematics they use to suit their purpose, even if there's no ultimate reality there and it's a completely fictitious mathematical construct. They don't care about that. They have an employer. Their employer says make it fucking work, and that's all they care about. And the reason their employer says make it work because you say make it work, right? My electricity's out.
I want electricity. I want electricity in my house.
Yeah. I'm trying to cook. I'm trying to heat my house. I'm trying to look at porn, and my computer won't work. So turn that shit on.
I try to whatever cook. Run my computer. Or something. Okay.
Yeah. Computers are without electricity are nothing but a giant paperweight.
Yeah, that's very interesting.
Yeah, the story of electricity and magnetism is very interesting. There's a guy on YouTube. His name is Eric Dollard. There's a presentation he gave called "The History of Electricity and Magnetism." It's really good. He's not even a professor, man, but he goes through the history from the beginning of from Benjamin Franklin to Gauss to like all the people, all the original people, and how electricity and magnetism, its understanding of what it is and how to use it, developed over time. Is very educational. It's really like everybody that's like pushed the field to ends up going a little crazy, which is also kind of weird.
Yeah. Do another question, like different. So, would you consider your like views to be like kind of obscure or like dangerous? Like
dangerous?
Would you consider? I don't know if I say this at my work. The Earth is flat.
Like, my views are not dangerous unless like look.
Yeah, I don't know. It's dangerous.
Just personally, my view is not dangerous because I don't give a shit what the government does. I don't give a shit if they fucking make fake space programs. I'm not going to protest them. It's their gig. Let them do it. I don't care if everybody follows it. I'm just here giving information. Hey, they're saying it's this. You go out into the real world, it's not that. It's this other thing, and that's all I'm telling y'all. Like, I mean, and you can take it or leave it, do what you want with it, but you can't say you didn't know because now at least you know. I mean, listen. I grew up in the '80s when the space shuttle first, flew. And I know all the bullshit that they were telling us back then is the same bullshit that we're going to the moon, we're going to go again. All this stuff, it's to me, it's just nonsense. They've been just saying forever. Like, I mean, we were actually talking about this in here last night. How long is it going to be when people because they keep saying, so they keep saying like, hey, we're going to go back to the moon. We're going to go back to the moon. How many more years of not going back to the moon before people start being suspicious?
Right? I mean, it's
another
already
80?
Suspicious. Yeah, I agree.
I know. But I mean,
I agree that it's suspicious. I agree that it is suspicious because there was only like one successful moon landing, and it was in the 70s. Yeah, it was in the 70s.
Yeah. What I'm saying is,
so it is suspicious that it's been like 50 years and the technology has improved. I mean, computers have improved, and they have this. Like,
actually, the only technology that has gone backwards is space technology. Moon landing technology has been going backwards compared to everything else.
Yeah, they can't even make space.
Okay. I honestly believe that moon landing could be fake. Because I've seen a lot of like analysis on YouTube that prove that it is a fake. Yeah, and I was more convinced that it is fake, this moon landing. So I believe in this for sure. That it
You
was
were
fake.
fighting me earlier, but that's good that you kind of like.
Hold on. But
Go ahead,
I really want to. I'm talking about the whole space thing. I was just using a moon landing as an example. They've also said there's going to be space tourism, and like just like random people can just like buy a ticket to space. When none of this stuff happens, like, is it going to be like 50 years from now, 100 years from now, 200 years from now? Like, hold on, dude. It's been 200 years. You're still not doing space tourism. Like, you must be lying. Like, how long is it going to take before the normal people go, these guys must be lying? Mute up, buddy.
Okay. Yeah. I know. That's like very interesting what you're saying. Okay, so that may be a lie, but apart from this, do you have any other like beliefs that are counter, like that counter what generally people believe in like this? Do you have any other beliefs like this?
I mean, I don't know how many people believe the freaking official 9/11 conspiracy. Do you believe in the official 9/11 conspiracy theory?
What do you think happened in 9/11? Let's hear it.
Do you believe in an official one? The official conspiracy?
The official conspiracy or the official story?
The official story is a conspiracy.
I mean, I honestly, Loki, I think it might have been Israel, honestly. At this point,
I mean, you just got to admit, though, the official story is a conspiracy theory.
Or the Al Qaeda one, like the terrorism one.
Well, yeah, a conspiracy of 19 hijackers, right?
Okay, yeah. I mean,
it's a conspiracy of 19 hijackers, brother.
I just don't know what to believe anymore.
Well, all I'm saying is, even the official story is a conspiracy theory. So when they say 9/11 conspiracy theory, they're talking about any theory. Because no one thinks one person did it, right? Because your thing is conspiracy or solo. Nobody thinks 9/11 was a solo job, like the lone gunman on the grassy knoll. No one thinks there was a lone pilot. Okay, so there's no lone pilot. It's a conspiracy theory. We're just quibbling about what the conspiracy actually was.
So yeah, what do you think happened?
I look. I know what didn't happen.
Okay.
Because it's really simple, just from the laws of physics. In like simple things, dudes demonstrate there was not planes smashing into that building and frickin' exploding. That could not have possibly been happened.
I've never known a building to fall down. Sorry, Indio. I've never known a building to fall down because the ones next to it apparently got hit by planes. That doesn't happen.
Yeah, that is. I'm sick. That is awful. Awfully suspect.
I'm lonely and just committed suicide. Did Building 7 get lonely and commit suicide, bro?
What's the official explanation for why Building 7 fell?
Fire. External damage.
Good lord. That's
Fire.
the official story.
But it's telling the same way that the other two did. All right.
Interesting thing about those buildings that have fallen down is that event, fires knocking down concrete, steel girder buildings, has only happened 3 times in history. And you wouldn't believe it, all 3 of them happened within a very short amount of time.
Yeah. You asked Indio if he believed in any other conspiracy theories, right? The whole world is a conspiracy theory, dude. Everything.
I didn't, by the way. It was the other guy.
Oh, sorry.
Yeah, it was me. It was me.
He had other ideas, to be honest. He didn't say conspiracy theory specifically. But
yeah, because I've just said like other ideas that are non like that you ask someone on the street and he tells you, no, it's not what I believe in, or he tells you that, bro, it's like not even true or something.
Yeah, so I don't like that you're like sticking flat Earth in that. I told you. We just observed the Earth is flat, and
I told you that it's my first time. This
yeah. I know. Like this is a common thing where people think that we have like some belief, but because they never really thought about it, like why did everybody in the past think the Earth was flat? Oh, because that's what they saw. Well, I see the same thing they saw. Okay, the only difference between them and me is I got a bunch of people around me thinking the Earth is a ball. That's the only difference.
Yeah, when it comes to this,
in movies, in picture books, and that's the only difference. But like, I just observed the Earth the way it is, and like I said before, there's people that say, "Hey, you can't just naively look at the Earth and go, hey, it looks flat, therefore it is flat." We have looked into the sky with our telescopes, and we figured out that though it looks flat, we're actually on a giant ball. That's fucking idiotic. I'm just sorry to get like upset about it. It's just dumb.
That's fun. It's kind of funny.
Well, that's the thing. I mean, we've been debating this topic for like 10 years. It always comes down to like, oh, you flat Earth, to buy a telescope. Okay, I bought a telescope. Now what? Can you see the moon?
Yeah, that is actually the number one. In 10 years, it will be the number one. The number one evidence of the globe is looking away from the Earth. Earth is a globe when you look away from it. Like you gotta look in the TV, not to the Earth. Just don't look at the Earth. Look at something else. That's the best.
Yeah, because it's weird because like you're internal on the Earth. So how are you gonna like judge the object when you're on the object? You have to look at the object's effect on other things, which is, for example, the moon. Like the moon, the Earth, the spherical Earth has an effect on the shadow of the moon.
No,
which is why.
No. Even if you're going to say that the Earth is like the moon, you still have to prove that the Earth is like the moon. You can't just say that the Earth is like the moon because the moon exists.
I meant like you have to look at the objects. You have to look if you're on the object.
How do you know Earth is an object in the first place?
You look at the Earth, don't you? If you want to know what the Earth is, you definitely look at the thing you want to know about.
Because I can touch it, that's why.
Yeah, cool. So we look at the Earth to figure out what the Earth is. We can look at the moon to maybe figure out what the moon is.
Okay, but another valid way of looking at it is to look at the moon and see spherical shadows. That's one of the, I think, one of the simplest observations of why.
So the moon's flat then.
The moon's flat? What? No.
Yeah, because if you're going to have perfect shadows created by objects and you get the true representation of that object, let's say a sphere, it's going to have a perfectly rounded shadow. You're only going to cast that shadow on a flat surface. If the surface is distorted like a sphere, then so will the shadow be. So for your example to work, the moon must be flat.
We gotta.
Ever created shadow puppets before?
I have. They're fun.
Cool. Try and do that on a distorted surface and note how your shadow is distorted by consequence of the surface.
You know, eclipses make the moon turn red. How do you know that's a shadow? Shadows aren't red.
I don't know how eclipses work, or that the blood moon. I don't know how the blood moon works.
Yeah, but you, you need to think. You need to think about your shadow example.
Is the moon the only
you need a flat moon for that, dude.
I don't think the GIF on shadows is fair because we're looking at the moon substitute at an angle, which would make the shadow look not proper.
What? It's a curved surface. It's a sphere.
Like,
As the shadow passes over that curved surface.
I can see a curved. I can see a curved shadow on the moon.
Talk through me because he's getting upset about his moon shadow.
Oh wait, my bad. I was talking to you. That's my bad.
That's fine. As I was saying, as the shadow passes over the curved surface, you'll notice how it continually distorts. I.e., you can't have a true representation of a object shadow on a curved surface. It won't be a true representation because the surface will distort it, right?
Not so insanely that you wouldn't be able to not so insanely. There could be a slight distortion, but it wouldn't be like an insane.
Dude, it's really. I ask you to go and do this. Go and get a flashlight and some balls. See what shadows you create.
Okay,
what you will create, I'll give it away for you. As you make the shadow move across the object, you'll create what's known as a sine wave. That looks like an S. As the Earth an S.
Okay, I see.
That was kind of rude, Jed. I asked him the guy to get some balls. Come on, bro.
I see.
So we can tell you the reason it makes an S is because what'll happen is the shadow, the edge of the shadow will cross the center of the sphere, right? The center, like say the dividing line of which way the shadow is being projected, and one side of that curves one way down, and the other side of it curves the other way down.
So
as the shadow crosses this, its orientation of the curve changes. It'll look like an S, basically.
Okay. Word salad objections. Blue Jumper, how about you mic up, and how about you try and review or talk?
Mic up, like better microphone, you mean?
No, mic up as in get on the mic, bro. Start talking.
Yeah.
Instead of typing.
He's getting upset.
Instead of going clack 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 on your keyboard, go talk on the mic.
Well, listen, he's allowed to type. Just mute yourself so we don't hear the background noise, and that's it. You're allowed to type whatever you're gonna type, and then speak to us in the VC if you want. It's okay.
Never mind. Okay. Okay, I see the GIFs provided.
It's just something that you can try and recreate yourself.
I have. What is this trying to show? What is that one trying to show? The top.
What straight lines can be distorted by curved surfaces when they cast a shadow on them.
The mostly black one.
What do you think that's trying to represent, dude?
Have a look at the shadow
you can
on the little
concede,
white ball in the background.
My bad. But what they told you, you can concede that seeing this phenomena of the moon being opaque, that doesn't prove the globe. You can concede that, though. The point that he's giving you that if it was a sphere, you wouldn't see this round shadow like you're saying. What do you think about that? That was a direct reply to you saying we see a shadow on the moon that looks round, therefore the Earth is round.
Yeah.
Why isn't like flat Earth popular?
Wait. We still hold that question.
Okay.
Let the other guy reply to what Jada told him about what will happen on the surface, depending on the surface orientation, if it was flat or a sphere. What do you say about that? What will happen to the shadow?
Pretty much. I actually can't think of anything to say because I think I'm getting tired. It's like 10:15.
Quarter to 10.
You're gonna go to sleep? Go ahead.
To be fair, this topic.
It's Friday.
My bedtime's in like an hour.
Okay, so this topic is very thick. It covers like actually a lot of different things. It covers history, sociology, psychology, science, measurement. It covers parasites, brain worms. It covers it covers a lot of things. So it will mentally exhaust you in the beginning because a lot of these things they're hard. They're not hard to comprehend. They are in a way, especially when you're just talking about it. If we had like whiteboards and diagrams, it'd be easier to show you. But don't feel bad. It is mentally exhausting to deal with this topic. We're just used to it. So I mean,
me it's hard because you guys are throwing out literally everything I've been taught.
Yeah, me too.
Yeah, I mean, you've been taught the wrong thing. I mean, the people. To be fair, the people that taught you, they didn't know either.
Yeah, probably.
Yeah.
They got the textbook. They said, teach the kids this. And they're like, okay, just give me money.
They weren't even given enough money. Have you seen teacher salaries?
Oh, yeah.
It's a living.
Have you seen teachers?
Yeah.
Have you seen teachers?
It's a living. It pays bills. People just go to it as a job of work. People like this
honestly,
think they're benefiting the community.
I am a teacher, by the way.
And of course. So you think that you're benefiting your community, educating the younger and next generation, right?
I'm educating them about English. I don't have anything in common with science.
Whatever the subject, it's beneficial. You have some kind of pride in your work, I would hope. I would hope some teachers at least do. Right? There's no
I mean, I do like I teach them like necessary stuff, like how to speak English, how to write English. That's it.
Yeah, that's fine.
In a public school, or just like?
Yeah, in a public school.
Yeah. Can you just teach them whatever you want?
No, I have like a textbook, and there's like present simple, present continuous, past simple, past continuous.
Now, it's like say you open the textbook one day and it said, "Teach the kids the Earth is a globe." Would you do that?
No, I wouldn't. But they don't tell me to do this.
Yeah, look, you're an English teacher, of course not. But the science teachers or the other classes, they're told, teach the kids the Earth is a globe, and they just do that. They don't know that. They don't fact check the textbook and say, I refuse to teach this. The textbook's wrong. They don't do that, right? So, like they just believe it. Everybody believes it. It's just like a collective thing, like believing in Santa Claus or something. Everyone just believes it because they think everybody else believes it.
Okay, cool.
But we have a flat earther. She's a teacher. She's a school teacher, Dandelion. She's not in here right now, but like, if you come back, maybe you'll be able to talk to her, and you guys can like compare notes of teaching brats.
What do you think there are any like teachers? Sorry, you go ahead.
No, I just want to. What age do you teach?
Primary school, so like young learners. I mean, age, yeah. So specifically like 9, 10, 11, 12, 13, 14. 13 okay, 13, up to 13.
Oh yeah, that's pretty awesome. You get to teach them English. That's freaking great. I wish.
Primary school, 13.
Yeah, in my
Primary schools.
country.
Oh, okay,
in my
okay.
country, up to 14, there's the primary school.
Okay, that's cool. What country?
Poland. I live in Poland.
Okay.
There was the change in education, and they made the primary school longer, and they deleted the middle school.
Interesting. Okay.
That's funny because where I live, they added a middle school about 3 years ago.
Oh wow.
Yeah, I know. The reforms, they are just politically connected. They have nothing with education. They are just the new government has to change something to prove something. Yeah.
You got it. That's exactly what they did here. New mayor. Oh, I'm doing something. We're gonna make a middle school. Not knowing, right, that there used to be middle schools here where I live, 40 years ago, and then they got rid of them. And 40 years later, they just went back. Make up your goddamn mind.
Yeah, in Poland it was like this, that they first have introduced middle school, then they deleted them, then again middle school, and now they deleted them.
I think that's weird that you're in a foreign country and that's the exact same thing they did here.
Where are you from?
Maybe we just keep. I'm in Cambridge, Massachusetts. In Boston, in America.
Ah, okay.
Where Boston is. I'm sure you heard of Boston.
Yeah, I heard of Boston Tea, yeah? That they sank the ship with...
Have you heard of Harvard? Have you heard of Harvard University?
Yeah, I know. That's one of the best universities.
Yeah, that's where I'm at. In Cambridge.
Okay.
So all the Harvard kids are right down the street being idiots because they're dumb as... Don't ever let anybody convince you that Harvard kids are smart. They're as fucking dumb as rocks, bro.
But Mark Zuckerberg is Harvard student from...
No, he quit Harvard because he was smart.
Okay.
Or did he get kicked out? I don't know. He either got kicked out or he quit.
Yeah, quit Harvard.
She quit. I think there are other smart kids from Harvard, billionaires. There's one other billionaire from
Harvard is kind of like a place